What's up everyone, welcome to this Python course. Now this course has taken me a lot of time to make and I really appreciate the fact that you've clicked on this video. So to support the channel, please leave a like and don't forget to subscribe if you're new. Without further ado, let us get started. Hi everyone, welcome to this Python course. In this course, I'll teach you the basics of the Python programming language. Python is a widely used programming language used in fields such as data science, machine learning, and it's also used in web development. Using Python, you can automate very many boring, repetitive tasks. So allow me to hold your hand and walk you through the basics of the Python programming language. Without further ado, let us get started by learning most of the ways we can install and get running with Python. For us to get started with Python on our Windows machines, the first thing we shall have to do is to download and install Python. So we're going to head over to our official website of Python, which is python.org. And on this website, we are going to go to the download section. Under the download section, we are going to download the latest version of Python. At the time of recording this video, the latest version of Python is Python version 3.11.1. So I'm going to head over to the download button right here and click download. This is going to go ahead and download my Python to my machine. So after downloading Python, I'm going to click on open. And this will go ahead and open up our Python application. So once we've opened up this window, we have a lot of options right here. So we have the option for installing now. We also have that one for customizing our installation. Now this button for customizing our installation is going to allow us to be able to add more features onto our Python installation. So we're going to skip this for now. One important option that we need here is the one for adding Python to path, and this is going to allow us to run Python within our command line. So I'll go ahead and tick this and then click on install now. So this will go ahead and install Python on our machine. Now that our Python has been installed, the next thing we're going to do is to verify if our Python installation has worked successfully. So to do that, I'm going to open up a command line window. So on Windows, it's going to be the command prompt, which is cmd. So I'll go ahead and look for cmd. So on this command prompt, I'm going to verify our Python installation by typing. So I have to enlarge this a little bit so that you guys see. I'm going to check if our version has been installed by saying python --version. And this will show us that we have a version of Python that has been installed, and that is version 3.11.1. On Linux, chances are high that you have a version of Python installed, and this is because very many system programs rely on Python to run. Now, to verify if you have a version of Python installed on your Linux machine, go to the terminal, just like the one I have here, which is a bash terminal, and type Python or Python 3 --version. When you do that, you'll now find out that you have a version of Python installed on your machine. And this machine has version 3.10.6, which is okay for this video. Another way we can run Python without having to make an installation is by using Replit. So Replit is this tool that allows us to code in various programming languages without having to set up installations on our machines. So I'm going to go to replit.com, and after visiting Replit, I'm going to log in into my account. So you'll have to sign up for a free account. I'm going to log in with Google, and then I'll choose the account I want to use to log in. So this will help me to log in into my Replit account. So once I'm here, this will redirect me to the home page. we'll be able to create a new Replit. So think of a Replit as this environment in which you can code for a specific programming language. For you to create a Replit, you have to go to My Replits, and then you click the Create button. So right here, I'm going to search for a template. So just like you see here, we have various templates for Python, HTML, C++, Node.js, and so on. Now the one that I want to use is the one for Python. Now I'm just going to come and click on the one for Python. I'm going to choose a title for it. I'm going to name this Python course. And once I'm done with this, let me fix the spelling here. I'm just going to click on Create Replit, and this will go ahead and create for us the Replit that we need. So this is going to create for us an environment that has Python 3 already installed. We shall have a simple editor right here, and then we shall have a very simple console right here. So this is just enough for us to be able to learn Python programming. Now that we've installed Python, we are going to need a text editor that's going to allow us to write our Python code. So I'm going to choose Visual Studio Code out of the various text editors out there because it has a lot of extensions that can allow us to code in the Python programming language. And another thing is it is so widely used that if you get a problem using it, it won't be hard for you to get answers online. So the first thing I'm going to do is to head over to the official website, which is code.visualstudio.com, and I'll download the Visual Studio Code for our operating system. So I'm currently on Windows. I'll go ahead and download the one for Windows. So this will start up a download on my machine. So after the download, the next thing I'm going to do is to go ahead and click on these options. I'll go ahead and open our Visual Studio Code. So this is going to open up our installer. I'm going to pull up the window right here, and here is where we shall have to first of all agree with this agreement. So I'll accept the agreement and click on next, and then this is going to select the folder in which we're going to install our Visual Studio Code. So I'm going to click next. So we also have a folder in which our shortcuts will be, which is going to be Visual Studio Code. I'll just go ahead and click next. I'll click next and next. So this will go ahead and install Visual Studio Code on our machine. So now that our VS Code has been installed, let's go ahead and launch it. So I'm going to click on Finish, and this will open up a new Visual Studio Code window. So for us to get started with programming in Python with VS Code, we shall need some VS Code extensions that will give us the ability to write Python. So to do that, I'll go right here on the Extensions tab, and then I'll look for the Python extension. So I'll go to Search Extensions and I'll type in Python, and this is going to return the official extension by VS Code or by Microsoft. So I'll just go ahead and select this extension right here. So the Python extension is one that will allow us to write Python, debug Python, and do very many things for the Python programming language. This is actually the official Python extension for VS Code. So I'll click on Install. So this is telling me to download it manually. I'll go ahead and download it manually. So this will take us to the VS Code Marketplace, and we shall install the extension by downloading it just like you see here. So to go ahead, download the extension, put it on our machine, and then we shall be able to install it in our VS Code. So I'm going to close this. So I'll just say open, and then I'll basically open this in the folder it is in. So that will basically launch. Let me try to locate where it is. So I'll go to my downloads, and within my downloads you see that our extension has been downloaded here. So for us to install this extension from the VSIX file, what I'll have to do is to go to our Visual Studio Code, and then I'll go to the extensions panel just like you see here. So in the extensions panel, I'll have to click on these three dots, which are more actions, and then I'll say install from Vscode. So when I click on that, I'll go where I downloaded that extension, and then I'll go ahead and install the extension just like that. So that will be able to add our extension to our VS Code just like that. This process should be simple for you, and it is just been a little bit difficult for me, but as long as you click install, it should go ahead and download as well as install VS Code for you on your machine. Now that our VS Code extension has been installed, let's go ahead and try to create our first Python program. To create our first program, we're going to first of all open up a folder. So I'm going to go to our menu right here, and I'll go to File, and in here we have a variety of options, but the one for opening up a folder is going to be the one for Open Folder. So I'll click on Open Folder, and then this will point to any location on my file system. So I'm going to go to where I want to create our folder. I'll go to our Documents, and inside Documents, I'm going to click on any random place and say New Folder. Then inside here, I'll create this and call it the Python course folder. So right after creating this Python course folder, there is already a file named Python course, so I have to create it somewhere, or what I'll do is to actually rename it to, let's say, Python basics. So once I've done this, I'll go ahead and select that folder and then be able to open it up in Visual Studio Code. So after creating this folder and opening it up in VS Code, the next thing we shall have to do is to go ahead and create a Python module. So a Python module is a file that contains source code written in the Python programming language. So we are going to do that by coming right here and then right-clicking on any point within this space and then saying New File, and then giving the name of our new file. Now in this case, I'm going to name this file main. So since this is a Python module, it will have to end in the .py extension. So I'm going to come here and say .py. And once we've created this file, then the next thing we'll do is to write some simple Python code. So what I'm going to do is to write the simple normal hello world message. So I'll just come and say print and then say hello world. And because we have some awesome auto-completion right here, thanks to the Visual Studio Code Python extension, we now see that each time we try to write some valid Python code, we shall be able to have some auto-completion to help us get this done. So I'm going to save. The next thing is going to be to run our file. So for us to run our file, we shall have to use a console or a terminal or a command line of some sort. So to open up our command line, I'm going to come right here on our menu and then go to terminal, and then I'll say new terminal. So you can also use the keyboard shortcut that's provided for you here, which is Ctrl Shift and then tilde, or you can actually use Ctrl and then tilde. That will allow you to be able to open up your terminal without having to write this long keyboard shortcut. So once you've done that, now your terminal is going to open up right here. So I'm using git bash, but feel free to use any other command prompt you may want. So other options are actually command prompt, JavaScript debug terminal, git bash, and so on, but I'm going to choose the one for git bash. And once I've done that, I'll just come right in here. So the command is going to be Python, which is going to invoke our Python interpreter, and then the name of the module in which we've written our Python source code. So I'll do that by saying main.py, and this will go ahead and print hello world to our console. So we have successfully run our first Python program. Now that we've run our first Python program, let us understand the concept of variables. Variables give us a way for us to store values. So in this example right here, what we have done is to go ahead and print a value to our output. And that value is our hello world string, just like you see here. Now I'm going to be talking about strings later on in the video. So if we want to store this in some kind of container that can allow us to access it, then that's when we are going to create a variable. So think of a variable as just a name that will help us to be able to understand a certain value and also access it whenever I want to use it within our program. So let's go ahead and create our first variable. Now I'm going to remove our value of hello world right here, and then go at the top of our code, and then I'll create a message. So the message is going to be our name. So I'm going to use the assignment operator and then give the value of hello world. So what is going to happen here is each time we want to use our value of hello world, we'll refer to the message variable or the message name to access our value. Now let's say I wanted to print hello world to the console. In this case, what we'll have to do is to go ahead and print our message. So when you run our file once again, what we're going to get is hello world. Another thing we may want to know is we can assign these values of a certain variable to other variables. Now let's say I wanted to create another variable called word. So let's create a variable called word. We can still set it to have the value of hello world, but this is like repeating ourselves. So what we can do in this case is to just go ahead and just put in the variable of message. So what this will do is to actually give this word variable a value of our message, which is hello world. If we go ahead and save and then try to access our word, so we can say print. So in this case, we can use our print statement to print multiple strings. So we can just come and say the word is, and then inside here we can say comma, and then we say word. So this will basically allow us to access our word variable, just like you see here. If we run our program right here, we can now see that the word is hello world, meaning that our message is still having the same value as our word variable that we have just created. So another thing we can do is to create other variables using other data types. Now we're going to look at these data types later on in the video. So let's create a variable called age, and let's assign to this a value of 23. So the way we do that is by writing the name, just like you see here on the left side, and then using our assignment operator, just like we've done for the previous examples, and then giving the value, and in this case our value is going to be the number 23. So if we wanted to access this number 23, all we have to do is to use the name of our variable that we've created, which is our age. So I'll just come right here and say print, and then we can now say that the age is going to be age, and this will be equal to our 23. So in this case, we shall just say 23. So let me leave a little space here, and then when we run our program once again, we shall now see that our age is 23. So just like you see here, variables allow you to be able to access your value from wherever you want to access it within your program. But it's not just that. There's quite a lot that actually happens whenever you create a variable, and let me start explaining that right now. So each time we create a value, just like you see this value of hello world, and we assign it to a name, which is our variable name here called our message, what happens is we are referring to an object that has a certain type. And for us to find out this type, we'll have to use the type function that's inbuilt within Python. So for us to be able to do this, what I'm going to do is to come to the next line, and then on our next line, what I have to do is to go ahead and print the type of each of the variables that we've created. So in this case, I'll just come and say print, and then I'll say type, and then I provide an object. So the type function will take in an object of whatever data type. We shall look at these data types as we go on. But let's say we provide our object, and in this case, our object is going to be our message. So I'm going to save this, and when I save, I'm going to clear my terminal with Ctrl and L, and then go ahead and run. And this is going to return for us the class of string, basically meaning that our object or our variable is of a type which is a string type. Let us also go ahead and do the same thing for our age. So I'm going to come at the top right here, or actually down below right here, and then print type. And in this case, I'll provide our variable for our age. So I'll just come and say that we're going to have our age. Now that we've provided our age, I'll pull up the terminal once again. And what I'll do is to run python main.py, and this is going to go ahead and print our integer, meaning that our age variable we've created right here is an integer. So just beyond creating objects and then finding out the types of those objects, we can also be able to identify these objects. So think of an object as a unique entity or a unique object, or an object that has a unique identifier that basically points to where it is in memory. So each time you create a variable, you're basically placing a certain value in memory at a certain memory location. So for us to be able to find out that memory location, we are going to use the id function, which is inbuilt within Python, that's going to actually allow us to be able to find out where these variables are. So to do that, we're going to just come right here. So I'm going to print, and in this case, I'll say id, and in this case, I'll provide our first variable, which is going to be our message, and then I'll do the same thing for our age. So I'll say print, and this is going to be the id of our age. Now I want you to notice what is going to happen here. If we pull up our terminal and then run this file, what we're going to do is, what we're going to get are different values, and these values are going to point to the memory address or the location of our variable in our computer's memory. Now, you know this can be confusing, but what an ID is, it's just a unique identifier that identifies a variable within the lifetime of our program. Now that we've been able to understand that, let us also look at how we can be able to name these variables. For now, we have been just using one word. Sorry for this. So just going to close this and then go back to our file. So what we've been doing is to just use one word to name our variables. So now let's say we created a variable that's verbose enough to contain multiple words. So there are very many ways to name these variables, and this is how we name them. So let's say we are creating a variable, and this variable is going to have the number of days in the week. So we can create that as number of days in week, and we can give this a value of 7. We can also create it in this way. So we can come and say number of days, and we can give this a value of 7. We can also give this a name that is number of days, and this will still be 7. So in this case, what we've done is to show different ways in which we name the variables. For the first one, we use underscores to separate the various words that this variable has. And the variable being more verbose, just like you see here, is very helpful because the moment you see the variable, you'll have an idea about what the variable does in your program. So in most cases, it is important that we write descriptive variable names so that we save those who are going to work with our code later. And it also helps us to basically understand the flow of our entire program. So the first one is what we call camel case. The second one is what we call, the first one is what we call snake case, sorry for that. And the second one is what we call camel case. Now for the first one, we call this Pascal case. So camel case is where we use a combination of lowercase and uppercase letters, basically starting with the lowercase, and then with the other word we use a capital letter or an uppercase letter, and so on. For the Pascal case, what we do is to start each of our words with a capital letter, just like you see here. There are also multiple rules that help you name variables, and I'm going to basically mention some of those. When creating a variable, you have to use any alphabetical letter. You can choose any alphabetical letter to create a variable. You can also choose a number, but this does not have to be at the beginning of the name of the variable. So let us try to create some variables to show this. So what I'm going to do is to create a variable called number3. So I'm just going to say this is going to be our number3, and it is going to have a value of 2. So number3 is going to have a value of 2. It's a very valid Python name. So we can also go ahead and create number and then underscore 3. This will still be a good variable name. So these are going to be different variables, but in a different way. And we can also have something like number 3. This will also be an okay name to use within our program. However, what will not be okay for us to use is 3 number. This is because it starts with a number. Now, thanks to the Python interpreter, we can be able to see that this is going to give us an error. It goes ahead and links it and basically provides for us this red squiggly line to show us that we have an error within our program. So let me remove that. Another thing we may have when creating variables is there's a set of words that we are not allowed to use, and these are the keywords that come within the Python programming language. So I'm going to leave a list of those so that you can be able to see all of them. One of the ways you can tell other programmers or yourself in the future about what your code does is by using comments. So a comment basically explains what a certain line of code does. Now, another thing a comment can do is to allow you to eliminate some of the code that you do not want to learn. So let us go ahead and create our first comment. In Python, it is very easy to create comments. So to create a comment, all you have to do is to go to where you want to create that comment and then place your cursor there. You create this hashtag right there and then write whatever you want to be your comment. So you can choose to name this our first comment, and that will be a line of code that will not run. Comments can be used to explain what code does. They can also be able to explain multiple things. So for example, in here, we can choose to basically comment and add some comment here, like let's say assign variable a value of another. So just like that, we've created a variable that's its own line. We can also go ahead and create a comment, and this comment can be on a line that has a variable, just like you see here. So we can now just write hash, and this can be our, so this can be our first number. And then you can also go ahead and comment out a line, for example, print message. So you can just go ahead and basically put a hash symbol or a hashtag just before that print statement. And this will be eliminating that line. You won't be able to run it. So basically, that's how comments work. Another way that you may want to comment your code is by basically placing your cursor at any point where you want to comment, and then you can select what you want to comment. On Windows, you can press your Control and question mark, and that will go ahead and comment out your code. So this is a multi-line comment, and what it does is to just eliminate 2 lines of code by basically putting a hash symbol at the beginning of each of the lines. So that's what comments are. When creating values in Python, you are going to be creating them in various data types. So a data type allows us to know which kind of variable we are creating. The first data type we're going to look at is the string data type. And the string data type is one that allows us to express text or be able to organize text in a certain way. So let's say we had textual data such as your name or my name. We may express that in terms of a string. So let us create our first string. I'm going to go within our main.py module in here, and all I have to do is to say that we're going to have our name, which is going to be our variable name, and that will have a value. So the value inside here is going to be the name. So in this case, I'm going to provide my name, which is going to be Sally Jonathan. And once that is happening, for us to be able to verify if this is a string, we'll have to use our type function. Now let us find out which data type this has. So to do that, we're going to print, and then using the type function, we shall basically provide our name object, and then we shall be able to find out that it belongs to the class of string. So basically, wherever you create a string or wherever you create text and you wrap it in quotes, all you're doing is to create an object of type string, just like you see right here. However, strings are not only created with double quotes, just like we're going to see. Now, let's say we want to store a number as a string. Therefore, we could create a variable such as our age, and then we could give this a value such as 24. And this is my age. So let's say we wanted to express this as a string, and that's why we would wrap it in quotes. Still, if we use our type function right here, so I'm going to copy this and paste it on a new line. In this case, if we provide our age and save, and I pull down my terminal, we shall see that it's still going to give us the value of string. So basically, anything wrapped within quotes in Python is referred to as a string. Now, what we've done here is to just create a single line string. Now, let's say we wanted to create a multiple line string. So to create a multiple line string will actually have the same text as a single line string. So let's say I wanted to create a multi-line string, a string that's going to fit on multiple lines. We'll say multi-line string, and this is going to be equal to our quotes. And inside the quotes here, what we'll have to do is to write the long text that we need, or to give the value of the long text that we need to keep within that variable. So let us begin. So let's say I wanted to write the lyrics of Never Gonna Give You Up. We can say never gonna give you up, and then we can go to the next line and say never gonna let you down. So this is a multi-line string. However, for us to express it as a multi-line string, there's a certain way or syntax we are supposed to use. Now, the end of each line of this multi-line string, we can add some other text. So let's say we can add some blah 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 text, some long text that can be numbers, letters, or other gibberish. For us to achieve this being a string, all we have to do is to first of all mark where our first opening quote is and where our last quote is, which is the closing quote. And then in between, all we have to do is to add backslashes. So let's see how we're going to do that. So I'm going to come to our first line and then add a backslash, and then this will basically highlight the text on the next line. And even on the next line, I'll add a backslash, and that will basically highlight the next line. And when you go and add the backslash, we'll now see that our code is not having errors. So basically what we've done here is to create a multiple line string. If I save and try to print this out, we're now going to see that this is going to print out our text, and this text is going to be one that is long, one that is not going to actually have lines in between. But let's say we had let's say text that had multiple lines, and we had to express that white space or the multiple lines within this text. Then that's where docstrings come in. So I'm going to pull up my terminal, and all I have to do is to create another string. So let's say that string is going to be equal to twinkle, and twinkle is going to have a poem of twinkle, twinkle, little star. So in this case, I'm going to basically create multiple quotes. So I'm going to start by creating a pair of quotes. Those are 2 quotes. I'm going to create another pair of quotes, and this will basically create 6 quotes. Now in between the triple quotes or 6 quotes, I am going to write our poem right here. So let's begin. So this is going to be twinkle, twinkle, little star, how I wonder what you are. So basically, this is a string that lies on multiple lines and has a lot of space in between it. Now let's look at the difference. So what I'm going to do is to go ahead and print our twinkle variable. Let's notice what's going to happen. So if I pull up my terminal and run our main.py again, we shall now notice that this other variable is being printed with all the space and all the padding or all the indentation present. Now this is what we call a docstring, and docstrings are very helpful when you're documenting functions and classes and so on. So most of the time you'll encounter this, and we shall look at them more when we are dealing with functions. Another thing that we need to understand is strings are sequences. Now by sequences, we actually mean that the characters within a string are expressed in a certain order. And let me explain that. So let's say we created a variable called t, and it had a value of t. In this case, for us to be able to find out the position of the characters in this string, we can be able to access them via positions. And these positions in programming are what we know as indices. So you can be able to print something like t, and then by using these square braces, we can be able to know where a certain item or a certain character in our string lies. So let's say we wanted to find out the first character in this word t. To do that, we'll have to use the index 0 or the position 0, because in programming, the first position is always going to be the first 0 or the 0 position. So the item at position 0 or index 0 is going to be the first item within your sequence. So I'm going to come and say t0, and let's go ahead and print the second one. So to print the second one, that will be the one at position of 1. So I'll say t1, and then when I print t, in this case, I'll go ahead and provide t2, so that will basically print the last letter in this sequence. When I save and pull up my terminal, so I'm going to come and we shall see that we're going to have our first being t, and our second is going to be e, and our third is going to be a. Now another thing we can be able to do, which is quite interesting, is to be able to access negative positions or negative indices. Now that we know that our string basically has our first item at index 0, the last item within our string always resides at the position of -1. So let's see how that works. So if I come and print t and provide our index as -1, in this case, when you run our program, let's see what is going to happen. So we shall see that we are trying to access the index or the item at index -1, which is the last letter in our word, which is a. So let us try to also access the item following the last letter or the character following the last letter. In this case, if we go ahead and print t, we can be able to access the one at -2. So if we save, we try to run this, we shall now see that we are accessing e. And if we try to access the one at -3, it will basically return the letter or the first letter in our string. So in this case, if we say -3 and save, it's still going to return the first letter within our string. Now there are plenty of things that we can do with strings, and we cannot be able to know all of them. One last thing I'm going to talk about of strings that we shall explore in other videos are some of the methods that we can use in strings. Now since these are basically sequences, we can also first of all understand how we can know that a certain letter or a certain character or a certain number is part of a string. So this is where a membership comes in. So I'm going to create a comment right here. So I'm just going to say string membership. So when finding out whether a certain letter or a character basically is present within a string, then we can use the in operator. So let's go ahead and see how that happens. So what we can do is to print. So we have to first of all identify the character, and in this case we can say e, and then use our in to basically compare our letter with our word, and then be able to return for us true if it exists and false if it doesn't exist. Now we shall look at Booleans later as we go on. So in this case, if we say E in T, we're basically checking for the existence of the letter E within our string T. So let's try to run this. So if I pull up my terminal and try to run this, we shall see that our letter E exists, and then it will spit out true. However, if we wanted to find out if it doesn't exist, we can also say, if we wanted to find out a letter that does not exist, we can also say print Q in T. And if we try to run this, of course, it's going to return false because we have no letter Q in the word T. And that is how we find out that a certain letter or character exists within a string. Another thing we can do is to basically find out if two strings are the same. Now, for us to be able to do that, I'll go to the next line and I'll create a comment right here, and I'll say this is going to be our string comparison. So with string comparison, all we have to do is to basically check if a certain string is the same as a certain string. Now I'm going to create another string. So let's say we created a string called T number 2, and this is going to be T. So if you can notice, our first T basically begins with a capital T, and our second T is beginning with a lowercase t. If we try to compare this, this is how we actually write comparison. So if we come and say print, and then we basically compare T, which is our first variable, and we use double equals to compare. So in this case, if we say T2, this is going to basically print false because they are not the same. So if I come and run our terminal, we now see that this is going to return false. Now don't worry about these true false values. We're going to look at Booleans later on in the video. So if we went and changed this and maybe made it T, that starts with an uppercase T. Now if we try to run our Python, we now see that's going to return true because the two variables have the same value of T. Another thing that we can deal with when writing strings is dealing with characters such as quotes. So there may be situations in which you need to place double quotes inside your double quotes, or putting forward slashes or backslashes and all that stuff. Now that's where escape characters come in. So let us try to do that. So let's say you are writing your Python, but you needed to express reported speech. So let's go ahead and do that. So I'm going to begin and say it's going to be escape characters. So let's say I wanted to create a variable for a sentence, such as, let's say our sentence is going to have the value of he said, and then you want to write that text that they spoke in real life. In this case, what we're going to do is to basically write the text. So let's say he said, better call Saul. So what you may see here is we cannot basically use double quotes inside double quotes. So for us to be able to do this, we're going to go ahead and write an escape. So for us to escape these double quotes, before the double quotes, we have to use the backslash for us to be able to escape our double quotes. And then we shall also do the same thing for our double quotes. So let's go ahead and do the same thing for the closing double quotes, just like you see right here. Now another way we may have expressed this is by basically removing these forward slashes, just like you see here. And then we can also go ahead and, instead of using double quotes as our main quotes, we can be able to basically remove the opening quote and then use our single quotes to express our quotes. So let me remove the single quotes, the double quotes, and then replace them with single quotes, and that will be able to print out our statement or our sentence. So I'm going to save, and when I save, I'm going to go ahead and print our sentence. And when I run, we shall now see that this is going to return, he said, better call Saul. Now there may be other instances in which you want to basically write backslashes within your string, and let's look at that. So let's say we had some string some string that required us to write some backslashes. So let me create the second variable. Let me just call it word. And then let's say the word is going to be blah, blah, blah. And then it's also going to have some forward slashes. So for us to be able to express such a forward slash, we are going to need to provide an escape backslash. So that will help us to escape the backslash that we are using within our string. So for us to be able to do that, I'll go before our backslash and then add another backslash, and that will get rid of our error. So I'm going to save, and when I try to run our text, we shall now see, because we haven't printed it out, it's not going to print. But if I went ahead and wrote a print statement right here, such as print word, in this case, when I open up my terminal, it's going to print a string with the forward slash. Now, there are very many escape characters that we can get to understand. So let's look at some of them. I'm going to basically leave some of them at the screen so that you can be able to experiment with them. Now I'm going to teach you about the basic ones. So let's start with the basic ones. The first one we're going to look at is the one that helps us to go to a new line. So while writing long text, you can be able to go to the new line in case you want to separate that text from the current line. And the way we do that in Python is basically creating a string. So let's say we're going to create a long sentence, and that long sentence will have some long text that basically goes and fills up the length of the screen. So for us to split that text, all we have to do is to basically go anywhere inside the text and then use a backslash and the letter N. So what that is a new line character. So if we go to a new line and print our sentence, in this case, when you go ahead and run our code, we shall see that it will break down our sentence and then go to a new line and then display the rest of the text. We can also be able to use a tab. So if we wanted to use a tab, all we had to do is to go ahead within our text and then use a backspace, a backslash, and then with a T. And by using that, we can be able to create a tab. It will basically push our text to the right, leaving some space in between our text. Now remember when I talked about every type of value being an object, strings are object of the type string, and they have various methods or various behaviors that allow them to do various things. So we're going to look at some of them right now. So let's go ahead and start. So let's say we had our sentence just like you see right here, which is in lowercase. If we wanted to make it uppercase, then we need to call some behavior, which is called a method. So in programming, a method just allows us to express a behavior of a certain thing. So for example, humans go to bed every day. That's a behavior. That can be a method of every human object if we were to talk about that. But we shall look at it later in the video. So let's say I wanted to make this sentence an uppercase string. What would we do? We would come and basically, let's go ahead and call the variable name and then use dot to call all methods that are part of that variable. Now in this case, you see the variety of methods you have for capitalize, case fold, setup, blah, 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 and all that stuff. But what we want to do is to basically go ahead and call the upper method. And what this does, it's going to return a copy of our string, but in uppercase. So let's go ahead and print this out. So when I print this out, we are going to notice that it is going to basically go ahead and print our string, but in uppercase. So I'm just going to come here, and then right now we shall see that our string is being returned, but each of the characters that make the string is in uppercase, which is beautiful. So let us go ahead and try to make this lowercase. So I'll do the same thing. Let me just copy this and then go to the next line. I'll print sentence dot, you guessed it, it's actually lower. So if we want to make this lowercase, of course, that's what we're going to do. When we go to the next line, we shall now see that our sentence or our word is now going to be returned in lowercase. If we wanted to make this capitalized, then we'll do the same thing. I'll go to the new line, and instead of upper, we shall now say we are going to use capitalize, and this is basically going to, when you try to run our file, it will basically start with a capital letter and then start the other word with a small letter, just like you see right there. Another method we may use is one that's going to allow us to replace a certain character within our text. So let's go ahead and do that. So if I pulled up my terminal or pulled it down, I could basically come and print the same sentence, but in this case what I'm going to actually do is to replace a certain character. So the replace method is going to take in the character that we want to replace as the first argument. So I'll talk about this when we are actually talking about functions later on in the video. But what you need to provide is the first character. So let's say in our sentence we wanted to start with the first occurrence of Q, can say Q, and then wanted to replace that with, let's say, capital H. So I'm going to replace that with capital H. In this case, if we try to run our code, you're now going to see that where we have Q, we are going to be replacing that with H. Remember, this is the original string, just like you see it here. But then in the next string, we are actually having all Q characters being replaced with the letter capital H. And this is working. Now that we've looked at some of the very basic string methods, let us also look at something very important. So there are very many ways or very many times in which you may want to use a string as a template for you to be able to provide multiple values for multiple strings or other data types. And that is where string formatting comes in. So string formatting gives you a way in which you can replace parts of a string by providing some variables. So let's go ahead and do that. So I'm going to come right here in our file and I'm going to create our first variable. So I'm going to call this variable sentence. And this variable is going to be basically a sentence that's going to take in some variables that can change at any time within our program. So let's say that this is going to be my name. And in this case, let's just use this greater than symbols to provide placeholder variables. So I'll say my name is name and I am. So in this case, I'll provide my age as also a variable. So what is going to happen is we're going to have a variable that contains the name and a variable that contains the age, or we can even provide them as values directly. But these are going to be varying. So in this case, we are going to look for a way for us to be able to place them within our string and then print the string out. So I'll just create a simple print statement here that's going to just print our sentence. When you try to run this, you shall see that's basically going to print it just like we have it here. So now we want to first of all replace name and age with actual values. So that's where the format function comes in. So the .format method or the .format function on every string object allows us to be able to place in some variables within a string. And let me explain how that happens. So what we're going to do is to add the .format function. And in here, we're going to add some arguments. So the first argument is going to be the first variable that we have provided within our string, and that is going to be our name. So I'll come and provide my name. So this is going to be Sally. And then I'll also provide my age. So in this case, I'm going to provide a number, which is 23. Do not worry about numbers. We're going to talk about numbers next. So right after doing this, then I have to go and update our string so that it can accommodate these variables. So I'll go within my name is and then change this. So I'm going to just add a pair of curly braces just like you see here. And then I'll do the same thing for our age and add a pair of curly braces. Now that we've done this, I'm going to go ahead and save. And when I save and try to run our file again, we're now going to see that actual values are being put within our string. And now we have a thing like my name is Sally and my age is 23, which is kind of beautiful. So that means that if we had these as variables, I'm going to go at the top right here. And then I'm going to create a variable called my name. So I'll just basically provide in the name Sally. And then I'll also create a variable. Sorry for this. I'm just going to delete this and close this. So you can also have an age variable that has the age 23. So once we've done this, I'll go ahead and inside the dot format function, I'm going to provide our name and then our age as the two variables that we need. Now in this case, when we go ahead and print our sentence, we're actually going to have those variables just like you see here. We're going to have the sentence printed out as my name is Sally and I am 23, which is beautiful. So that means that we can even go ahead and change these variables. So if we go ahead and say my name is Sally, and then we can also change the age to 235 years. I wonder if someone can be that old. In this case, when you try to run, we're going to now see that these values will be able to change, but still within the same string, which is very beautiful. Now, another way we can be able to do this is by using f-strings. F-strings provide for us a much more easier way for us to be able to place these variables within the string. And let us look at how we can modify our sentence to use f-strings. So I'm going to do is pull down my terminal, and then I'm going to get rid of that dot format function. So after getting rid of that dot format function, I'm going to replace our variables just like you see here. So I'll go ahead and provide name, and then I'll also provide age inside our string. But at the beginning of the string, I'm going to go ahead and add an f, and that is what an f string is. So after doing that, when we try to run our program once again, we're now going to see that our values are going to be replaced within our sentence. And this is actually very interesting. Okay, so the next data type that we're going to look at is the numbers. So numbers are represented in very many ways, but I'm going to cover specifically two types of numbers. And those are the integers and floats. So I'm going to start with integers. So I'm going to basically create a comment right here. That is going to be integers. Now, what are integers? Integers are simply numbers that do not have a limit, and they can be both negative and positives. Now, these numbers do not also have decimal places, just like we're going to see right here. So let me start by creating a variable such as a, and let me give this a value, and its value is going to be 12. So that is an integer. We can also have a value such as b, and b can have a value of, let's say, 44. That will also be an integer. Now we can also have a very large integer. So let me say variable c, and that is going to have a value of, let's say, 1 million or 1 billion. And that will also be an integer, just like you see right here. Now, these integers have very many ways in which you can write them. Now, for now, we've only written these integers, but if we wanted to express this in a much more readable way, or this big integer right here, then Python also gives us a way to write it. So I'm going to create a variable d, and this is going to be one that's written in a very readable way. So for you to be able to read a very huge integer well, you'll need to separate the commas by the thousands by the commas. And let me show you how this happens. Now, let's say I wanted to write the value of, let's say, 10. This is 10,000, 10 million, of, let's say, 10 billion. What we'll do is to go where we have the thousands and then add an underscore. And then we can do the same thing for millions, and then we can do the same thing where we have billions. And that is a very good way for us to express an integer or a large integer. We can go ahead and save, and when trying to print all of this is basically going to give us all the integers, but I'm going to concentrate on our large integer, which is d. And when I print d, this is what is going to happen. We have its value as an integer printed out to the console, and this makes it easier for us to be able to write our integer. Now let's go ahead and also look at some of the operators that we can use with integers. Now keep in mind that these are numbers, and in most cases you may need the value of a number because you want to calculate or carry out some arithmetic. Now there are very many operations that you can use with integers, but let's look at the most fundamental ones. So we're going to begin by basically printing some. So for example, we can use f strings to be able to show the various operations that we have carried out with these numbers. So let's say we want to use an f string to basically calculate the addition. So we may say addition is by using the plus sign, of course, just like you do it in normal calculations. So this is going to be a plus b, and then we shall have a value of the result, which is going to be a plus b, and that will be the sum. So let's do the same thing for all the other operators. Now I'm going to basically go ahead and copy this statement right here. I'm going to just highlight it and copy it, and then I'll go ahead and paste it for the various operations that we have. Now let's go ahead and change this. Now for me to change this, I'm going to highlight the plus sign and then press Ctrl D. It will highlight the next plus sign. So let's change this to minus. If I say minus, then we shall be able to have a minus b on this side. Now for the multiplication, I'm going to basically use the same method. I'll just go ahead and use our sign for multiplication. For the division, we are going to use our /. So I'll do the same thing and then replace the plus with our /. Now we're also going to look at the integer division. So the integer division is what will return the result, not as a float but an integer. And let me try to do that. So I'm going to remove the plus sign, and all I have to do is to use these double /. So if I save, and then we'll go ahead and print this. So I'm going to pull up my terminal right here. When you try to print this, we now see that 11 plus 44 is going to be equal to 56. 12 minus 44, it's going to give us a negative. So this is how we write negative integers. When you try to multiply 12 by 44, of course, we're going to get 528. And every time we carry out a division in Python, we always get a floating point number. Now I'm going to talk about floating point numbers next. And the floating point number we shall get will be this recurring 0.272727, just like you see right here. Now for the integer division, of course, whenever we divide a number by another number, we expect to get a float. But in case we do not want to get a float, then we carry out integer division. And since this is less than what we're actually dividing by, it's going to give us a value such as 0 point something. So to sum it up or to round it up, we're going to get 0 as basically the integer. So let's try to deal with another number. So let's say we're going to replace all the values of a. So I'm going to highlight the first a and then press Ctrl D to highlight all of them, and then I'll replace our b or our a with the value of d. So let's see what is going to happen. So if I pull up my terminal right now and run our file, we shall now see that our value of 10 billion is the one that's going to replace our a that we had. And in this case, we now see that 10 billion plus 44 will actually give us that value. And if you subtract 44 from 10 billion, we shall have that value. If we multiply by 44, it will of course give us 440 billion, just like you see right here. And if we do some division, of course, we're going to get a fraction or a decimal, which is going to be this. But if we try to do an integer division, of course, we're going to get this very huge integer right here, showing us that it's going to get rid of the decimal part and only return the integer part. Now, there are very many operations that you can do and very many ways you can express these integers. But let's look at floating point numbers. So a floating point number is the one that's going to come as a result of division. So each time you want to express a fraction or a decimal, then you're going to use a floating point number. So let us carry out a simple example. So I'm going to print 1 divide by 4. When you look at this, this seems to be a fraction of some sort. But what is going to happen is that Python is going to view this as a division and therefore return for us a floating point number. So I'm going to pull up my terminal and try to run this. Now in this case, you shall see that the value that will be returned to us is going to be 0.25, meaning that this is going to be a floating point number. So a very easy way to look at floating point numbers is basically results of division. Each time we have a fraction, we basically have a floating point number, just like you see right here. Now, these floating numbers can be explained or can be expressed in very many ways. Now, let's say I wanted to write a very big floating point number. So what I'll do is basically use the exponential syntax or the exponential notation. And let's say I wanted to write something like 1 billion. So I'm going to just come in here and use an exponent. I'll say 1 and then use e and then give it the power of 10. You want to raise this to, so I'll say 6. When I save and try to run our file, in this case it will give us 1 million. So this is 1 million. In case it was to be 1 billion, of course we needed to provide one extra 0 to make it a billion. So this is going to actually be 10 million. If it's 10 power 8, of course this will give us a billion, but we shall see that this is also going to be a floating point number. So these are very good ways for us to be able to create large integers by using our exponents. So if you're confused about exponents, exponents are just ways for us to express a large number by using a power of 10. So let's try to create a decimal using this same syntax. So if I come right here and say print, in this case I'll say something like, let's say 2 exponent, and then in this case we shall say -3. And what it is going to do, it's going to basically raise 10 to the power -3, which is going to be, of course, decimal, and then multiply it by 2. So we expect to get something like 0.00 and then 2. So let's see how this is going to turn up. If we run, we shall now see that we're going to get 0.0.0.2, meaning that we can be able to create floating point numbers by using exponents. Another thing that you may want to observe is each time, just like we've seen in the previous example, each time we want to basically go ahead and maybe divide two numbers, be it integers, we're going to create a floating point number. And this is basically how floating points and integers work. Now let's try out a simple example. So let's say we're trying to calculate the area of a triangle. So what we would do is to basically provide the base and the height for that triangle, right? So let's create two variables. I'm going to name the first one our base, and our base is going to be 12. And I'm also going to give this a height. So let's give this a height of, let's say, 24. Now remember that the volume or the formula for our area of a triangle is going to be a half. So I can express this as parentheses just to keep them in one place, and then times or multiplied by the base, and then multiplied by the height. So this is how we can express a simple formula in Python. And then right now what we're going to do is to basically go ahead and print our area. So I may use an F string, and inside this F string we can basically write the area of a triangle with base. Then we put in the value for the base, so this will be our base, and then we can also provide our height, which will be our height, just like you see here. So I'm going to try to put this on the next line. So just going to come and put this on the next line, and when you do this, so I'm going to push this a little bit higher so that you guys can see. So we can say that the triangle of an area with base that and height that, and then you can right now say is, and in this case what we can do is to provide our value for the area. So I'm going to go ahead and save and try to run this. So when I pull up the terminal, we shall now see that we're going to get the area of a triangle with base 12 and height 24 is going to be 144. So this is basically going to return our area, but it's going to return it as a float. And the reason for this is we are having a multiplication of a float and two integers, which is basically going to return for us a float. We have now looked at some very important operators for numbers, but we've forgotten one really important one, and that is the modulus operator. So the modulus operator is one that allows us to find out which remainder is going to remain after us dividing two numbers. So let's go ahead and look at what this does. So I'm going to begin with an example of division. So let's say we are going to print 100 divide by, let's say, 30. And what this is going to do, of course, is going to return for us a fraction or a decimal. So when you run this, we're now going to see that we're going to get 3.3333, which is going to be recurring. But in case we wanted to basically fix this or find out what we want to have as the remainder, then I'll pull down the terminal, and instead of us dividing, let's go ahead and print. In this case, shall say 100 modulus, and this is actually going to be a percentage sign, and in this case we shall provide 30. So what will happen, or what will remain after us dividing 100 by 30? So I'll pull up the terminal here and then run, and this will show us that 10 will basically remain. So this is very important in case we want to find out whether two numbers are divisible by each other. So for example, let's say we wanted to find out if a certain number is divisible by 3. What we'll do is to use the modulus operator, and let's look at that. So if a number is divisible by 3, that basically means that when you divide that number by 3, you'll have no remainder. And for us to be able to do that, we can do a print, and in this case we can maybe say 10, or let's say 10 modulus, and then 2, and then we compare it with 0. That's basically checking if when we do modulus for 2 and 10, we are actually going to get 0 as the answer. So I'm going to save this, and when we try to run, we shall now get 2 true, because of course when we divide 10 by 2, we do not get any remainder, and that is very beautiful. Let me use this chance to also talk to you guys about some built-in functions that will help you deal with numbers. Now the first one I'm going to look at is the round function. So I'm going to create a comment right here, and this is going to be for round. So round is the one that's going to allow you to be able to round off to the nearest number, just like we're going to see. So let's picture a situation in which we have a number such as 1000, and then this is going to be 6, 7, 8, 9. So you're in a situation where you need to round this off to the nearest thousands or the nearest tens and so on. So to do that, we can use the inbuilt round function to do that. So I'm going to come right here and then print, because we need this to our output. Then inside I'll provide our round. So this basically takes in the first argument as the number we want to round off. So we're going to provide our one number. Let's actually put this value in our variable. What I forgot, so I'll just come and say this is going to be our number. And once we have this number, then I'll just basically provide our variable for our number, and then we can also provide the number of digits we want to round off. So this basically takes in, if you're rounding off to the nearest tens, to the nearest thousands, to the nearest hundreds, and so on. So let's say I wanted to round off to the nearest one, to the nearest, let's say, because this is a decimal that goes beyond the thousandth. So in case we wanted to round off, we can maybe round off to the nearest tenth. So to do that, I'll provide 1, and when you do that, we shall now see that it's going to round off to 1000.7, meaning that's going to basically eliminate all this and sum it up as 7. So let's also try to round off to, let's say, the nearest one, or the nearest tens. So when you do that, we are going to now provide 0. When you provide 0, it's actually going to round off to 1001.0. So that means it's going to basically eliminate all of this, and it's going to replace it with 1, meaning that we shall have the nearest one number as basically 1001. Another function we're going to look at is the power function. So the power function is what is going to allow you to raise some numbers to some powers. If you're familiar with math, when you raise a number to a power, you basically need to be able to multiply it by itself for all those times. So let's say we wanted to raise, so I'm just going to add a comment here. Let's say I wanted to raise the number 4 to the power 2. So that basically means that we want to multiply 4 by itself. What we'll do is to basically print In this case, we're going to use the power function, and it also takes in the integer. In this case, let's say 4, and then the power for the exponent. And in this case, it's going to be 2. So what happens is when you have a statement such as power 4 and then 2, this is the same thing as saying, so I'm going to add the comment here, it's the same thing as saying 4 multiplied by 4. If this was 4 raised to the power 3, then we would have something like 4 multiplied by 4 multiplied by 4. And basically, that's what we'll be doing. So if we try to multiply this, we're now going to get 64 as the answer. So this is quite straightforward. It saves you from having to write this entire statement, just like you see right here. Another function that's very important is the one for returning absolutes. So I'm going to go ahead and also add a comment here, and this is going to be the one for absolutes. And this is basically going to be the ABS function. So what this does is to take in the number that you want to find the absolute for. Now in this case, let's say we have negative 144. When I save, when I try to run this, it's going to return 144. So basically, that's how numbers work in Python. At this point, we can be able to create simple programs that take in values and use those values to compute and return results. But we have not been able to interact with our program deeply. This is because we are hard coding values into our code. And by hard coding, I actually mean that we get values and assign them to our variables without having to get actual input. That is something that can make our program less usable. But if we want users to be able to interact with our program, then we need some way of getting input from them. Now that's where the input function in Python comes in. So using the input function, we can be able to ask the users for values that can help us to compute our result. So let's go ahead and modify our program so that we can provide actual values from actual users. Now in here, what I'm going to do is to basically replace our values with prompts, or prompts that will request for the values that are needed. Now in this case, I'll just come right here and I'll use the input function. So the input function is an inbuilt function that will help us to ask for the input. All it does is to take in the prompt. So I'll say enter the base. I'll leave some space right here so that you can be able to read this well. And then I'll do the same thing for the height. So I'll replace the value that we have here with input. In this case, what I'll do is to say enter the height. After doing this, then the next thing is to test our code and see if it runs. So I'll save with Ctrl and S and then pull up my terminal. So when I pull up my terminal, I'll run my file with Python main.py. And in this case, you see that it will ask us for some input. Now provide our base as 12, and I'll also provide our height as, let's say, 24 or 23. Let me provide it as 24. And now we can see that we cannot multiply sequence by non-int of type float. So the reason that's why it's happening is we are multiplying 0.5 by the inputs that we got for that base as well as the height. And this is not something that Python cannot accept. The reason that's why this is happening is because when we use the input function, whatever the values we get are inputs of the type of string. So if we want to confirm this, then we are going to go right in our code. So I'll basically add some print statements to help us find out the type of whatever inputs we get out of the input function. So I'll use the type. So I'll just say print, and then I'll say type. And in this case, we shall get the type of our base. And we shall do the same thing for the height. So I'll say print. In this case, I'll say type. And right here, we shall say that we're going to print the type of our height. Now I'm going to save. And when I come right here, I'll basically run Python main.py. And in this case, when we enter our base, so let's say our base is 12 and our height is 24. Now in this case, we see that what we have are strings. So what can we do to convert these into data types that our multiplication can work with? So this is where type conversion comes in. So type conversion allows us to basically get values such as strings. So a number can be a string, and then we'll be able to convert it to a number, and then we carry out the different operations that a number carries out. So in this case, what I'll do is to go ahead and modify our code so that we change our inputs into integers or floats that our multiplication can work with. So for us to be able to do that, I'm going to basically update our programs by using int. So whatever we shall get as our input is going to be converted to int. So that's basically by using the int class. So we shall wrap everything within the int class. We shall look at classes later on in the video. Now, another thing we shall do is to do the same thing for our height. So I'll say int and then input. And then what I'll do is to go ahead and wrap it the same way, just like we did for the base. Now go ahead and save. I'm going to pull up my terminal and run again. In this case, when you enter the base as 12, let's say 12, and then you enter our height as 24, we shall now see that our product or our result is actually going to be 144. Now the reason that's why we're getting a float is because we are actually multiplying a float by the result of the multiplication of the integers. We shall look at this as we go on in the videos. One of the most important data types in the Python programming language is the Boolean data type. So Booleans are values that hold the values of true or false. So when we refer to a Boolean, we're actually meaning a truth or false statement. So we can have a fact such as it is raining. And this fact being true, it can have the value of true. So the keyword true is what allows us to express something being true. And then we can say it is sunny. So since it's raining, we can now have this fact of being sunny being false. And we can be able to also do multiple logic basing on whether these facts are true or false. So we're going to look at how we do that. But for now, let's also basically find out the type of these variables we've created. So for us to do that, I'll just come and say print, and then I'll use our type function. So I'll say type, and in here, I'll provide our it is sunny. So in this case, it's going to be it is rainy, and then I'll do the same thing for, so this will be print. And in here, we shall have our type, and this type is going to be it is sunny. So when we have this, I'm going to go ahead and pull up my terminal. So if we run main.py, we shall see that all Booleans belong to the class or the type of bool. So basically, each time we want to create a Boolean, all we have to do is to use the bool class or the bool type. So every time I refer to the word class, it's better you understand it as type. We shall look at this later on in the video. So what you're going to do is to go ahead and also be able to find out the Boolean value of multiple data types. So I'm going to create a name, and I'm going to give this a value of my name, which is Jonathan. And after giving this my name, then I'm going to go ahead and print. So if you want to find out the Boolean value of a variable, all you have to do is to use a class, which is the Boolean class, and then we shall give in the variable that we want to check for. Now in this case, what I'll do is to use the keyword bool or the class name or the type name. Now in this case, all we have to provide is the object, and in this case, what we shall do is provide our name. So if we go ahead and run our code, we shall now see that this basically returns true. So what this shows us about strings is strings are actually having a Boolean value, and that Boolean value is actually a true value. So let's also go ahead and experiment with some numbers. So if I pull up my terminal, if I pull it down, I'll basically create a variable. So let this be my age. So let's say if we give this a value of 24, and we go ahead and print our Boolean, and in this case, let's say we provide our age. When you pull up our terminal, when you run, in this case, you shall see that our number or our age is also going to return true. So what does this show us about Booleans? So the Boolean type or the Boolean class basically has each variable that you create of a certain type has a Boolean value of true. except for one. Now let's try to find out which variable does not have a Boolean value of true. And when you come here, so let's say I'm going to print, or basically find out the Boolean type of 0. Excuse me. So when you try to find out the Boolean value of 0, so what I'll do is to come and print. In this case, we shall say that our type is going to be, actually this is going to be our Boolean, so I'll say bool. And in this case, what I'll do is to provide the number 0. So when I save and pull up my terminal, I'm just going to go ahead and find out false. So basically, all values created from strings or numbers or any other data types will have the value of true except for the number 0. Now, the reason that's why that's happening is beyond the scope of this video, but I'll make a video to explain it. The next thing we're going to look at are some of the operations that we'll use often with Booleans. In Python, there are 3 basic operations that you may use with Booleans, and let's look at some of those. So the first one is going to be the not operator. So the not operator is one that's going to allow you to be able to negate the truthness or the falseness of a statement, just like we're going to see. So the second one is going to be our AND operator, used to compare the truthness or the falseness of 2 statements and only return true if both of the statements are actually true. Now the next one is going to be the OR operator. And what the OR operator does is to basically compare 2 statements and be able to carry out whatever we need to carry out as long as one of the statements is actually true. Let's look at an example. So I'm going to comment this out. And after commenting this, sorry for this, I'm going to pull that back. So if I highlight this and control comma, control question mark to actually comment them. So let's look at AND or not. So let's begin with the not operator. So we're using the not operator. All we need is a statement that has the value of true or false. Now in here, I'm going to begin by providing a variable. So let's say it is raining. And this is going to have a value of true. Let's say this is that it's not true that it's raining. If we want to be able to convert this into a false statement, all we need to do is to negate this by using the not keyword. So I'm going to come at the new line, and then I'll go ahead and print not it is raining. So what this is going to do is to simply return for us the opposite of what we have in our fact of it is raining. So if I go ahead and save, I'll pull up my terminal once again. So I'll clear my terminal, and then when you run, we shall now see that we shall get false. And this is because we are having our variable being negated or being returned as an opposite. Now the next operation we are going to look at is the AND operator. So the AND operator basically takes in 2 statements. Let us create a statement for a case in which it is sunny. Now I'm going to create that, and I'll say it is, and in this case I'll say sunny, and what we shall do is to come here and say, let's say if it was actually sunny and it's actually raining. So if we compare both statements, let's see what the output is actually going to be. So I'll come right here and say print, and in this case what I'll say it is raining, and then shall use the AND keyword. So we shall provide it is sunny as the second variable or second statement. So if I go ahead and print, shall now see that true is being returned. And this is because for a statement to return true when we're using the AND operator, all statements that are compared have to have the value of true, which is quite important. Now, this logic is going to be useful while we're looking at if statements, and I hope you watch to the end and be able to see how we can be able to use this logic while dealing with if statements. So let's look at the OR operator. So the OR operator works similar to the AND operator, only that it returns true when one of the statements is actually true. So let's go ahead and work a simple example. So now we've been able to run with AND for true statements, but if we were able to negate one, so by simply providing false, that means that it will actually return false for both cases. So let's go ahead and use OR to be able to experiment with our two statements. So what I'll do is to come right here and say print, and in this case what I'll do is to say it is raining, and then I'll leave a space and then say or it is sunny. So I'll save and then run our code. So in this case, we shall see that it will actually return true. This is because it will only have to look at one statement that actually has the value of true for us to be able to get true. Now, if we are to change both statements to make them, let's say, negative or false, when we run our terminal, we shall now see that we are actually having false. This is because it did not get any statement that actually had any true value. So these can be tricky to understand, but I'm going to leave a chart at the top of our screen so that you can be able to see what these different operations. Actually, I'm going to leave it in the video itself. Instead of using the AND and NOT keywords, we can also be able to use certain symbols that are provided within Python to help us express our ANDs or ORs. So let's go ahead and look at that. So I'm going to close my terminal, and then when I go back here, what I'm going to do is to negate or be able to change from our keywords to symbols that Python provides for us. I'm going to begin with AND. So for us to be able to use AND, we are going to use our ampersand symbol, which is basically Shift and 7 on Windows. Then if we want to use OR, we shall shift to this bar character right here, and that will signify our OR operator. Now that we've learned about Booleans, let us use them to control the flow of our program, and that's where if statements come in. Most of the times when we are speaking in English, you can be able to use an if statement in a sentence such as, if it rains, I'll carry an umbrella. So most of the times you have a fact, and basing on whether it's true or false, you want to do something with that. Now that's where if statements come in. So we're going to first create a Boolean. I'm going to create this it rains, and I'm going to give this a value of true. So in here, I'm just going to provide it a value of true. And once I provided for it a value of true, I'm now going to use the if keyword that's provided by Python to form a logical statement out of this. So right here, what I'm going to do is to come and say if, then I'll provide our condition if it rains, and in this case I'll just use a simple print statement. So I'll just come and say print, and here what I'll do is to say I will carry an umbrella. So basically the condition of us carrying an umbrella bases on the fact that it's going to rain. So let me complete this. So when you run this code, of course what's going to happen is we are going to print I will carry an umbrella. So if I pull up my terminal, I'm going to control it, and then I run python main.py. In this case, you see that it will be printed I will carry an umbrella. So basically what happens is whenever you have a condition, you basically want to use an if statement for you to be able to execute some code that only depends on that condition being true. So let's go ahead and look at another example. So for now, if we were to change this to give it a value of, let's say, false, then guess what will happen? If we pull up our terminal and run, we shall see that there is nothing that's going to be output. And this is because we have not yet got a scenario in which we have the opposite of our fact not happening. And in this case, what we are going to do is to use the else keyword. So the else keyword is one that allows us to be able to catch or be able to run some code in case our condition has failed or in case our condition has not been true. So in this case, what we'll have to do is to go ahead and provide else, and then we'll go ahead and execute some code right here. So I'm just going to print else I will. So let's say it's going to be sunny. So in this case, I'll carry sunglasses. And right after doing that, I'm going to run our code. So right now, if we are to notice, we are going to actually see that our itRains is false, which means that this code is not going to run, but the code that will run is going to be the one for our carry sunglasses. So if we come right here and we try to run our code, we shall now see that we are having I will carry sunglasses, which means that having failed to make it in a way that it should rain, or because it's not going to actually rain, we shall carry sunglasses. And if it rains, of course, we shall basically carry an umbrella. So basically, that's how if statements works. Now, we have only been able to look at one example where we basically have two conditions. And that is the fact that it's going to rain, or another fact that it's not actually going to rain. But there may be instances in which you want to basically be able to use an if statement for multiple conditions. So let's see how we're going to do this. So I'm going to give you an example, and that's what we're actually going to use to understand it. Alright, so now I have a very simple example that can help us to best understand these multiple conditions. So what we have here is just a simple income tax calculator. You can call it whatever you want. I've just chosen the random name. But what it does is to basically calculate someone's tax and be able to generate for us the net income. And we're going to see how we are going to do this. But what it has are the different conditions, just like you see here. We have one that shows us the gross income less than 1,000, and therefore our tax will be 5% of their income. If their gross income is less than 5,000 and greater than or equal to 1,000, then we shall get 10% of their income as tax. Then if the gross income is less than 10,000 and greater than or equal to 5,000, 15%. If it's greater than or equal to 10,000, then we're going to charge them 20% of their income as tax. So this is basically what we're going to code, and yeah, let's get into it. So the first thing we're going to do is to first of all be able to get our income, or our gross income. So the gross income is going to be a variable which we're going to use to determine all these. So the first thing we shall have to do is to create that variable. So I'm just going to call this our gross income. And once we have our gross income, let me increase the font size. So once we have our once we have our gross income, now let me give this a value of, let's say, 15,000. Once we have this value, we can even maybe get it as user input. So I'm just going to say, let this be quote as an integer. So I'll use the input function that we have looked at in the previous videos. And in here, I'll just say enter gross income. So once we've asked the users for the gross income, now the next thing we're going to do is to actually go ahead and use our if statements and the conditions given to us right here to form conditions that will help us to be able to make sense out of this. So the first thing we're going to do is to first of all go for the first condition. So our first condition is if our gross income is less than 1,000, then we should charge 5% as tax. So what I'm going to do is to come right here, down here, and then I'll use an if statement just like for the previous example we've done. And in this case, what we're going to do is to basically use our gross income, and we're going to check if it's less than 1,000. So this is basically our condition right here. So basically when this passes and it is true, what we'll need to do is to set our tax. So I'm going to create a variable called tax, and this is going to be equal to 5% of our entire gross income. So to do that, then we'll have to calculate this as 5 out of 100, which is the same thing as 0.05. So let me just write it as a decimal. So I'll say 0.05. And in this case, one thing we're going to do is to multiply that by our gross income. So in this case, I'm just going to say that that's going to be our gross income. Now, in case we have multiple statements, or in case we have multiple statements or multiple conditions that we're dealing with, then that's where an elif comes in. So think of a condition where you have multiple conditions. For the previous example, we actually had two conditions, and that's why we used if and else. But in case we have multiple conditions, then Python allows us to use the elif keyword. So the elif keyword is one that's going to allow us to be able to use multiple statements or multiple conditions within our if statements, and then in combination with else, we shall be able to deal with all those conditions, just like we're going to see right in this example. So for us to be able to use our second condition, which is basically for having a gross income that's less than 5,000 and it is greater than 1,000. So for us to do that, we shall use our elif keyword, and then here we can choose to put them in parentheses just to group them for easy reading. So you can say that if our gross income is less than or greater than or equal to 1,000, but so here is where the AND keyword comes in. So basically what this is going to do is to check if both of these are true. In this case, we're trying to check if our gross income is greater than or equal to 1,000, and if our gross income is actually less than 5,000. So once we've been able to do this, now we can charge the gross or the tax as basically 10% of our gross income. So I'm just going to create a variable here. I'm going to call it our tax, and this is going to be 0.1, which is 10 out of 100 of our gross income. So in this case, I'm just going to come and say 0.1 times, and in this case, it's going to be our gross income. So once we've done that, then I'm going to go to the next condition, which is basically the one for if our gross income is less than 10,000 and it's greater than or equal to 5,000. So I'm just going to come right here and say elif, and in this case shall say gross income is greater than or equal to, so in this case it's going to be greater than or equal to 5,000, and because we need both of those conditions being true, in this case what we're going to do is to go ahead and say our gross income should be less than 10,000, just like you see right here in our example. So I'm just going to come here and provide 10,000, and once I provide the 10,000, now I'm going to create our tax, and our tax in this case is going to be 15 out of 100 times our gross income, which is going to be 0.15 times our gross income. And once we've been able to do that, then the next thing is going to be for us to be able to deal with the next condition. And that next condition is if we're having a gross income that's greater than or equal to 10,000. This was actually supposed to be greater than, it's supposed to be greater than or equal to 10,000. So we're going to charge them 20% tax. So for us to be able to do this now, since all of these conditions have been met, that's where we can introduce our else. So what I'm going to do is to say else, and in this case we shall charge our tax as 0.2, or call it 20 out of 100 times the gross income. So in this case we shall say times the gross income. And once we've been able to do this, the next thing is going to be for us to be able to calculate our net income. So to calculate our net income, this is going to be the income that's got after us subtracting our taxes from our gross income. So I'm just going to come here and create this variable called the net income, and this is going to be equal to our gross income, and this will be minus our tax. Now keep in mind that our tax is being got from our if statements right here, just like you can see right here. So let's go ahead and run our program and see what kind of output it's going to give us. So I'm going to pull up my terminal. I'll clear my terminal with Ctrl and L because I'm using bash. So once I've done that, then I can come and run our program with Python main.py. And in this case, we shall now see that we are being told to enter our gross income. So let's say we're going to enter something like, let's say 1,000. We now see that it's going to run, but it's not going to print anything just because we haven't yet provided anything. So when you go ahead and provide some print statements, so in this case, let's say we're going to print, and we're going to use f strings, basically to use them as templates, in which we shall substitute most of our values. So in this case, what we want to do is to get our gross income, and then basically provide that within our variable. So in this case, what I'll do is to maybe provide the $sign, and here I'll provide our gross income, and that's going to be our gross income. So I'll do the same thing. I'll say that this is going to be our tax, and in this case I'll just basically come right here and provide a variable for tax, which we are getting from our condition. And then we shall come here and say print, and in this case shall say this is going to be our net income. So once we have this as our net income, we shall also provide our net income variable. Sorry for that. So at this point, this is what we actually have. So I'm going to clear my terminal or kill that terminal, and then I'll come and run our program again. So in this case, when we provide something like 1000, we shall now see that 10% of 1000 is being got, and our net income will be 900. And then if we try to basically run this program, let's give it 125,000 income, and that will basically get 25,000 as our tax, and then give us a net income of 100,000. So basically that's how our program will run. And another thing we have to notice here is we are having many if statements, or we are having actually a lot of conditions to handle, and that's why a good understanding of our Boolean logic, just like I talked about in the last section, is very important. One very important way for us to deal with conditions without having to write if statements is by using the ternary operator. The ternary operator comes in very many programming languages, but Python does not have one, so in most cases you'll need to implement it in a given way. So let's see how this is going to happen. Now, given a statement such as if it rains, I'll carry my umbrella, else I'll carry sunglasses, we can be able to combine this into one statement and then use our if else on that same statement without having to write the syntax of our if statements. So basically this is how it's going to run. So what happens is, what you have to do is to basically have a result in mind, or a variable in mind. So let's say this is going to be our result, and in this case what you can do is to basically go ahead and write what will be true, or what will happen if this condition is true. So in this case, our statement is going to be I will carry an umbrella. So this is basically what we're going to have as being true. So I'm just going to copy this and paste it right here. So basically it's going to be I'll carry an umbrella, and then we can write our if statement still on the same line, and I'll carry an umbrella if it rains. Basically if it rains is true. So in here we can just come and say if it rains, and then else we can provide what will happen if this condition is not going to actually run. So I'm just basically going to come right here, and all I have to do is to cut this or remove it and basically paste it in there. So this is what will basically happen. I'll carry an umbrella if it rains, else I'll carry sunglasses. So I'm going to get rid of our if statement right here, and then I'll have to change this it rains from what it is currently to true. So let's see how this is going to run. So if I pull up my terminal and control my, or clear my terminal, in this case when we run our program again, we're going to see that it doesn't print anything because we expect it to print a string. So I have to add a print statement here, and that is going to print our result. So if I save and run our program again, right now we'll see that I'll carry an umbrella, and this is because it rains is true. So this is how we can think of a ternary operator in Python if we want to implement one. Now that we've looked at an if statement, we have also been able to do something that we haven't been doing for the previous examples, and that is what we call indentation. Now if you're to notice right here, all we have is a simple program that basically gets a number from the input, that's via the keyboard, and when you have this number, then we can be able to check if the number is greater than 50, then you just print out number is out of range, and if it is the opposite of what we have in our condition, then the next thing we're going to do is just to print number is within range. So there are quite a lot of things that are happening right here. One of the things you can notice if you're observant is after the if block, after us being able to mention what we have as our condition, when you go to the new line, there is some space that's being left away from the margin. So this is what they call indentation. Indentation is a way in which Python allows us to be able to understand where a block of code starts from and where a block of code ends. So in this case, what we can notice is that when you have distance away from the margin to where our first print statement is, that means that all the code that is slightly away from the margin where our if statement is under our if statement. So basically what you have here is whatever code you shall write within our if statement. So let's maybe write some other code. So I'll just say some other code. All this code is basically going to run inside our if statement. Another block of code that we have is our else statement, just like you see right here. And then after the if statement, if we go ahead and write some other code in here, what is going to happen is all code that resides away from the margin after our else block is going to reside within the else statement. Now this is something that you need to get used to, and it's something that's tricky. But what happens is actually that when you're inside an indent block, you basically have 4 spaces away from the margin. So if I go to the margin right here, or let me delete our indent, for us to be able to go within our else statement, all we have to do is to press our space 4 times. So if we say 1, 2, 3, 4, our cursor will be right where our code needs to be. And we can also use tabs. So if we say, let me delete the space, or let me delete our indent, we can now use our tab. That's if your editor really supports tabs, or if your editor is really having support for Python and set to indent into 4 spaces. You can basically press your tab key and it will allow you to push your code 4 spaces away from the margin, which means that your code will be under the block. So this is basically a simple example, but we shall look at more examples of indentation while dealing with other control flow structures. The if statement is one of the ways in which Python allows us to be able to run or control the flow of our program. But in most cases, we may need to iterate or be able to repeat a certain task. And that is where loops come in. So a loop basically allows us to be able to iterate or to repeat a certain step or a certain task or run certain lines of code for a given number of times. And we're going to look at loops. So loops that exist in Python are the for loop and the while loop. So let's start with the for loop. The for loop is a special loop that allows us to be able to iterate over a sequence. And you're going to see how this works. Another loop is going to be the while loop that basically helps you to loop while a certain condition is true. And we're also going to look at. So let us start with an example of a for loop. So a for loop allows us to loop over a sequence. And let's see how that really happens. So the first example I'm going to do here, I'm going to come to our code. And the first example I'm going to give is one for looping over a string. Now, remember that we discussed strings and we discussed the fact that a string is basically a sequence of characters. So in this case, we're going to loop over a sequence of characters. So let me create my name, and my name is going to have a value of, let's say, Jonathan. We can be able to iterate over this sequence of characters by printing out each letter in my name. And that's where a for loop comes in. So what I'm going to do is to go to the next line, and then I'm going to use the for keyword. So I'm going to say for. Then the next thing we have to do is to specify the element in the sequence. And in this case, it's going to be our element, or we can call it our letter, since we want to print out or be able to do something with the letter in our name. Then we're going to use the in keyword. So it's basically the in keyword does is to basically check if a certain character exists within a sequence. Now in this case, what we're going to check for is the name. So in this case, I have to provide our name. So basically what we have here for each letter in the name Jonathan, then what we're going to do is basically go ahead and print our name, or let's first print our name. So in this case, if we come and say print name and we run our file, so I'm going to basically stop our, or basically clear our terminal and run. Now we shall see that for every letter in my name, we are actually going to go ahead and print my name. Now we can do the same thing for all the characters that exist within our name. So if you're to notice, my name basically has 1, 2, 3, 4, 8 characters. What happens is when you say that you want to print this name, this process of printing is going to actually occur for each of the letters that we have in our name. So basically that's how a for loop works. A for loop works in one way in which you have to know the amount of times you want to run the loop or repeat running a certain line of code before you actually start looping. And that's how a loop or a for loop actually works. Now let's try to make this interesting. So let's print out all the letters in my name. In this case, I'm just going to come and say for letter in name, then we're going to print our letter. So I'll come and use Ctrl L to clear my terminal. And once I've done that, I'll run our code, and now you'll see that it's going to go ahead and print each of the letters of my name. So this is basically cool. Now, that is just a simple example of how a for loop works. Now, another example that we're going to use is one that uses a range. So we can be able to print or be able to do certain things given a range. So let's say a range from 1 to 10, or a range from 0 to 100, or a range from 0 to 1000. And that can all be done by using a for loop. So let me introduce you to a special function called the range function. So range is a function that can allow you to be able to describe a number of times you may want to be able to do something. Now I'm going to pull down my terminal right here, and I'm going to remove our previous example, or let me just comment it by pressing Ctrl and question mark on my keyboard. So once we have this, then I'm just going to come and basically use our range function. So inside here, I'm going to use our for, and then in this case, I may say I, which is basically going to be any letter. You can feel free to call it whatever letter you may want, or whatever variable you may want. But what this is going to be is actually for any element within the range or the sequence you want to loop over. So once I've done that, then I'm going to say for I in. Now I'm going to call our range function. Please feel free to be patient. I'll talk about functions later in the video. So once we have a range, we can provide a start value, or we can simply provide a value for the range or a number of times that we want to run the for loop. Now in this case, let's say I want to basically print 3 times, or basically carry out something 3 times. I can just provide the start value as 3. And once I've done this, then I'll go ahead and maybe print I. And I want you to notice what is going to happen. So if I go ahead and save, in this case, if I pull up my terminal and run the program, we now see that the range is going to be from 0, 1, and then 2, which means that this is going to execute 3 times. Now, if you go ahead and maybe try to provide a certain value with a start and a stop, I also need you to notice what is going to happen. So let's say I wanted to start from 0, and then we go to 3. So what we can notice here is we have a start value, which we've provided as 0, and a stop value, which we have provided as 3. Now, when we save and try to run this program, we now see that it's going to print 3 times, but it's going to leave out the last number that we provided within our range. So basically, that's how a range works. When we provide a start value and a stop value, what will happen is we shall exclude the stop value. So it will consider all the other numbers except the stop value. So let's try to do something more interesting. Assuming you wanted to print from, let's say, 1 up to 10. In this case, what we'll do is to come and provide 1, and then we would say maybe to 11, because we want to leave out 11. So if we go ahead and save and run our code, and now we can be able to see that it will print from 1 going up to 10. So basically that's how the range function works. And if we wanted to provide maybe a step or basically numbers which we need to skip, in this case what we'll do is to come within our range function right here, and we'll provide a third argument or a third attribute to our function, which is actually going to be an argument. So we shall look at all these when we are looking at functions. So I'm going to come and provide our step. So basically, let's say I wanted to step 2 numbers from the current number in our range. So we can provide that step as 2. And when we run this program, what you'll notice is we shall be skipping from 1, we shall add 2 to go to 3. From 3, we shall add 2 to go to 5. And from 5, we shall add 2 to go to 7. And then we shall end on 9. So that's a brief introduction to for loops. Now we shall look at for loops later in detail when looking at sequences, and I hope you have understood how for loops work. Now that we've looked at how for loops work, let us try this simple example. Now I'm going to give you some seconds so that you go ahead and try it yourself, and I'll be back. Alright, so now let's go ahead and try this. So now that we have our statement here, it's saying that print even numbers from 0 to a number entered within the keyboard. So the first thing we need to do is to create a variable that's going to hold this value or this number that we need to create a range with. So I'm going to come right here and I'm going to create a variable called number, and this is going to be equal to integer. And inside here, we need to use the input function, which we looked at in the previous videos. So here, we're going to provide our prompt. So in here, we're going to say enter number. And once we've been able to enter our number, we're now going to create a for loop that's going to loop from 0 as the start to where we have that specific number. So the way we're going to do that is by saying for I in, which can be j, it can be k, or any other letter or variable you want to create. So I'm going to keep it to I, and then I'll say for I in range, and in this case I'll start from 0 and then go to the number that we've entered in the keyboard, which we called number. What we want to first do is to get all the numbers that exist within this range. So for us to be able to do that, we shall just come and print I. And if we try to run our program, what is going to happen is we are going to be asked for a number. So let's say we want to enter 12. Our program is going to go ahead and print from 0 up to 11, which is good. But what we need is to basically go ahead and print all even numbers that fall within this range. And if you were to guess, we are actually going to write an if statement to be able to do this. Now, for us to be able to know that a number is divisible by 2 or an even number, we'll have to use the modulus function, the modulus operator. So the modulus operator is one that's going to allow us to basically divide and check if we have a remainder, and then it will return the remainder. So if a number is divisible by another number, then that means when we divide that number by the given number, we do not have a remainder. So let's go ahead and write our if statement. So in here, what we're going to do is to write if, then in this case, shall say number, or actually that's going to be I. And then what we should do is to use our modulus operator. And then what we have to do is to basically go ahead and divide it by 2. And if our remainder is going to be equal to 0, so what we're doing is to use the comparison operator right here. And if we will compare if the result of our modulus is actually going to be equal to 0, meaning the number is divisible by 2. After doing this, then what we have to do is to go ahead and print our I. So that basically means that this is going to go ahead and only provide for us even numbers within our given range. So if I save and try to run our program, once again. So in this case, I'm going to enter 100. So this will basically go ahead and print only the even numbers that are within our range. And this is a very good example right here. Now that we've looked at the for loop, let us look at the while loop. So the while loop allows us to execute code in case a certain condition is true. That means that the program will continue repeating some lines of code given a certain condition being true. And when that condition becomes false, then the while loop will stop iterating or looping. So let us look at a simple example. So let's say we have a number and we want to increase that number to a certain given point. That number will be less than that certain given point. Therefore, we can execute certain lines of code while it's still less than that certain given point. So let's create that number. So I'm going to come right here in our main.py and I'll create a number which I'm going to call num, and I'll set it to 0 initially. So while it's still 0, we want to check if this is less than a certain number. Now let's say we want to check if this number is actually less than 30. What you can do is to write a while loop. So I'll begin by using the while keyword provided in Python, and then I'll give the condition. So this condition is what we'll have to evaluate to true for the loop to run. So for me to do that, I'll say while number. In this case, we want to check if it's less than 30. While the number is less than 30, what do we want to do? We want to print the number. So I'll just come right here and say print the number. So what I'm going to do is to save, and when I pull up my terminal right here and try to run our program, we shall now see that the program is going to execute until it will not stop. And the reason as to why this is happening is because our number right here is going to continue being 0, meaning that it will still be less than 30, and for as long as it's less than 30, our program is going to execute endlessly. So if we want this to evaluate to false, what we shall need to do is to we must actually increase the number so that it reaches that point where it's actually greater than 30. So I'm going to stop our code from running by pressing Ctrl and C. And once I've done that, then I'm just simply going to come right here and update the value of our number to a certain other number. So I may do this by increasing it by a certain value. So let's say we're going to increase that number by 1 for each iteration. So I'm going to come here and say number, and then our number, or our variable called number, will have a new value that will be equal to number plus 1, which means that we've increased this by 1. So what I'm going to do is to pull up our terminal once again, and we run our main.py. So what will happen is our program will run from 0, just like you see right here. So it will run from 0 and then go ahead and execute up to 29, just like you see right here. So you'll see our program executing from 0, and then it will go all the way up to 29, and then it will stop. And the reason for that is beyond 29, our number is going to be equal to 30, which is actually going to be greater than 30. If we want this to include 30, then all we can say is to say less than or equal to 30. I'm going to save, and when I come right here, we shall now see that 30 will also be included, which is good. But for now, what we are doing is to just actually increment our number. So we can also go ahead and use a certain shorthand that's provided for us by Python to basically express our increments. So what I'm going to do is to change this from number is equal to number plus 1. And all I have to do is to say number plus equals, and then I'll say 1. So this is the same as saying number equals number plus 1. So basically this shorthand allows you to do the same thing. I'm going to leave an illustration that will show you how to do this for addition, subtraction, multiplication, and division. So let's go ahead. So once we have this, then our number will be increased, and for as long as it's less than as long as it's greater than 30, then the condition will stop because it will evaluate to false. Let me provide another example. For the next example we are having here, we are having this simple exercise or a simple question that's asking us to enter the user to ask the user to enter a number and then enter another number. So what we want to do is to add these numbers together and then ask if they want to add another number. And if they want to ask they enter y, which is basically yes, we shall ask them to enter the other number and keep adding numbers until they do not answer y or yes. So while the loop has stopped, that's when they have not answered y, then we shall display the total of our numbers. So let's go ahead and do this simple example. So what we have is our condition that will be true is our answer that we ask for the user as being y. And if they do not provide y, then our loop has to stop. So the first thing we shall have to do is to ask the users for the first number and then the second number. So I'm just going to come here and create two variables. The first one is going to be num1, and this will be int and then input. And then here, what we need to do is to basically provide a prompt. So I'm just going to come and say enter num1. And then I'm going to also go ahead and ask for the second number. So in here, I shall say num2. And this is going to be equal to int and then input. Here, we shall also go ahead and say it's going to be enter num2. So once we've been able to do this, the next thing we're going to do is to go ahead and basically create our first statement or our first answer. So our first answer is going to default to true, and this is because we need our while loop to run for the first time. So we're going to create a variable called answer that will allow our while loop to run for the first time. But then within the loop, we shall have to go ahead and ask for the answer or ask users for the answer. And if they enter y, we shall keep on adding to the number. When they ask for no, then we go ahead and simply print out the total of the numbers. So let's go ahead and do that. So I'm going to create a variable called answer, and this is going to have the default answer being y. So once we have this default answer being y, then we're going to use a while loop to check if our answer is actually equal to y. So that will actually be true if we are given the example that we have above the while statement. So what we're going to do is to say while our answer is equal to y, then the first thing we're going to do is to ask the user for another number. So for us to be able to do that, we shall say other number. Let's just call that other num. And this is going to be equal to int and then input. And in here, we shall say enter and then other number. So once we've been able to do that, then the next thing we're going to do is to go ahead and we simply go ahead and basically add the total of the numbers that we actually have. So I'm going to create a variable called total, and this is basically going to be what we have as a result of adding these two numbers. And in here, when you say yes, all we need to do is to go ahead and basically update that to what we have when you ask for the numbers. So I'm just going to come right here at the top, and then I'll say that our total is going to be equal to our number 1 plus our number 2. And then once we go right here, if we have answered yes, then all we have to do is to update our total. So we shall say that our new total is going to be equal to, so sorry for this. So our new total is going to be equal to total, and this total is what we have right here, plus our other number. So once we have this, then we are going to go ahead and ask for a new answer because we need our answer to be different for each time we loop. So I'm just going to come right here and say answer. And in this case, we are going to have our answer being equal to input. And then we shall say, do you want to add another number. So what we want to do is to ask the users if they want to add another number. We can also give them a hint by saying yes stroke no, because just to help them understand if they have to enter yes or no to this question. So let's go ahead and try to run this. Now, once all this has failed, or once our answer is not y, then what we need to do is to just go ahead and print the total. We can also give them a hint by going ahead inside here and then printing our total. So let's go ahead and do that. So we can just come and say print, and then here we can just say, well, I can use an F string, so I'll just say the total is, and in here we shall just basically provide our new total. So we can also do the same thing outside our if statement or our while loop, which is actually a while loop. So just come and basically have it there and also have it outside our while loop. So when I go ahead and save, if I open up our terminal, I'll stop what I've been doing with Control and C, and then I'll go ahead and run main.py. So in here we shall have enter number 1. So we shall have, let's say, number 12, and then when we enter 13, which is the second number, we shall be asked to enter another number. So let's say it's 12. So our total is going to be 37 for the first time, and then for the second time, since our while loop is having true in our condition, we shall be asked to enter if we want another number or if we don't want. So in this case, if we say no, our loop will stop at 37. So let's try to run our example again. So if we say 12 and then 12 and let's say 14, our total will be 38. And in case we want to add another number, I'll say yes, and then I'll add another number, let's say 13. So our total will update to 51. If I say yes again, in this case, let's say 45, our total will be 96, just like you see here. If I say yes and then add 67, we shall see that our total is now 163. If we say no, our total will not be updated, and then we shall see our program stopping. So this is just a simple example to show you that while loops will run for as long as a certain condition is true. And in this case, the condition that we're checking for to be true is our answer being equal to yes. So as long as our answer is equal to yes, our code within the while loop will continue to execute. But while this condition becomes false, that's when our answer is not equal to yes, then we shall just basically go out of the loop and print our total. Now that we've looked at for loops and while loops, let's go ahead and look at how we can combine these with other control structures so that we can control the flow of our program in a certain way. So why would you want to use a while loop or a for loop with another control structure like an if statement? So there may exist a condition in which you want to combine all these statements for you to be able to perform some logic. Now let me give you a simple example. The simplest example I can give you is one for getting the sum of even numbers from 0 to 100. Now you may ask, why would you want to use an if statement and a for loop? And this is the perfect example I can show you. So what we have here is we are given a range of numbers from 0 to 100. And in case we want to be able to deal with a range of numbers, then this calls for us to use a for loop. So what I'm going to do is to first of all create that for loop. I'll come and say for, and then let's say for number, let's say this is going to be our number. And in this case, we're going to say in our range, which is basically the range from 0 to 100. And when we have done that, then we can maybe go ahead and find out all these numbers within our range. So let's use a simple print statement to go ahead and print all these numbers. So we can say print number. And when I pull up my terminal, now we can be able to print out our numbers. But in case we want to actually find out which number is divisible by a certain number or divisible by 2, because we are now trying to deal with even numbers, that calls for us to use an if statement. And the way we're going to be able to do this is by using our modulus operator. So our if statement will be something like if, and in this case shall check if our number modulus 2 is going to be equal to 0. Then right here, we can go ahead and print our number. So if we print our number, if we save, we can now see that this is actually going to print only even numbers within our given range, which is important because now we're using our for loop to basically loop through each of our numbers, and we're now using our loop for us to be able to find out which number is divisible by 2 and then returning that number. Now, in case we want to find out the total of these numbers, then that calls for us to use a total, or to be able to create a variable of total and then go ahead and add each of these numbers to our total. So for us to do that, we're going to first of all initiate a variable called total, and we're going to give that a value of 0. So once we've given this a value of 0, then the next thing we can do is to go ahead and add our total. We can add a number that's divisible by 2 to our total. So in this case, I'll use the shorthand of incrementing, and I'll just basically come and say that that will be our total updated to our total plus the new number that's divisible by 2. So once we've been able to do this, then I'll basically go ahead and print our total, our updated total after running our loop. So that's going to be right here. So I'm just going to come and say that we're going to have an F string, and this is going to be our total of even. So shall say this is going to be our total of even numbers, and that will be our total. So once we have this, then the next thing we're going to do is to run our program, and let's see what is going to happen. So if I pull up my terminal, I'll clear it, and when I run our program, we can now see that our total of even numbers is going to be 2,450. So basically, this is what we are going to have as our total of even numbers. Now, to make our program more interesting, what you can do is to go ahead and provide this as something that is dynamic, that can be got by providing some sort of user inputs. So for us to be able to do this, we are going to basically ask a user to enter our range. So ranges of numbers from the start to the stop. And then we are going to basically return the total of even numbers within that range. So for us to be able to do that, we are going to begin by, first of all, getting the start value. We can call this our start value. And this is going to be equal to integer, and then input. And then we can be able to enter the start value. And once we've been able to do this, then we can also enter the stop value. So I'm going to say the stop value, and our stop value in this case is going to be integer, and then input. Then here we can say enter the stop value. So once we've been able to do this, now instead of having 0 to 100, we can go ahead and modify this so that we can have the stop value, and then we can also have our start value. So once we've been able to do this, then let's run our program. So if we run our program, this case, we shall be asked for the start value. So let's say 1, and when you provide the stop value, then we can say 1,200. So when you try to run this, it's going to return all even numbers within that range, and then it will also provide for us the given total, which is amazing. While using loops, we can be able to basically control the flow of our loop by using the break and continue statements. So let us start with the break statements. I'm going to pull down my code right here. So all we have is, as long as we have an even number, we shall go ahead and add the total to one number. Now, what if we wanted to modify this program so that when we reach a certain total, then we'll have to escape the loop. We don't have to add anything to it. So that's where the break statement comes in. A break statement is one that will allow you to break out of a loop based on any condition that you set for that specific occasion. So in this case, what we want to do is to check if our total is greater than a certain total or equal to a certain total, but let's just check if it's greater than a certain total. Then we'll be able to actually go ahead and break out of our loop. So in this case, what we are saying is if we provide a large number, such as 1,200, we will have very many even numbers. But what if we wanted our total to be a certain total? that's less than actually 1000. So what I'm going to do right here is to add another if statement inside our for loop. And what this if statement is going to do is to basically go ahead and check for our total being greater than 100. And if our total is being greater than 100, all we're going to do is to stop our loop from running and then print out our total. So to do that, what I'll do is to come right where we print our number. I'll go to the new line and I'll use an if statement to set our condition. So in this case, we're going to check if our total is greater than 100. And if our total is greater than 100, then all we're going to do in this case is to go ahead and basically break out of our loop. So I'll say break, and that will be it. So if we try to run our loop once again, so I'm just going to go ahead and pull out my terminal. So in this case, I'll enter the start value, which is going to be 1. And if I provide a large number such as 1200, in this case, when our loop reaches to the point when our total is greater than 100, which is at 110, what it will do is to stop running. So we shall have our total as 110. So this means that actually when we go beyond 100, when we reach 110, our total will be the one for this condition, and therefore our loop will stop running. We can also use the continue statement to basically skip an iteration and then go on and execute the code for other given iterations. So within our range, such as the one from 1 up to actually 1200, we can be able to skip a certain iteration. So we're going to go ahead and modify our total right here. So I'm just going to modify this, and let's say if our number, in this case we're going to maybe skip 100 or skip the iteration for 100. So what I'm going to do is to say if our number is equal to 100, then what we want to do is to go ahead and continue, meaning we will not add a total to our number at that given point. So let's go ahead and be able to do that. So I'll come right here and add an extra print statement, and what this is going to do is to basically help us to keep track of our total at that given point. So I'll just come and say print, and I'll use an F string to basically go ahead and print our total. So I'll say total, and in this case our total is going to be equal to our total. So I'll just come and provide it in here. So I'll say it's going to be our total. And once you have our total at that point, I'll replace our break statement with a continue statement and then go ahead to save. So when we have this, then what I'm going to do is to come right in my terminal and run our program once again. So I'll provide the same values for the range. So our start value is going to be our 1, and our stop value is going to be our 1200. Now we shall see that our program will execute until it reaches the total of all the numbers within this range. But if we are observant, when you go back to where we have our total being equal to 100, let's go all the way to the top where we actually have all these numbers. Now the numbers seem to be so many. Let me try to scroll up. So in this case, if I try to go to where I actually have the number of, let's say 100. So let me actually decrease my range so that you guys can see. So let's say if I run this with 1, and let's say we run this with 100, and let's say 50. When we run our code, we shall see that the total is going to be 5450. If we scroll to where we have our number being 100, this is what is going to actually happen. When our even number is 100, we are not going to be able to add to our total. So that's why you see the total being 2450. And then for the next number, we shall also see that the total will still be 2450. So this basically shows you that our total will not be added to. So the code will skip that iteration for 100. So we shall not add any total to our current total when our number is equal to 100. So that's basically how a continue statement works. It helps you to skip running code for a given iteration. If you have made it this far, please leave a like on the video. This video has taken me a lot of time and research to make, so a quick like is something you could do to support the channel. At this point, we've been able to learn how while loops work, and we've also been able to look at how we can control the running of our loops. In this example, we're going to be able to build this very simple application that's going to allow us to basically understand how loops or for loops, actually while loops work. So this is a very simple banking application with very limited features or very limited functionality that we can use to understand this. So it's basically one in which we have a program that basically runs, and it should help users to deposit cash. So we have sort of a current balance, and then we go ahead and just add to it when we deposit cash. It should also allow users to withdraw cash. So that means we are going to be able to subtract whatever users will withdraw from this example balance or from this current balance. Then we should also be able to check the balance. That means that users, when they select a certain option, they can be able to check for their balance, and then users can be able to quit the program once they are done using it. So using our knowledge of while loops, we are going to put together some lines of code that will allow us to basically organize or write this program. Now to start, we are going to begin by executing a while loop, and this kind of while loop is going to be the one that's going to allow our program to run without stopping. So what we need is a certain condition that's going to be true, and while that condition is going to be true, our program is going to run without stopping. So this means that we're going to write an infinite while loop. So let us start by doing that. So I'm going to come and say while, in this case I'll say true. Then while we have true, we're going to go ahead and set a condition that's going to stop our program from running. So we can ask them for a number. So we can maybe say if they enter 0, then the program should stop, or if they enter 1 or any other number, the program should continue running. So what I'm going to do is to write a variable called prompt. And this prompt is basically going to ask the user to enter 0 to stop, or any other number to continue. So in here, what we're going to do is to go ahead and set that stop variable. So I'll come and say stop. In this case, stop is going to be actually equal to, so we shall have int, and then inside here we shall have our input function, and what we shall ask for is going to be our prompt. So I'm just going to come and provide our prompt right here. So once we have this prompt, then when this prompt is equal to 0, that means that our program should stop to run. So I'm going to come right here and write an if statement that's going to check if this is not equal to 0. So I'll come and say if stop is not equal to 0, so the exclamation mark is one that sums up our not operator. And in this case, what I'll do is to basically check if it's not equal to 0. So we shall have some code running here. So I'm going to use what is called a pass statement to basically skip the lines of code that will be here. So I'm just going to come and say pass, and then else, that means if our stop is equal to 0, then our program should actually go ahead and break. So in this case, we are going to just terminate the program to stop our loop from actually existing. So now that we've done this, then we are going to have all of the options right here executed when our value for stop is not equal to 0. So for me to be able to do that, I'll have to come and basically give the user the chance to enter any of these options. I'm going to do that by coming right in here. I'm going to remove our pass, and when I remove our pass, I'm going to come right here, and all I have to say is print. So I'm going to go ahead and print whatever we have at the top right here. So I'm going to copy these options right here, and once I copy these options, I'll be able to go ahead and provide them as instructions for the user on what the different options do. So I'll say print, and then I'll use our docstring right here to go ahead and basically print what we have here. So I'm going to provide the different options. So this is going to be for quitting, withdrawing, and checking balance, just like we see right here. So I'm going to tidy this up a little bit, and then we are basically going to have this. So here we're going to actually just tell users to deposit their cash or deposit whatever amount of money they want. So I'm going to use Ctrl D to remove this instruction, and then we shall have our our instructions just like we see them here. So once we have this, then we are actually going to create a variable, and this may be our option or our prompt or whatever variable we may want to create it, so or to call it. So I'm just going to come right here, sorry for this. So what I'll do is to come right where we have this, and I'm going to come and say that we're going to have a variable called option, and this option is going to be equal to an integer as well. So when you have this as an integer, it's going to take in the input, so they'll be able to enter whatever option they want out of these many options. So I basically say enter option, and once they have entered these options, we are going to use if statements to basically control what will happen when users select any of the options we have right here. So for us to be able to do this, I'm going to come, and the first thing I'll do is to basically write options. So I'll start with the first option. So I'll say if option is equal to, so in this case, what I'll do is to say the option is equal to 1. So we are going to be able to deposit cash. So I'm going to create a variable called the deposit, and this is also going to be an integer. So I'll just come and say int, and then input. Hope you guys can see this well. So let me make it a little bit bigger by pulling it down. So inside here, we're going to just ask them to enter the amount or to deposit. So I'll say enter amount to deposit. And once they enter the amount to deposit, we shall go ahead and add that to our current balance. Now, if I go up at the top, I'll just create a variable called our current balance. So I'll say current balance, and that current balance will be 0 at the start of our program. Now what we're going to do is to go ahead and increment our current balance by the amount of money they have deposited. So to do that, I'll just come and say current balance plus equals, and then in this case we shall add our deposit. So once we've been able to add our deposit, then the next thing is going to be to take care of our withdraw. So for withdraw, it's going to be different in a way that they're just going to be subtracting money from whatever they have on their bank account. Now I'm going to just come and copy what we have here. Now since this is another condition, when you go ahead and paste it here, what we shall have is, if our option is 2, then this is actually going to be an elif. So I'll change this and call it an else if our option is 2. Then instead of depositing, what we're going to do is to actually withdraw money. So in this case, I'm just going to basically check this, and I'll say withdraw. And in here, I'll just say that we're going to enter the amount of money to withdraw. And once you have that, then we shall also update this so that we can actually withdraw or be able to subtract our current balance by removing the withdraw. So I'll just come and say current balance minus equals our withdraw. So once you've been able to do that, then we're going to take care of our checking of our balance. So I'll do the same thing. I'll come right here, and all I have to do is to say else or else if or elif. And in this case, we're going to check if our option is equal to number 3. So when you have our option being equal to number 3, in this case, what we need to do is to return the current balance. So I'm going to come and say print, and in this case, we shall basically use an f string to just say that the current balance, and in this case, we shall basically just provide it in here, current balance. So once I have that, then I'm going to come right down here, and then since we have the fourth being our quit program, so I'll just come and provide our option as quit program. So this is actually going to be elif option equal to 4, then we shall basically print something to tell the user that they are done using the application. So we may print something like bye, and then we go ahead and use our break statement to basically go out of the code. So shall just come and say break. So we also need an else statement in case they haven't entered any of the provided options. So what I'm going to do is to use else, and then in here what you can say is to print invalid option, or to just tell them that they have entered something that's not part of the provided options. So I'm just going to come here and say print, and here I'll say that print invalid option. So once we have this, then we are going to go ahead and basically run our code to test if it actually works the way we want. So I'll pull up my terminal right here, and if I run python main.py, we are now going to have enter 0 to stop, or any other number to continue. So let's start by providing 0. If I provide 0 right here, our program will stop immediately, meaning that it will not go ahead to execute, which means it's working well. So let's try to provide a value that's not 0. So I'll say 1, and in this case we shall see print. This is going to print deposit cash, withdraw cash, check balance, quit program. So let's enter our first option as, let's say, to deposit cash. So if we enter the amount we want to deposit, let's say we want to deposit 125,000. So in this case, if we enter 1 to stop, or 0 to stop, or any other number to continue, so let me enter 1. In this case, let's say if we want to check our balance, if I say 3, it will print our current balance as 125,000. Now in case we want to withdraw, we shall say 2, and let me enter my option as 2. So if I enter, let's say we want to withdraw 2,000. In this case, if we enter 0, let me actually enter 1, and if I check my balance right now, we see that our balance has gone down by 2,000, which is good. So that means that our program is working as we expect. So if I enter 1 and enter 4, that will actually print by and stop our program. So this has been a very simple example to help us understand our while loops. So what we have is basically a program that has a while loop and some if statements with a variety of options. If you have made it this far, then you probably understand how for loops and if statements work. But in this example, we are actually looking at an if statement with very many conditions. So this program just basically takes in an HTTP status code and then matches it with the given conditions for us to be able to get an appropriate message for a given code that's entered from the keyboard. Now that's where the match statement comes in. Given this variety of conditions, we can be able to write a bunch of elif statements that will allow us to return the appropriate message given a status code. But this is ugly and non-readable, and it's something that will make our program more bulky. So for us to be able to fix this, Python provides for us the match statement. So the match statement is one that's going to allow us to match the variable of our code, and then we match it to given cases. So the cases are actually going to be the conditions in this case, or the codes, the integer codes, just like the ones we have right here. And then basing on those codes, we shall be able to return an appropriate message. So let's look at how we can do that. I'm going to come right here, and where we have our program, where it's ending, I'm going to go ahead and basically go ahead and comment whatever we have except our code. So I'm just going to press Ctrl and question mark. That will comment our code. And I'm going to enlarge this so that you guys can see. So the syntax of a match statement is basically easy. All you need to do is to match a given variable. So in this case, the variable we need to match is going to be our code. And once we've matched our code, now we need to create a bunch of cases that are going to determine what our message is going to be. Now in this case, we shall use the case keyword, and this case keyword is going to be having our code. So in this case, we're going to start by providing our code, which is going to be 404. So when you have our code as 404, then we are actually going to go ahead and basically return the message as not found. So what we're going to do is to just simply copy what we have here. So I'm just going to come and copy our statement for message equals to not found. So I'll just come and place this right here. That's going to return not found. So in case we go ahead and write the second case, so our second case is going to be equal to, so what we're going to have is our case being 400. So I'll come and provide that as 400. Now in this case, we shall come and say that our message is going to be equal to bad request. I think that's going to be bad request. Now I'm just going to copy this and paste this just to save time. So if I come, I'll copy what we have here and then paste it right here. So that's going to be for our case of 400. So in this case, I'll also come and provide our next case. So our next case is the one for 302. So come and provide our case as 302. And once you have it as 302, then we shall have to provide our message. So in this case, our message is going to be our found. So I'll just come copy our message right here, and then I'll paste it just right here to save time. So this is going to be message found. Now another thing I'm going to do is to provide our case. So the next case is going to be the one for 500. I'll just come and say 500. And once you have this as 500, then in this case, shall come and say that our message is going to be equal to. So I'll just go ahead and, sorry for this, so stop this and go ahead and delete the space that I've created. So this is going to be internal server error. So I'll copy what we have here, and then I'll basically go ahead and paste it right here. So this will provide our message. So once we have our message, then we shall provide the next case. So our next case is actually going to be the one for 403, and our message will be forbidden. So I'll copy this, and when you go right where we have our 403, then our message will be forbidden. Now once we provided this, we also have an extra condition. That's when all these conditions are failed, then we're basically going to go ahead and have our message as invalid status code. I'm going to come and copy what we have here. So what I have to do is to create a variable that's going to stand for a condition in which we do not have any case, or we do not have any variable matching whatever we have as our conditions or cases. So what I'm going to do is to create a case. Now I can call that other, and once I have that as other, then inside here I'm going to basically come and set our message to invalid status code, just like you see right there. So when you try to run this program, let's see what's going to happen. So I'm going to clear my terminal, and if I run, so in this case when we enter as HTTP status code, so let's enter our 404. In this case we shall see that's going to print not found. If we enter our HTTP status code as 500, to return internal server error. And in this case, if we go ahead and maybe print, let's say, provide our status code as, let's say, 302, or let's say 300. So let's see. So this is actually going to be our 300. Provide this at 300, we shall see that we are now going to have an invalid status code. So this is basically showing us that we can use our match case statement to basically allow us to be able to write a clear and more brief if statement. So basing on all those conditions, we can be able to write a very brief match case statement, and it will be able to allow us to do exactly what we want with an if-else statement. Let us now look at a very important and fundamental building block of Python code. So we're going to look at functions and how they allow us to basically keep code within a single unit that allows us to use that code wherever we may need it. Let us begin with a simple example. Throughout all the videos or the sections we've been learning, we have always been using a function such as the print statement. So let me go ahead and create a simple print statement and explain why it is a function. So I'm going to go ahead and write print, and then let's provide a string in here. So I'm just going to say hello. I've actually written a wrong spelling right here. Forgive me for that. So when we have this, this is a function, and it basically takes in a string and then prints it out to the output. What if you wanted to know what this function really does in Python? So the beauty with VS Code and the Python extension is we can be able to know the underlying functionality or the workings of a function as defined in Python. So for us to be able to do that, since this is an inbuilt function, we can press Ctrl and then hover over the function, and then we shall see the function definition and the documentation being brought up. So right here you can see that this is a function called the print function, and it basically takes in values, a separator, and other parameters that we are going to look at, do not mind. So basically to return the definition of the function and what it does. So let's go ahead and try to create our first function. Now I'm going to get rid of our print statement right here. And then we are going to use the def keyword that's provided for us by Python to create a function. So for us to be able to do that, I'll say def, and then following def, we have to provide the function name. So let's say we are writing a simple function to get even numbers in a range of 0 to, let's say, 100. So for us to be able to do that, we can call our function get even, and then in here we follow it by a pair of parentheses. Now this pair of parentheses is where I provide the different variables or parameters that will be used inside the function code, just like we're going to see later. Now we also follow that with a colon, which is going to allow us to start the function body. Now the function body is simply all the code that will run within the function. So for us to be able to do this, let's write a simple for loop that's going to allow us to print all the even numbers from 0 to 100. So for us to be able to do that, we can say for I in range, and then here shall say 0, and then let's say 100. So when you have that, then we can basically check if I is divisible by 2, which is even. And in this case, we can say if I modulus 2 is equal to 0. That actually means that we do not have any remainder. We shall just come and print our I. So let's go ahead and run our code and see what this is going to return. So if I pull up my terminal, I'm going to clear it with Ctrl and L. So if I run our code, we are now going to see that nothing will be printed out to the console. And the reason for this happening is, in case we want to use code that exists within a function, we shall have to first call it for us to be able to run and receive our output from our function. I'm going to pull down my terminal, and then I'll come right here, and then what I have to do is to call our function. So all we have to do is to write the function name and then provide a pair of parentheses. So when I go ahead and save and pull up my terminal once again, so let me make this a little bit larger so that you can see. If I run our code, we shall see that this is going to print out all the numbers that are divisible by 2 but are in the range of 0 to 100. So that's basically a simple function we have created. Now let us look at another function that can be helpful. So let's say we wanted to calculate the volume of a cylinder, and we are required to write a function that's basically going to be calculating this throughout all of the program that we shall be using. So I'm going to go ahead and try to write that function. So we're going to get started by defining what this function is going to be. So I'll use the def keyword, and we shall choose a right function name. So let's say that's going to be get volume or calculate volume or whatever you may want to call it. Now this get volume function is basically going to require us to have the radius. Now we can first of all understand that the volume of a cylinder is actually going to be equal to, let's say, pi times the radius squared. So shall have to raise the radius to the power 2. So that's going to be power 2 then times the height. So we are going to require two variables, which are going to be the radius and then the height. Pi is a constant that is given to us by math. So let us go ahead and try to do this formula. Now we're going to first of all require to get a height. So let's say the height is going to be a variable such as 24, and then we are going to have a radius. So let's provide our radius at, let's say, 12. So when you have this, now we shall need a value for pi that's not rounded off. So in this case, I'm going to be making use of the math module that's built within Python. We shall look at this later. So what I have to do is to go ahead and use the import keyword for me to be able to use this module. So I'll say at the top of our code, import math, and after importing math, I'll go right where we have our code. So let's go ahead and create a variable called our volume, and this is going to be having what we have as our formula right here. So I'm going to go ahead and say that our volume is going to be math dot pi. Now if you're confused about the syntax, you shall look at it later on as we look at modules in detail. So this is basically accessing the pi value, the pi variable or the pi value, just like you see right here. And then you shall go ahead and multiply it by the radius raised to the power 2. So for us to be able to do that, we can either use the power function, which is also a function, or do it manually by saying that we're going to have our radius raised to the power 2, which is going to be that. And then we can also go ahead and say that we're going to multiply that by the height. So when we have this, then we shall need a way for us to be able to print this to the output so that we will be able to view it in our output. So what I'm going to do is to just write a simple function right here, and this function is going to be an f string. Let me correct this. So in our f string, what we want is to basically go ahead and give our volume. So I'm just going to say that our volume is, and then in here we shall basically provide our value for the volume, and then since we do not have any specific units, we shall just say that these are going to be cubic units. So I'm actually wrong, so let me correct this by providing the quotes in here. So that's what we're going to have. So right after doing this, then let's go ahead and call our function. So when I go ahead and call our function get volume, we are now going to pull up our terminal, and what we'll do is to run. So this will return for us the volume of our specific cylinder that has the radius and the height, which is basically 10,857 point blah 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 cubic units, just like you see right here. But if we wanted to make this program dynamic, then we will need to provide some variables that the function may take in, so that we do not have to have only one type of variables being used. And what am I saying? So if we go back to this function right here, what we have are the height and the radius, but these are provided or hard-coded within the function, which means they can't change. But in case we wanted to use this function for very many values of the radius as well as the height, that would mean that we may want to be in a position where we provide this dynamically. And that's where parameters come in. Now the purpose of these two parentheses that we provided in the function definition is to hold those variables or parameters that the function may require to run. So let's go ahead and correct this function so that it may take in these variables and be able to run our function with those specific variables. So we shall begin by providing our radius. So I'm going to come and provide this as our radius, and then I'll use a comma to separate our variables and then provide the second variable, which is going to be the height. Now this makes these variables in here useless. So if I remove them, if we go ahead and run our code, right now we need to also provide the variables within our function call. So where we called our function get volume, we'll have to go ahead and provide the radius as well as the height. So we shall go ahead and say get volume, and in here we shall say that we're going to have our radius. Let's say our radius is going to be 12, and then we shall also require to have our height, which is going to be 24. Now if I save, I can also call the same function with different values. So let's say get volume, and then in this case we shall be able to get the volume using our radius. So let's say 24, and let's say our height of 48. So if I go ahead and save, if I pull up my terminal and run, we shall now see that we've been able to get different values for our volume, given different values for our radius, as well as our height. At this point, we've created our simple function which we call getVolume, and we provided some variables that can be used within the function so as to be able to carry out the different calculations. But then we went ahead to use those same variables by providing values to stand for those variables so that we enable our function to run. Now, I just want to tell you about what these are. When we provide variables to a function, those are what we call the parameters of that function. And when running that function or calling that function, the values that we provide for those variables are what we refer to as arguments. Many times people get to mistake this, and I thought that would be helpful to talk about them. The working of a function will be really dependent on the user who wants to use the function. But in most cases, functions will be used to return values, and that's where the return keyword comes in. Now, what we've been doing to get the output of this function is to use a print statement that will allow us to print the volume given the radius and the height. But we're going to modify our program so that instead of printing, we shall be able to get actual values that we can then use within our program to do different things. So let us go ahead and modify this function. So what I'm going to do is to go ahead and get rid of our print statement, and instead of using our print statement, we're now going to use a return keyword. So I'm going to say return, and then we'll just basically provide the value that we want to return. So if we want to return our volume, all you have to do is to provide our volume, and when I save, in this case when you run our program, guess what's going to happen? So if we run our program, nothing will be printed out. So the reason that's why that is happening is the getVolume function is basically going to get the volume, return the values, but won't be able to use them anywhere. So if we want to use them, then all we need to do is to use some sort of output to basically show them in the output or in our terminal. So I'm going to do this by coming right here and simply printing them out to the console. So I can come and say print, and then what I'll do is to basically go ahead and print our getVolume for 12 and 24, and then I can also go ahead and do the same thing for the second function call by printing. So this is actually going to be print, and when I do that, if I pull up my terminal, we shall now see that our values will be printed out to the console. If we wanted to make our program more interesting, then what we may do is to ask the users to enter our values from the keyboard. So for us to be able to do that, what I'll do is to come at the top of our code before our function and then say that we are going to have our radius, and this is going to be a float or an integer depending on what you want to use. So I'll say float, and then in here we shall ask for the input. So we're going to ask the users to enter the radius. So we shall enter the radius, and after entering the radius, now we shall also enter the height. So I'll say height is going to be equal to float, and then input, here we shall ask for the height. So I'll just say enter the height. So once we've been able to do that, then what we can do is, instead of hard coding these values in here, we can then return them dynamically. So for us to be able to do that, I'll just come right here, and all I have to do is to provide our radius and then our height. So these values are the ones that are going to be got from the keyboard. So in this case, what you can do is to get rid of what we have here. So I'll just go ahead and run our code. So in this case, shall be as for the radius. Now let's enter the radius as 12, and then the height as, let's say, 24, and then we shall be able to get the same output. We can also modify it so that we can get it as an F string. So let's say we can say F, and then in here we can say volume of cylinder, and then we can modify this. So let's say is, and then we can use our F string to basically go ahead and print this out. So I'll modify this by closing the curly braces and then providing the quotes. So when you run this code, we shall now see that if we provide our values, our output will be provided in a better way, just like you see right here. Let's assume we had a case in which we wanted our function to return 2 or more values. Now that's where we write a function that has more returned values. Now we're going to create a simple function that's going to be able to calculate different things, or be able to basically give us the functionalities of a simple calculator. So for us to be able to do that, I'm just going to come right here, and all I have to do is to define a function. I'm just going to call it calculator. And this calculator function is going to take in the different numbers. So let's say our first number is going to be first num, or num1, and then we shall have our num2. Now when you have this function, then what we need to do is to basically go ahead and return the sum, the multiplication, or the product, as well as the result of dividing these two numbers. So let's go ahead and do that. So I'm going to first of all begin by creating a variable called sum. Let's say call it total. So the total is going to be a variable, and all it's going to contain is the value of adding our first number plus our second number. So let's go ahead and do this. So we can say this is going to be our second number. Now we're going to also have our product, and our product is going to be the result of multiplying our first number by our second number. So this is going to be num2. And then we can have this third being the quotient, or the basically the result of dividing these two numbers. So the quotient is going to be equal to, so that's going to be num1 divided by num2. So when you have such a function and you want it, so sorry for this, I'm going to cancel. So if you want this function to basically return all these values, then what we'll do is to basically come and say return. And what we'll do in this case is to return all these values. So we shall separate them with commas. So we shall say return total, and then we shall return our product. We shall also return our quotient. So once we've been able to do this, how are we going to access all these variables, or all these returned values? So Python gives us a very interesting way in which you can be able to access all these values. So let's go ahead and try to do that. So what I'm going to do is to go ahead and basically create this. So I'll just say total. I'm going to create variables for the total. For the product, it's going to be our product, and then we shall also have our quotient, and this is going to be the result of calling our function. Now I'm going to get our numbers from the input. So I'm just going to come here and say that our number 1, remember these are outside the function, so they're not part of the function, and that is going to be an integer. So in this case, shall input or get it from the keyboard. So I'll put a prompt here, and that is going to be enter first number. So when we have this, then we're also going to do the same thing for our second number. Now I'll have to copy this and then paste it on the next line. So this is going to be our number 2. So I'll say number 2, and this is going to be enter second number. So once we have this, then let's go ahead and try to access these values, or these return values. So what I'll do is to call our calculator function, and then I provide it with the first number, num1, which is basically going to be our value of num1, and then the second one is going to be our value for num2. So when we do this, when we go ahead and print our sum, our product, and our quotient, let's go ahead and use f-string. So I'll say print, and then in here I'll say this is going to be our sum. So I'll say that our sum of, let's actually just make it easy to read. So I'll just say num1 plus, this is going to be num2. This is going to be equal to our total. So I'll also surround it with curly braces so that we have it easy. So I'm just going to go ahead and do the same thing for our multiplication and division. So in here we shall have this multiplied by num2, and then we shall have our product, which is basically going to be the return value of our function for the product. So in here I shall just say our product, and then for our quotient or our division, we are going to return our quotient, or So when I go ahead and save, when you try to run our code, in this case, we're going to be asked for the first number. So let's say our first number is going to be 100. And let's say our second number is going to be 25. When we run this, we shall now see that this is going to allow us to access the different return values that are returned with the function. And this case clearly shows you how we can get multiple return values out of a function. Let us look at two ways in which we provide arguments. Our function right here just takes in two values, which are x and y, and then returns the sum of those values. If we wanted to provide arguments to this function, there are basically two ways, and we shall look at others later. So the first two ways we're going to look at are positional arguments as well as keyword arguments. Now, positional arguments, just like you hear the word positional, really depend on the position of these parameters within the function. So when you create a function and then it has parameters x and then y, that's the order in which we shall provide our arguments. Now let's go ahead and call our function. So I'm going to be using our print statement to output the result. I'll say print, and in this case what I'll do is to provide our x, which is going to be, actually it's going to be a call to our add function, shall have our x as 2 and then our y as 3. And then it will be done basically providing our arguments. But if we wanted to use our keyword arguments, then we would follow a way that doesn't really depend on the position. What we have to do is to first of all understand the name of our parameter, which is x, and then y, and then be able to provide them in that way. So let's go ahead and call the same function using keyword arguments. So if I come here and say print and then add, I'll provide our arguments with x being the first, so I'll say x equals, and then I'll provide our 3, and then I'll do the same thing with y, and then equals, and then I'll say y is equal to 3. So if we go ahead and run our code, we shall now see that our values have been printed to the console. The first method is the one for positional argument. It really depends on the position in which we named our parameters, and then the second one really depends on the name of that specific parameter. So this is just a by the way, but it's really important as we are going to look at it. At this point, we've been able to look at some of the ways to create functions, pass values, and then be able to call those functions. But what if we wanted to document a function so that we can make it easier for people to really understand how functions work? Now that's where docstrings come in. I've talked about docstrings in the video I talked about comments, but now I'm going to be talking about what docstrings actually do. So whenever you write a function in your code, chances are high that it will be used by people who will be able to interact with your code in the future. And that's where docstrings come in handy. So whenever you have a docstring or a function, you have to document it by using a docstring. Now I'm going to come and all I have to do is to create 3 pairs of double quotes, and that will be our docstring. So I'm going to add a docstring. So I have this extension that helps me to create these docstrings, and I'm going to show it to you. But what it does is to basically show us the summary of the function, what the function does, and the arguments, their types, and their descriptions. Now let's go ahead and try to do that. So what I'll do is to come in here and provide our summary. So in this case, shall see that our function adds or returns the sum of 2 numbers. So let's say this is going to return the sum of 2 numbers. And here on the args, we are actually having the arguments that this will take in. So we have to provide a type. Now in this case, I'm going to say that the type can be an integer, and then we can also provide our type as an integer. So for the description, we shall say that x is going to be our first number. So this is going to be our first number, and then y will be our second number. So once we have this, then we also can define the type. So the type in here is going to be an integer, and in the description it will be the sum of the numbers. So in this case, we shall just say that will be the sum of the 2 numbers. So once we have this, then we can be able to actually know what the function does. Even if we use it in other files, they are the help function that we're going to actually look at. We can be able to know what this function really does. So let me call the help function. That's an inbuilt function that is going to help us to understand what this does. And all it does is to just basically take in the name of the function, and we'll be able to know what that function does. So I'm going to save, and when I pull up my terminal, when I run our file, we shall now be able to see that our help function is going to allow us to understand what the add function does. So the add function takes in x and y and then returns the sum of the two numbers. It takes in the arguments x and y, x being the first number and y being the second number, and then returns the int, or the integer, which is basically the sum of the two numbers, which is amazing. Now, the extension that I was talking about for helping us to generate these docstrings in Python is what they call the auto doc generator. So let me actually open my extensions. So when you go to extensions and I go to install extensions, you can search for the auto docstring extension. This is very helpful while creating docstrings, and it will make it easy for you to create them, just like you see right here. Functions can also have default parameters, and let's look at an example. So let's say we created a function. We can create a function. Let's say we call it square root. What this function is going to take in is a number. So let's say it's going to have a number as an argument, and what it's going to return is the square root of that number. So what we can do is to just basically take in the number and then raise it to the power of 0.5. This is one of the ways you can calculate the square root. But let's say we wanted to be able to provide a default number in case we do not have a number passed to this function. Now that's where default parameters come in. Then we'll be able to provide a default parameter or a default value for a certain parameter is by going inside the parameter and then assign to it a value. So let's say in this case we are going to say 100. So what we're going to do is to come and call our function. If we call our function with print, and let's say we print our square root, and we provide our number. So let's say our number is going to be nothing for now. When you try to run this function, we shall see that it's going to return for us a square root of 10.0 or 10, let's say. And that is because we have provided a default argument of 100. But in case we provided something like 144, right now we can be able to call our function and it will return a different value for our square root. So that's just basically a way you can provide default arguments to a function. Each of the members in a list can be accessed by using an index. So let's say we had a list of names such as the one we used in a previous example. You can be able to access each of the items within this list by using an index. Now let me show you a simple illustration. So I'm going to begin by creating a comment right here. Actually, this is supposed to be a comment. So in this comment, I'm going to basically go ahead and place some numbers to just show you the indices of these specific items. So let's begin with the first one. So the first item of the list is always at index number 0. So I'm going to say this is going to be at index number 0. That means that the second one will be at the index number 1. So if I provide index number 1, I can go to the next one and then give it an index of 2, and then give this an index of 3, and that will go until the end of the list. So basically, if we have a list that contains 10 items, then the last item will be at the index 10 minus 1, or n. Let's say the length of our list is n. n minus 1 will be the index of the last item within our list. So if we want to access each of these items within this list, then we're going to use their indexes to be able to access them. So let us begin by accessing the name gems from our list. So the way we access our name is by basically going and printing or calling our variable, which is our names variable, and then we use the square brackets just like the ones you see right here. So in here is where I will go ahead and provide our index. Now let's begin by accessing the first one. So let me just actually go ahead and print this. So we go ahead and print our names. Now this will actually give us access. Let me clear my terminal and run, and that will give us access to our name gems. So let's go ahead and do the same thing for all the items that exist within our list. I'm going to basically go ahead and copy this, then I'll paste it, go to the new line and then paste it. So I'll call this item number 1. I'll go to the next one, which is item number 2, then I'll go to the next one, which is item number 3. So if I save and run our code once again, we shall now see that we are now able to access the different items within our list. But what if we wanted to actually access the last item within our list? And that's where negative indexes or negative indices come in. So a negative index allows us to access items beginning from the last item within our list. Let's say I wanted to access the last item. Python provides for us multiple ways in which you can be able to keep some data, and one of those ways is the list data type. So the list helps us to create a collection of items. These items can be of whatever data type. So let us begin by creating a simple list of names. These names can be our friends or your friends, so feel free to add values the way you want. So I'm going to begin by creating a variable called names. And this variable is going to be a simple list. So an empty list is one that has 2 square brackets, and that will make for an empty list. But if you want to add values, then what we'll do is to basically provide some strings. So let me say James, and then let's say in here we're going to have Jerry, and then we can have Maria, and then we can have Martha. So you can call this Martha. So if we have this is a valid list. We can also have a list of numbers. So if we create one list of numbers, this can be 1, 2, 3, and 4, and 5, and 6. And then we can also create a variable that contains Booleans. So let's say attendance. So let's just say attendance. So let's say you are creating a list, but this has to keep attendances of a certain individual with values of true and false. So we can be able to keep this as true and then let's say false. So this basically has 2 items. A list can be of data types that belong to very many data types. So let's say we can create a string that has multiple data types. So in this case, let's say we are going to create a list, let's call it A, and this is going to be having both strings. So let's say Jerry, and then let's say here we can have like a word like bot, and then we can have 12, and then we can have some booleans in here. So we can have a value such as true. We can also have another list within this list. So let's say can have one list that contains 2 numbers, 1 and 2. So all these are valid ways for us to be able to create a list. But we can also use the list function to create a list. So let's say we're going to create another list. So let's say this is going to contain all the letters that are going to be in my name. So what we have to do in this case is to go ahead and create our list called name. And then by using the list function, we can go ahead and say list. And then we provide the specific value. So in this case, I'll just come and provide my name, which is going to be hello. And that will be a valid list. So if we go ahead and print some of these, we can print our names. And then let's say we can also print our name list. So when you pull up our terminal, I'm going to run our file. And here we can see that we've been able to create 2 lists. So we've created a bunch of lists, but then we've gone ahead and printed only these lists. So that's how we create a list in Python. Each of the members in a list can be accessed by using an index. So let's say we had a list of names such as the one we used in a previous example. You can be able to access each of the items within this list by using an index. Now let me show you a simple illustration. So I'm going to begin by creating a comment right here. Actually, this is supposed to be a comment. So in this comment, I'm going to basically go ahead and place some numbers to just show you the indices of these specific items. So let us begin with the first one. So the first item of a list is always at index number 0. So I'm going to say this is going to be at index number 0. That means that the second one will be at the index number 1. So if I provide index number 1, I can go to the next one and then give it an index of 2, and then give this an index of 3, and that will go until the end of the list. So basically, if we have a list that contains 10 items, then the last item will be at the index 10 minus 1, or n. Let's say the length of our list is n. N minus 1 will be the index of the last item within our list. So if we want to access each of these items within this list, then we're going to use their indexes to be able to access them. So let us begin by accessing the name gems from our list. So the way we access our name is by basically going and printing or calling our variable, which is our name's variable, and then we use the square brackets just like the ones you see right here. So in here is where I will go ahead and provide our index. Now let's begin by accessing the first one. So let me just actually go ahead and print this. So we go ahead and print our names. Now this will actually give us access. Let me clear my terminal and run, and that will give us access to our name gems. So let's go ahead and do the same thing for all the items that exist within our list. I'm going to basically go ahead and copy this, then I'll paste it, go to the new line and then paste it. So I'll call this item number 1. I'll go to the next one, which is item number 2, and I'll go to the next one, which is item number 3. So if I save and run our code once again, we shall now see that we are now able to access the different items within our list. But what if we wanted to actually access the last item within our list? And that's where negative indexes or negative indices come in. So a negative index allows us to access items beginning from the last item within our list. Let's say I wanted to access the last item within our list, which is Martha in this case. What would we do? In this case, what we'd use is to start from the index of -1. So let me add another comment at the top to just show you how these indexes are going to be. So I'm going to create a comment and then we go at the top. So at the top right here is where I'm going to go ahead and basically create our indices. So let's start with providing the index for the last one. So that's going to be -1. If we go to the next one, this is going to be our -2. And then here we shall go and this will be -3, and then we shall have -4 for the last one. So therefore, when you have a list that contains 10 items, the -10 will be the index or the negative index of the first item within the list, while -1 will be the index of the last item within our list. So let us try to access the name Martha by using negative indexes. So for us to be able to do that, what I'm going to do is to come right down here. So I'm going to say this is going to be negative. Let me correct this. So when I come and try to access our Martha, I'll say names, and then in here I'll provide -1. So if you run our code, I'll pull up my terminal, and now we shall see that we're getting Martha as the last item within our elements. So that's basically how we access items in a list by using indices. When given a list, one of the important things you may want to do is to find out if a certain item exists within a list. And that's where the in keyword or the in operator comes in. So in is what you use to find out if a certain item or element exists within a collection, whether a set or a string or any other collection, just like we're going to see in this video. So let's go ahead and try to use the in keyword to find out if any of the items that belong to this list exist, and then we see what values this is going to return. So what I'm going to do is to first of all begin by writing print, and then in this case what we're going to do is to find out if the name Martha exists within our list. So what we do is to first of all provide our variable or our value, and in this case it's Martha. Then we call our in variable or our in actually operator. Then we basically go ahead and try to find out if it exists within a certain collection. In this case, let's say our names. So if we go ahead and try to run our code, in this case we're going to now see that this is going to return true. So we can even make this interesting by basically making a program that basically checks if a certain item that the user has entered within our keyboard exists within our list. Let's go ahead and try to do that. So what we're going to do is to first of all go ahead and try to create a variable. So let's say a guess, and this is going to be some input from the keyboard. So we may ask the user to enter a name. And in this case, when they enter a name, we're now going to write an if statement that will basically check if that name exists within our list. So what we're going to do is to say if guess in and then names. So if this is true, of course, we're going to get true. So what we're going to do is to print, and then here we shall say that our guess, I'm going to write an F string, and then we shall say that our guess exists in the list. Now I'm just going to write an else statement, and that else statement is basically going to tell us that that given guess does not exist within the list. So what I'm going to say is else, and in this case what we shall do is to print. I'll use an F string still, and in this case we shall say that our guess doesn't exist within our list. So shall just basically say does not exist. And once we are done with this, let's go ahead and try to run our code. So if I pull up my terminal and then run our program, we're now going to be asked for a name. So when we enter one that exists, such as Martha, we shall see that Martha exists within our list. If we go ahead and run the same command and we provide a name such as Jonathan, in this case we shall see that the user does not exist. So using the in keyword, we can be able to find out if a certain item exists within a list or not. Each of the members in a list can be accessed by using an index. So let's say we had a list of names such as the one we used in a previous example. You can be able to access each of the items within this list by using an index. Now let me show you a simple illustration. So I'm going to begin by creating a comment right here. Actually, this is supposed to be a comment. So in this comment, I'm going to basically go ahead and place some numbers to just show you the indices of these specific items. So let us begin with the first one. So the first item of the list is always at index number 0. So I'm going to say it's going to be at index number 0. That means that the second one will be at the index number 1. So if I provide index number 1, I can go to the next one and then give it an index of 2, and then give this an index of 3, and that will go until the end of the list. So basically, if we have a list that contains 10 items, then the last item will be at the index 10 minus 1, or n. Let's say the length of our list is n. N minus 1 will be the index of the last item within our list. So if we want to access each of these items within this list, then we're going to use their indexes to be able to access them. So let us begin by accessing the name gems from our list. So the way we access our name is by basically going and printing or calling our variable, which is our names variable, and then we use the square brackets just like the ones you see right here. So in here is where I will go ahead and provide our index. Now let's begin by accessing the first one. So let me just actually go ahead and print this. So we go ahead and print our names. Now this will actually give us access. Let me clear my terminal and run, and that will give us access to our name gems. So let's go ahead and do the same thing for all the items that exist within our list. I'm going to basically go ahead and copy this, then I'll paste it, go to the new line and then paste it. So I'll call this item number 1. I'll go to the next one, which is item number 2, and I'll go to the next one, which is item number 3. So if I save and run our code once again, we shall now see that we are now able to access the different items within our list. But what if we wanted to actually access the last item within our list? And that's where negative indexes or negative indices come in. So a negative index allows us to access items beginning from the last item within our list. Let's say I wanted to access the last item within our list, which is Martha in this case. What would we do? In this case, what we'd use is to start from the index of -1. So let me add another comment at the top to just show you how these indexes are going to be. So I'm going to create a comment and then we go at the top. So at the top right here is where I'm going to go ahead and basically create our indices. So let's start with providing the index for the last one. So that's going to be -1. If we go to the next one, this is going to be our -2. And then here we shall go and this will be -3. and then we shall have -4 for the last one. So therefore, when you have a list that contains 10 items, then -10 will be the index or the negative index of the first item within the list, while -1 will be the index of the last item within our list. So let us try to access the name method by using negative indexes. So for us to be able to do that, what I'm going to do is to come right down here. So I'm going to say this is going to be negative. Let me correct this. So when I come and try to access our method, I'll say names, and then in here I'll provide -1. So if you run our code, I'll pull up my terminal, and now we shall say that we're getting method as the last item within our elements. So that's basically how we access items in a list, by using indices. When given a list, one of the important things you may want to do is to find out if a certain item exists within a list. And that's where the in keyword or the in operator comes in. So in is what you use to find out if a certain item or element exists within a collection, whether a set or a string or any other collection, just like we're going to see in this video. So let's go ahead and try to use the in keyword to find out if any of the items that belong to this list exist, and then we see what values this is going to return. So what I'm going to do is to first of all begin by writing print, and then in this case what we're going to do is to find out if the name method exists within our list. So what we do is to first of all provide our variable or our value, and in this case it's method. Then we call our in variable or our in actually operator. Then we basically go ahead and try to find out if it exists within a certain collection. In this case, let's say our names. So if we go ahead and try to run our code, in this case we're going to now see that this is going to return true. So we can even make this interesting by basically making a program that basically checks if a certain item that the user has entered within our keyboard exists within our list. Let's go ahead and try to do that. So what we're going to do is to first of all go ahead and try to create a variable. So let's say a guess, and this is going to be some input from the keyboard. So we may ask the user to enter a name, and in this case when they enter a name, we're now going to write an if statement that will basically check if that name exists within our list. So what we're going to do is to say if guess in and then names. So if this is true, of course we're going to get true. So what we're going to do is to print, and then here we shall say that our guess, I'm going to write an f string, and then we shall say that our guess exists in the list. Now I'm just going to write an else statement, and that else statement is basically going to tell us that that given guess does not exist within the list. So what I'm going to say is else, and in this case what we shall do is to print. I'll use an f string still, and in this case we shall say that our guess doesn't exist within our list. So shall just basically say does not exist. And once we are done with this, let's go ahead and try to run our code. So if I pull up my terminal and then run our program, we're now going to be asked for a name. So when we enter one that exists, such as method, we shall see that method exists within our list. If we go ahead and run the same command and we provide a name such as Jonathan, in this case we shall see that the user does not exist. So using the in keyword, we can be able to find out if a certain item exists within a list or not. A list is uniterable, and by this we actually mean that a list is a collection through which we can be able to iterate or repeat running a certain amount of code. Now let me explain why this is so. So using a for loop, we can be able to loop through each of the items that exist within this list, and then be able to execute some lines of code for all the numbers of terms or the elements that exist within this list. So let us go ahead and first of all begin by printing all the items within our list. So using a for loop, we can begin by writing a for loop such as for, and then we can basically say element, or we can actually go straight forward and say name. And in this case, we shall say for name in That's if a name exists within our list. And in this case, shall say for name in names, then you can go ahead and print an individual name. So if we try to save and run our code, in this case, when you run, we shall now see that this is going to go ahead and print each of the items that exist within our list. So another thing that we looked at when looking at for loops is the range function. So the range function allows us to be able to get values from a certain range. Let us try to create a list of values that belong to a certain range. And Python provides for us the list function to be able to help us to do that. Let's begin by doing that. So what I'm going to do is write another for loop. And this is going to check for number. And in this case, shall say for number. Now let's create a list of numbers. So in this case, you can say that our list of numbers is going to be created from the list. But this list is going to just basically take in the range of numbers from 0, sorry for this. And we're now going to have 0, then 100. So when you have that, you can go ahead and say for number in numbers, then we can go ahead and print all our numbers. So let's first of all begin by commenting this out. So just going to come and comment what we have here. So if I comment that out, I can go ahead and run our code, and now we shall see that our for loop is going to basically go ahead and loop through each of the items that we created in our list of numbers. If you are to create a list, you're basically creating an object that is very similar to some of the objects we've created most of the times when we are creating variables. But this list or this variable will basically belong to a certain type. Now let's use the print or the type function. So I'll just come here and say print, and I'll find out the type of the list we've created. So in this case, I'll provide the list. So in this case, we are going to provide our names list, and we try to run our code. We're now going to see that all the items of a list, or actually a list, belongs to the type of list or the class of list. And what does this mean? This is an object, and therefore it will have some behaviors or methods. So methods are just functions that you call on a certain object. We shall look at this when we are looking at classes later on. But let's say if you had a list such as the one for names, then we can be able to basically call some methods onto this list. Let us begin by looking at how we can be able to add items to this list. So all lists in Python have the .append method, and what this does is to add elements onto the list but at the end of the list. Let us go ahead and look at this. So if we have a list of names such as the one we have here, we can go ahead and basically call names, and then when you say dot, we shall have access to all the methods that belong to this specific list. So what we want is to access the append function or the append method. So this basically takes in an object of any type, and then let's say we wanted to add the number 12. When you go ahead and print our list, so in here we shall basically have our names. If we go ahead and print it at first, so shall print names at first. So this is going to be names before we add an item, and this will be names after we add an item. So let's go ahead and run our code. Now I'm going to begin by first of all commenting what we have here. So I'll save. And when you go ahead and run our code, we shall notice that a new item has been added onto the list, but at the end. We can also go ahead and insert or be able to add an item at a certain position within our list. Now to do that, we use the insert function or the insert method onto our list. Now let us look at how we can be able to do that. So given our list of names, just like the one we've modified by adding an item to the end of the list, we can also go ahead and do the same thing. So we can do names dot insert, and in this case what we have to do is to first of all target a certain index. Now let's say we wanted to change the name Jerry. We have to enter its index. Its index is at position number 1. So we say 1. Now we can produce or basically create another name. So let's say Jackson. So if we go ahead and print our list once again, in this case, what we do is to go, what we shall have is, if we run our code, shall now see that our list, which had a name of Jerry at the position of 1, now has the name Jackson, and this has changed just like you see right here. So what does this show us about lists? So there are two terms that we need to get to understand right here. This collection called a list is what we call a mutable sequence or a mutable collection. So by being mutable, we actually mean that we can be able to modify or change items that are within this list, which is not the same thing for a string. So let's try to do the same thing for a string. So given a string such as, let's say, name, and let's say our name is Jonathan. If we have this name, we cannot go ahead and modify it by using any index or basically changing any letter, just like I'm going to try. So if we say name and then we use an index, we can say, let's say we're updating the letter at index number 2, and let's say we wanted to make this capital M, just like you see here. If we go ahead and print our name, what is going to happen is, if we run our code, we shall get an error, and this will tell us that string object does not support item assignment. Now in this case, what we have done is to change the item at a certain index within our list of names, just like you see right here. We can also be able to do the same thing just like we're trying to do here by doing item assignment. So what I can do is to get rid of this example, which was just for demonstration purposes, and then we try to use item assignment to assign a value to a certain index within our list. So what I can do is to say names, and then we say, let's say the first item, want to change that to have a name of, let's say, Joel. So if we go ahead and print our names list, right now what we're going to notice is if we run our code, we shall now have our first item of the list being changed to Joel. So this basically shows us that we can be able to change items within a list, which is not the same thing that we can do for some of the sequences that we've looked at, such as strings. At this point, we've been able to look at how to add items within our list, but we have not yet looked at how we can remove items from our list, and that's where the pop function comes in. So the pop function is one that allows us to remove items from a list basing on our indexes. It defaults to only removing the last item within our list. That's if we've not provided an index. And what it does is to actually return the value of that item that we have deleted from our list. Let us try to look at that. So if we went ahead and printed something like names dot pop, what will happen is that we're going to get rid of the last item. In this case, it's James, and then we shall return that specific value, which is going to be James. So that means we shall have to print an updated list. So if we print our updated list, in this case, what we want to do is to return the list, but without the last item. So if I run our code right here, we are now going to see that this is going to return James after removing James from our list, and then our updated list will be one that does not have James being the last item within our list. So basically that's how the pop function will work in case we have not provided an index. But let us look at how it will work when we provide for it an index. So if we go ahead and do the same thing, so I'll copy what we have here and then paste it on a new line. So in here, what we're going to do is to go ahead and provide an index for the list or the item we want to delete from the list. Now let's say I wanted to get rid of the name Jerry. So if you've been following up to this point, you now know that the indexes start from 0. So that means that Jerry will be at index number 1. So if we wanted to remove Jerry at index number 1, all we have to do is to say names.pop, and then you provide our index, which is going to be 1. So if I go ahead and save, if we run our code once again, we shall see that Jerry will be popped out of our list, and then our new updated list will be a list but without the value of Jerry. And that's how the pop function works. Python also provides for us the remove function that allows us to remove a certain first occurrence of a certain item within our list. If you're to see our list right here, we actually have two values for the name gems. So we have the first one and we also have the second one. Now I'm going to get rid of what we have here. So what will happen is if we use our names.remove, it will look for that specific item we want to remove from the list, and if it occurs more than one time, it will actually go ahead and delete the first occurrence. If it does not exist for more than one time, it will delete the only occurrence of that specific item that we may have within our list. So if we go ahead and do something like names dot remove, and then we provide our gems. So I'm going to provide our first name, which is gems. So if we go ahead and print our names list, we shall now see that our list is going to be printed, but the first occurrence of the name gems will be removed from the list, giving us a list with only 4 items and the second occurrence of gems. But if we wanted to remove a name such as Jerry, so let me update this to Jerry. What will happen is this will go ahead and remove Jerry, and then we return a list without the name Jerry. So that's how the remove function works in Python on lists. At this point, we've been able to look at the fact that we can access these items of a list by using their indexes. We can also be able to use these indexes to be able to return certain portions of these lists. And that's where the concept of slicing list comes in. So when you slice a list, you can be able to return that list, only returning a portion of the items that exist within that list. And you can be able to achieve this by using the indices or the positions of the various items that exist within this list. So when you go ahead and print our list, so you can go ahead and print our list, and then let's say we wanted to access the value at index 0, which is our first item. So that's going to return our first item. In this case, that's going to be gems. But if we wanted to return our portion, let's say we wanted to only return values such as James, Jerry, and then Maria in a separate list, that means that we are going to use these indexes of these positions to be able to return those items. So for us to be able to achieve that, what we're going to do is to write the same syntax, but we shall have to provide our colons, and then we shall also provide an index that is going to be like the ceiling or the last position that we shall not include within our list. So in this case, if we wanted only values James, Jerry, and Maria, what we have to do is to exclude the one for Martha. So that means we shall have to provide its index as 3, which shall not be included in our final result. So if we go ahead and provide our index number 3 right here, and we run our code, in this case, we are going to see that this is going to return James, Jerry, and Maria. Now, if we wanted to include Maria, that means we shall have to include the item or the position of the item that exists after Maria. And that is going to be the one that starts from position number 4. So if we go ahead and run our code, we shall now see that that is what is going to be returned. Now, let's say we wanted to return all the items from, let's say, Maria, all the way up to Abel. So that basically means that we shall have to provide our first index as 2, and then our last index will be 7. Let us try that out. So if I pull down my terminal and do the same thing, so I'll just copy this and then go to the next line and paste it. All we have to do is to add 2, which is our start index, and then 7, which is going to be our excluded index or our end index. So I'll come right here and say 7. So if I save and try to run our code, shall now see that this is going to return Maria, Martha, James, Jimmy, and Abel. So it will exclude the last item, which is going to be our value for Herbert. Now, this is one of the ways in which you can use slicing, but when you provided both the start value and the value that you want to exclude at the end of the list. So let us look at ways in which you can be able to only provide the start index. So let's say I wanted to access items from a certain index, such as index number 5. sorry for this. So I'll be able to do that by simply coming right here and saying print names, and then we can provide our index, which is going to be 5, and then we provide our colon. So what this means is we're only going to start from index 5 and then basically provide all the items that exist after the index 5. So if we go ahead and print right now, we shall have only items Jimmy, Abel, and Herbert. So that's basically the list that we're going to return out of that specific slice. So the same thing would happen if we wanted to access items by only providing the end value. So let's say I wanted to only provide items that exist and exclude, let's say, the name Abel. So the name Abel exists at the index number 6. So if we go ahead and do that, so let's try to do the same thing. So if I print, let's say, names, sorry for this, this is going to be our names. And in this case, what we shall do is to provide our index. So our index is going to be 6. So let's observe what is going to happen. If I pull up our terminal and run, we shall now see that this is going to run and print all values that exist from the first one up to the last one, which is going to be Jimmy. So it will go ahead and only exclude items starting from index number 6. And that's how we can slice a list in Python. Every time we have a list, we can be able to modify it or change the order in which its items are. And that's where the sort function or the sort method comes in. So the sort method is one that allows us to be able to update the order of the list by basically sorting them in a certain order. So we have a jumbled list of items like the one we see right here. But when you call the names method or the names function on this list, let's see what is going to happen. So we can say names dot sort. And when you call this, what we're going to do is to go ahead and save. So let's actually print the updated list. So if we say print names, we can now go ahead and print our list. So I'll say Python main.py, and this is going to set or sort our list, and it's going to return it in an alphabetical order. This can also work for items in other values. So let's say we had a list of numbers. So let's say this is going to be nums, and let's say we had 1024, and then we had 64, and then we had something like 256, and then we said 512, just like you see right here. So if you had a list such as this one, you can also do numbers dot sort, and this will basically go ahead and return our updated nums list. So if we went ahead and ran our code, what it's going to do is basically sort this in an ascending order, just like you see from the smallest all the way to the biggest. There exists a number of methods we can call onto a list, and I'm going to leave a chart on the screen so that you guys can go ahead and check them out and be able to find out what they do. For the previous examples, we've been looking at lists that have only one dimension, lists that only have items that do not have multiple lists that are contained within them. And in this example, what we're looking at is a list that basically has all these items that are lists, and then within those lists we also have other lists. Now these are what we call multidimensional lists. A multidimensional list is one that contains multiple lists within itself. Those lists can also contain other lists and also contain other lists, just like the one you see right here. So what you have is a simple table example, and this table basically has users, their age, as well as the list of hobbies or things they want to do in their free time. Now, let us look at how we can access the items that exist within such lists. So, assume we wanted to access the user whose name is Jonathan. We'll do that normally, just like we access any item within a list. So that means we shall go on and access their index, which is going to be the position 0. And then when you try to print this out, we're now going to see that this is actually printing 0 or a list of 0. So let's update this to basically return our table and then the index 0. So if we go ahead and try to run this, we shall now see that this is going to only return the list that contains Jonathan, his age, as well as some of his hobbies. But what if we wanted to dig deep and find out some of the items that this list has? So that means that we're also going to add indexes to the current index we are provided. So let's say I wanted to access Jonathan's hobbies. So now the name will be at index 0, the age will be at index 1, and then the hobbies will be a list, but that list will be at an index of 2. So if we try to access this, then that means we are going to basically go ahead and try to access the index of 2. So if we go ahead and try to run our example, we're now going to see that we are only going to access the items that exist within our list by the index of 2. And that's what it's going to return. Now let's say I wanted to go ahead and use a for loop to loop through each of these lists and return only the hobbies that all of these people have. So let's go ahead and try to do that. So we're going to write a for loop. So I'm just going to come right here. And what we're going to do is to say for user in table. So basically we've called each of the lists that we have within our table user. We can now go ahead and print our user. So if we print our user, when you try to run this code, it will go ahead and print all the users that exist within our table, just like you see right here. But if we wanted to dig deep and find out the hobbies, so we want to be able to add or append all these hobbies to a list. So let's go ahead and try to create that list. So shall call this hobbies, and this will basically keep all the hobbies for all our users. So I'm just going to create it as an empty list, and what we need in this case is to go ahead and first of all access these hobbies. Now if you're to notice, all these users have a certain pattern, which means our hobbies are all existing at index number 2 of all the lists that we have here. So let's go ahead and try to access this. So we can say user, and in this case we can access index 2. So for each of our users, which is a list, we can now access the hobbies at the list that is at index number 2, just like you see right here. So if we go ahead and try to run, now we can be able to access only the hobbies that these have. So let's go ahead and append all these to our list. So what we can do is to come right here and then say for user in table. Then what we want to do is to say hobbies dot append, and in this case what we can do is to go ahead and append our hobbies. So we shall now say that hobby, or a single hobby, is going to be the one at the index 0 for each user. Actually the index 2 for each of our users. Now just come and say user 2, and then we shall go ahead and append this. So we shall say hobby, and after doing that, then we shall just basically go ahead and print our hobby. Such is going to be hobby. So if I save and try to run our code once again, we're now going to see that this is actually going to have movies only as the list. So this is going to be, we have actually printed hobby, but if we print hobbies, so this will return a list of only the hobbies. So this is just a simple example of how you can access items that belong to a list that has multiple lists within itself. Using lists, we can modify a function to make it one that can allow us to provide as many parameters as we want. And that's where list unpacking comes in. So given a function such as the one we have right here for adding x and y, what it does is to take in values x and y and then basically return the total of these values. But what if we wanted to update this function so that it basically takes in as many parameters as possible, or arguments as possible? And that's where list unpacking comes in. So The first thing we have to do is to go ahead and provide a parameter that's going to be the one for all the values of the list we shall unpack for this case. So what we're going to do is to come right here and provide the next argument as our value of parameters. So we use the star notation, so I'll say star, and then I provide values. So when you have star values, this basically means that we shall have all the other parameters that we shall have to provide for this function, and that will create a list of these parameters which shall go ahead and loop through and then be able to carry out whatever we want within our function. So to begin, we shall have to first of all have a total. So in this case, we can have a total which is going to be equal to x and then plus y. But what we need is to return this total for all the parameters that will be provided for this function. Now for us to be able to do that, since we are going to get all the values for the parameters as a list, then we'll loop through all those values and then be able to add them onto our total. So for us to be able to do that, we shall say for value in values, which we have provided in our function as a parameter right here. So shall access our values, and then after adding that, then we're going to append each of our values to, actually not append but to add. So shall just update our total to one that basically has each of our values. So shall say total plus equals value. So that will basically help us to increase our total by each of the values provided as parameter. So once we've been able to do that, and we've been able to do it for all the parameters, all we shall do is to go ahead and return our total, just like you see right here. So if we go ahead and call this function, we can call it with as many arguments as we want, simply because when we provide our value for x and then we provide our value for y, we can go ahead and provide multiple other arguments. So let's go ahead and do that. If we come right here, I'm going to go ahead and print. So we shall call our add function. So it's actually going to be our add, and then we shall for the first positional argument we shall provide 12, and then for the second one we shall say 23. Then for values, let's say 45, then we shall say 56, and then we shall say 78, and then we shall say 90, and so on. So when you go ahead and run our function, this is what is going to actually happen. So I'll pull up my terminal, and then when I run, what will happen is it will print the total of all the numbers that exist within this function call. So this basically means that we can provide as many arguments as we want to this function, and it will still unpack all the arguments and provide them within our function for it to be able to carry out whatever it has to carry out. Let us look at another way that Python allows us to keep data, and that is by using tuples or tuples. So tuples are a way in which Python allows us to store data, but the difference between these tuples and lists is they are immutable. So by immutable, it actually means that we cannot be able to change any of the items that exist within a tuple. Let us look at how we create tuples. So the first way in which you create a tuple is by basically creating a variable. Let's say we're creating a variable called names, and then giving that a value of empty parentheses. So these empty parentheses are the way we enclose the items that exist within a tuple. Now another way in which you can do that is by basically using the tuple function. So all these tuples belong to a class of tuple. That's what we can find out by printing and then using our type function to basically find out what this names variable is going to be. So if we run this, we would get our class of tuple, and then if we go ahead and try to create another tuple using our tuple class, we can just say numbers, and this is going to be a call to our tuple or tuple function. Now this is going to take in a list. Let's see if we are to add some items, but let's not add them for now. So I'm going to save, and when you try to pull up our terminal, we can also go ahead and maybe print. So I'll say print and then use our type function to find out what the numbers tuple is. So if we go ahead and run our code, we shall now see that we have a class of tuple. Let us go ahead and add some items within our tuples. So for the first case, what we're going to do is to simply add values, and all the values that will exist within our tuple are just simply going to be comma separated. So let's begin by providing some names. So I'll say Bob, and then I'll say Kevin, and then I'll add, let's say, Tom, and then I'll also add Jerry. Sorry for this, let me close this. So I'll kill this and close. So what we have here is basically a tuple that basically contains our names, just like we've done right here. So if we go ahead and print this, so I'm going to comment this out, and then what I'll do is to just add a simple print of our names tuple. So when you go ahead and pull up our terminal, when you run this, we shall now see that it's going to print out a tuple with all these comma separated values of our names, which is good. So let us see how we can be able to do the same thing by using our tuple function. So the tuple function right here allows us to create an empty tuple. That's if we've not provided any iterable or any collection. But what if we provided a collection? Let's begin by using a collection of numbers. Now a simple collection of numbers we can have right here is a list of numbers. Let's go ahead and provide a list of numbers. So what I'm going to do is to come right here and then provide a list of numbers. So in here I'll say that we're going to have a list of numbers. So let's say 1, 2, actually let's say 1, 3, 4, 45, 56, 34, and so on. So once we've been able to do this, if we go ahead and print our numbers tuple, so I'll say print and then add numbers, this will go ahead and basically return our two tuples. We can also be able to do this by basically providing another collection or sequence such as a string. Let us look at how we do that. So what I'm going to do is to come right here. Now let's say we are now going to have a tuple of letters that exist in a certain word. What you can do is to use our tuple function, and then in here what I'll do is to provide a string. So the string is going to be the iterable in this case, or the collection or the sequence that we shall iterate over and then create our tuple. So in this case it's going to be, let's say, my name, which is Jonathan. So if we go ahead and print our tuple of our letters, we shall now see that this is going to return my name, but it's going to return a tuple of all the letters that exist within my name. So that's basically how one of the ways we can create a tuple. But let's go ahead and also look at another interesting and weird way that Python provides for us to create tuples. So I'm going to first of all get rid of what we have here. So I'm going to get rid of these print statements, and I'll get rid of these print statements also. So once we have this, then let's go ahead and look at this way that many of you haven't thought about, or that may seem weird to basically use. So one of the ways that we can create a tuple is by basically creating a variable. Now let's say we were to modify our names list or our names tuple. Actually it's a tuple. So the way we'd modify this is by saying names and then basically creating a bunch of comma separated values but within this variable. So let's say we're going to have the same names that the ones we have here. So I'll just copy all of the names that we have here and paste them right here. This will be one valid way in which we can create our tuple. And if we go ahead and print our names, if we run our code, we shall now see that this is actually going to return a tuple of all the strings of the names that we provided within our tuple. This is one really interesting way in which we can also create a tuple in Python. One of the ways that separate how we create a list from how we create a tuple is that when we're creating a tuple and we have only one item in that tuple, then the item has to be followed by a comma. Now let me show you how that comes up. So if we are creating maybe a tuple that's going to contain only one name, so the way we'd be able to basically go ahead and provide a value or place an element within this tuple is by using our value. So in this case, let's say we have our name as Jonathan. So if we go ahead, let's try to print this out. So if I go ahead and print the type of our variable that we've created here, so I'll say type, and then we have our name. Let's do the same thing for tuple that contains a comma after the element. So I'll create the same variable name and I'll update its value to have a tuple. So in this case, I'll say this is going to be Jonathan, but then we shall have a comma. So if I go ahead and save and try to run this again, we shall now see that for the first one, we're actually having the type being a string. So forgive me for this. So the type of this is going to be a string. Let's go ahead and try to find out the type of the second name variable. So if we try to print our type of the name variable after updating it, in this case, what we shall see is that we are actually going to be creating a tuple. So most of the times when you have a tuple that contains only one word or one value, or be it any variable, that tuple will have, that element of the tuple will have to have a comma after it, just like you see right here. So that's some important observation you need to make. Tuples are also iterable. Similar to lists, we can be able to iterate over every item within a tuple and then be able to execute some code. So let's try to use a for loop to iterate through each of these numbers and be able to return multiples of 3. So we're going to do that is by basically using our for loop. So we shall say for element in, let's say, numbers, then we shall try to find out if any of these elements is actually divisible by 3. So we shall use our if statement, and then we shall use our modulus operator. So in this case, I'll say if element modulus, so in this case it's going to be modulus 3. If that compared to 0 is true, then what we shall do is to simply go ahead and print that specific number or that specific element. So when we do this, let's try to run our code and see what will happen. So I'll pull up my terminal, and then when we run, we shall see that this is going to actually return all those items or elements of our tuple that are divisible by 3. Similar to lists, we can also access the items that are inside a tuple by using indices. Now, given a tuple such as the numbers tuple we have over here, we can also access its items by using indices. Now, let's say we wanted to access the first item of this index. We can try of this tuple. We can use our indices to access each of the items. Now, let's say we wanted to access the first item. Then we'll do numbers, and then using our square brackets, we'll provide an index. Now, this is going to return the first item. So if we run, this is going to return number 1. And if we wanted to return the last item, then we would actually do the same thing, just like we did in lists. So we'll do maybe -1. Sorry for this. So this will be our -1. And after doing this, then we shall go ahead and print the same thing. So this will give us the value of our last item within our tuple, just like you see right here. Since a tuple is also a collection, we can check for the membership or the existence of a certain element within our tuple. Now in this case, we can use the in operator similar to the one we used in the lists example. So we can maybe try to find out if a certain element exists by first of all providing that element. So let's say the number 45, and then using our in operator with that specific collection, in this case, which is going to be our numbers. So if we go ahead and try to print this out, we're now going to see that this is going to return true, meaning that we have our value of 45 existing within our numbers tuple, just like you see right here. Similar to lists, we can be able to use the length function to find out the length of a certain tuple. Now in this case, we are going to print, so let's say I wanted to find out the length of this tuple, we would say f string, and then in this string we may type something like the length of the tuple. So in this case, we can actually provide the tuple. So let me just provide it in here. So we can say numbers, and then here we can use our length function. So I can say is, and then right here, let me change this to is, And in here, we can use our curly braces to provide our value within our string. So I'll say len, and then we provide our numbers tuple. So if you print this out, this is actually what we're going to get. The length of the tuple with all these values is going to be 9. And that will give us basically all the items, or the length of the items that exist within this tuple, just like that. Another way we can be able to find out the number of times a certain element occurs within our tuple is by using the .count method on our tuple. Now in this case, let's say we had a value such as 3 existing, let's say, many times within our tuple. Let's say I wanted to find out how many times it exists, so we'll call, let's say, print, and then in this case we would call the numbers.count, or the tuple.count method, and then we would call it with that specific value you want to check. So in this case, that would be a number of 3. If I save and run our code, right now we shall see that we have 3 occurrences of our number 3 in our numbers tuple, just like you see here. Similar to lists, we can be able to use the length function to find out the length of a certain tuple. Now in this case, we are going to print. So let's say I wanted to find out the length of this tuple. We would say f-string, and then in this string we may type something like the length of the tuple. So in this case, we can actually provide the tuple. So let me just provide it in here. So we can say numbers, and then here we can use our length function. So I can say is, and then right here, let me change this to is. And in here, we can use our curly braces to provide our value within our string. So I'll say len, and then we provide our numbers tuple. So if you print this out, this is actually what we're going to get. The length of the tuple with all these values is going to be 9. And that will give us basically all the items, or the length of the items that exist within this tuple, just like that. Another way we can be able to find out the number of times a certain element occurs within our tuple is by using the .count method on our tuple. Now in this case, let's say we had a value such as 3 existing, let's say, many times within our tuple. Let's say I wanted to find out how many times it exists, so we'll call, let's say, print, and then in this case we would call the numbers.count, or the tuple.count method, and then we would call it with that specific value you want to check. So in this case, that would be a number of 3. If I save and run our code, right now we shall see that we have 3 occurrences of our number 3 in our numbers tuple, just like you see here. One really important keyword that I did not talk about when dealing with lists is the del keyword. And the del keyword allows us to delete certain items or delete an entire collection. Now in this case, we are having our tuples, which is our numbers tuple we've looked at in the previous examples, and then we are having a del keyword, and we are trying to check if it will delete the item that exists at index 0 in our tuple. We also have a list right here that is created from my name, which is a string, and what we're trying to do is to delete the first item within our name, which will be the letter J, just like you see right here. So let's try to run this code and see what will happen. So if I pull up my terminal, when I try to run, we shall now see that our tuple object does not support item deletion. Now the reason as to why this is happening is our tuple is an immutable object, so we cannot be able to change any of its items or delete or update, or basically try to modify our tuple in a certain way. I'm going to get rid of our statement right here, and let's try to do the same thing for our letters list. So if I come right here and run our code, we shall now see that our code is going to run, and the letter J will be deleted from our letters list, just like you see right here. So let us try to use the del keyword to delete a tuple. So I'm going to get rid of the code that we have for our list right here. So for us to be able to delete a tuple, all we can do is to maybe say del and then say numbers. So this will basically go ahead and delete our tuple. And if we try to print our tuple right here, so let me get rid of this print statement, we shall now see that our tuple is not defined. And this is simply because the del keyword will basically get rid of the variable numbers as well as the values that are contained within that variable. Given a tuple, we can also be able to access the index of a certain item within this tuple. Now that's where the index method comes in. So what we're going to do right here is to come and simply print out. So I'm using print because I need to put this in the output. But if you wanted to access the, let's say the index of, let's say number 3 in our entire tuple, which is at index number 1, then we would call that .index method. So I'll say numbers.index, and in this case what we'll do is to basically go ahead and provide our value, which is number 3. Now in this case, when you go ahead and run our code, what we're going to do is to get the index of number 3, which is at index 1. Now if we wanted to find out maybe of 45, we'll do the same thing, and that will bring us to, let's say I wanted to find out the one for 456, then we'll run our code, and that will still give us the index of that specific value, which is number 7. Similar to lists, we can also concatenate two tuples. Now let's create our two tuples. So in this case, let's say we have a tuple such as numbers 1. I'm just going to call this nums 1, which is going to stand for our first numbers tuple. So in this case, I'll give it values 1, 2, 3, and then I'll give the second one values. So I'll say nums and then 2, and this will be equal to, so I'll say in this case that we shall have number 2, and here we shall give in values such as 4, 5, and 6. Let me actually make this 4, 5, and 6. So using the plus or the plus symbol, we can be able to concatenate or join these two tuples to create one tuple. Now let us create one final tuple. So we shall say, let's just call it numbers. And this is going to be our nums 1 plus nums 2. And if we go ahead and print this out, what we shall get is basically a tuple that contains all of these numbers or all of the values that are contained within each of our tuples. Now if we go ahead and try to run this, we shall now see that this is going to return for us 1, 2, 3, 4, 5, and 6. The same thing can happen with lists. So let's say we change them and updated them to be lists. If we made this be a list, so I'll remove the commas, I'll just make this the first list and also the second list, and then we shall have one list that will contain the values of both of the lists. So if we try to run again, we shall now see that we shall get the same output for a list that contains all the items that are contained in the two lists. At this point, we've looked at lists and tuples. Now let us look at dictionaries. Dictionaries allow us to be able to store data that is in a form of a mapping. By a mapping, I actually mean that for each of the data I want to keep, there exists a key value pair. Now in this case, let me give you a very simple example of a phone book where we may want to keep a name and map that name onto a value of its phone number. Now what we're going to do is to first of all create that dictionary. So I'm going to begin by creating a variable. I'm going to call this our phone book. And within this phone book, I'm going to go ahead and create various people. Each of these people are going to be mapped onto a phone number. Let us begin by providing the first person. So I'll say Jonathan, and then by using that semicolon, actually it's a colon, by using that colon we can then map this user to a specific number. Now in this case, I'll say 078, whatever it is. I'll just provide it as the phone number and then go to the next user. So in this case, I'll say Jerry, and then Jerry will also have 567, and that's, then we can keep another user. So let's say Joan, and Joan, let's say Joan, and Joan will also have a certain phone number associated with their name. Now, the way we can access each of these values is by accessing them by using our keys. So we're going to go down here, and I'll print this out to the console. So I'll say print, and when I say print, in this case, what we're going to do is to say phone book, and in this case, we shall provide our name. So in this case, we're going to provide each of our keys. So we have the names being the keys, and then the phone numbers in this case are the values. So if we want to access the phone number of, let's say, Jerry, all we'll do is to go right in here and use the key, which is the name. And in this case, the key will be Jerry. So if we go ahead and print this, we shall now see that this is going to give us the phone number that's associated with Jerry. If we try to do the same thing for the rest of the people that we have within our phone book, in this case, let's say we are going to try for Joanne, and then we try for Jonathan. So if we try for Jonathan, still what we'll get is a phone number associated to that one of Joanne, which is the first one right here, and then we shall also get that is associated to Jonathan as the last phone number right here. So that's just one way in which you create a dictionary. But a dictionary can also be created by using the dict function. So by using the dict function, all we have to do is to provide an iterable, but that iterable has to have tuples. Those tuples can be in form of a key value pair. So let us create another dictionary. So I'm going to comment this print statement out, and then on the next line, what we want to do is to create a dictionary that's going to keep a person's data. Now picture a table in which you are keeping user information. In this table, we can keep things such as the name, the age, and the gender of a person. So in this case, what we can do is to go ahead and create a person dictionary. And within this person dictionary, we can be able to create, using the dict function, we can pass in an iterable. Now in this case, what we want to do is to pass in an iterable that contains multiple attributes about a person. So what I'm going to do is to pass in a list, and this list is going to have tuples. So in here, let's say we're going to have our name, and in this case, I'll provide the second value in our tuple as the name Jonathan, and I'll provide another tuple. So in this case, I'll provide the tuple that has the age, and I'll give the value of the age as 24. And then after that, I'll go ahead and provide our gender. So in this case, I'll say gender, and I'll provide the value as male. So once I've been able to do that, if we try to print our person dictionary, I'm going to save with Ctrl and S and then pull up my terminal. So if we try to print our person, we shall see that this is going to create a dictionary, and this dictionary is going to have multiple values, and these are going to be mappings. So the first mapping is the one that maps our key of name to our value of Jonathan. The second one maps our age onto the value of 24. The third one is going to map our gender, and it's going to map that onto the value of male, just like you see right here. So that's just a way in which you create a dictionary. Another way we can be able to create a dictionary is by assigning values to an empty dictionary. So what I'm going to do is to come right here, and then I'm going to first of all comment this out, and what I have to do is to create another dictionary. Now this dictionary is going to be for, let's say, students. So let's say we're keeping data about students. Now I'm just going to come and say student, and this student is going to be an empty dictionary similar to what we did right here. So the way I'm going to assign values to this student is by using assignment. So I'll just come and say student, and then I'll provide these square brackets. Now in these square brackets is where I will actually provide a key. Now in this case, what I'll do is provide the full, so I'll call this our full name. And then when we provide this full name, we can go ahead and provide our name as Sally Jonathan. So by doing this, if we go ahead and print out this dictionary, so we can say print student, and when we pull up our terminal, we'll now see that this is going to create a simple dictionary, and this dictionary is going to have our full name as well as its values. So just like this, we can be able to see that dictionaries are simply mappings that map each key onto a value. So we can have as many keys as we want, and each of those keys can be associated with a certain value. Let us go back to our phone book example. So we've looked at the different ways in which you create a dictionary, and one of them is by using item assignment. But that can also give us a clue on how we can be able to access as well as to update some of the items that exist within a dictionary. Now let us try to access Jonathan's phone number. So for us to do that, I'm just going to simply go ahead and print. Then in this case, what we shall do is to call our variable for our phone book. Now we're going to use these pair of square brackets and then provide a key, which is going to be the name of that specific user we want to access from our phone book. And in this case, we are going to get the phone number for Jonathan. So if we save and try to run our code, we will now see that we'll be accessing Jonathan's phone number. But using this way, we can also be able to do some interesting stuff. For example, we can be able to add other phone numbers onto our dictionary. So let's try to do that. So I'm going to come right here, and all I have to do in this case is to go ahead and say phone book and then provide another name. So let's say we are going to provide a name such as Donald. And in this case, we shall say that their phone number is going to be 123456. So once we have that phone number, all we have to do is to print our updated list. So I'll say that our updated, it's actually a dictionary, sorry for that. So I'll say our phone book. When you print our phone book, now we shall get an updated phone book with a value of the phone number that belongs to Donald. So basically doing that, we'll update our dictionary and be able to add onto the values another mapping. Every time we create a dictionary, we are actually creating a dict object. So if we try to find that out, we'll print our type. So we'll use our type function, and in this case, we'll provide our phone book. So when you do this, if we try to run our code, we shall now see that this is going to bring back the class of dict. So this class or this type of dict will be able to help us to access certain commands or certain methods that will help us to carry out various operations while using these dictionaries. So what I'm going to do is to access the first method. So I'm going to comment this out, and the first method we're going to actually work with when dealing with dictionaries is going to be the items method. And what the items method basically does is to help us to access each of the items that we have within our dictionary. Now keep in mind that this is not an iterable. We cannot be able to run a for loop on a bare phone book or a bare dictionary. But using that .items, we can be able to do exactly that. And let's see how we can be able to do that. So what I'm going to do is to go ahead and print, because we want this in our output. So what I'm going to do is to come here, and all I'll have to do is to call our phone book, and then dot, in this case I'll say items. And when you call our items, when I save, in this case, when you run our code, we shall see that this is going to return dict items. So this is basically going to be like an iterable containing multiple tuples, and each of those tuples will be all of the items that we have within our dictionary. So if we go and look at our key of Jonathan and its value, we shall have a tuple that contains Jonathan and the value of the phone number for Jonathan. The same thing will happen for Jerry, for Joanne, for Jackson, and for Charles, just like you see right here. So this is basically what will happen. And this is very helpful if you want to maybe loop through each of the items that exist within our dictionary. So let us go ahead and do that. So what I'm going to do is to come right here. So I'm going to update this so that we don't only print out that list of items, or we use a for loop, and then we can say for item in phonebook.items. So I'll say phonebook.items. If we go ahead and print our item, run our code once again, we shall see that this is going to print tuples, and these tuples are going to be mappings of a key, which is the name, and the value, which is going to be the phone number for that specific name. Now, if we want to make this interesting, what we can do is to go ahead and access the keys as well as the values. So the way we do that is by updating our item so that we can be able to access both the key as well as the value. So what we can do in this case is to say key for key, and value in our phone book dot items. So what we're going to do in this case is to use an f string to basically display this in a very nice way. So I'll say print and then f. So this is going to be a simple f string. Now what we will do is to say name, and then we shall say that we provide our name in here. So I'll just provide the key, and then what we can do is to maybe make an arrow, and here we shall have our value being the phone number. So we say phone number, and the phone number will be that specific phone number for that user. So that will be our value. So if we do this, I'm going to go ahead and run the code. So when we run our code, we shall now see that our output is going to be displayed in this very nice way. So we'll have the name Jonathan mapping onto the phone number, which will be this, Jerry mapping onto this, and then Joanne mapping onto this, and it will be very nice, just like you see right here. There also exists a method for accessing all the keys that we have inside our dictionary. Now let's say instead of printing out the keys and the values, the only thing we wanted to do is to access only the keys. So I'm going to comment our for loop out, and when I comment that out, we're going to go on a new line, and on this new line what we're going to do is to go ahead and print. So in this case we'll call our phone book, and our phone book we are going to call dot keys. So this is also a method similar to the one of items. So what this is going to return is an iterable or a list of keys that belong to this specific dictionary. In this case, you can notice that the keys are the names of the respective people whose phone numbers are being kept in this dictionary. So if we go ahead and run our code, we'll now see that this is going to return dict keys, and inside here we're going to have a tuple that we're going to actually have a list that contains all the names that we have in our dictionary as keys. The same thing can happen if we want to access our values. So if we want to access our values, what we can do is to say print, and in this case we can say phone book, and here we're going to say phone book dot, in this case we're going to access our values. So when we access our values, when we go ahead and print this, we will now see that this is going to return our values, and all these values are going to be in a list just like you see right here. Now if you want to access or be able to print these out, since they are in an iterable format, you can just say for I in, let's say phone book dot keys, then you can go ahead and print your key. Actually, you're going to print your element, which is I. So we'll go to call this. This is a method or function, so I have to call it. We can do the same thing for our values by saying for I, or you can even make it straightforward by saying for value, and in this case you can say for value in phone book dot values. Then we can go ahead and print each of these values out. So we can say print and then value. So once we've been able to do this, when you pull up our terminal, we're now going to see that this is going to actually return all the keys, and this will also return all the values that exist within our dictionary. We can also be able to check for the items or the existence of items within a dictionary, and that is by using their respective keys. Now in this case, if we want to check if Jonathan really exists in the dictionary, all we have to do is something like Jonathan, and then using the in operator, we can say in, and then we provide our phone book. So if we go ahead and print this out, let me just drop this in a print function. So if we print this out, if Jonathan exists within our dictionary, we will be able to get true, because it's going to actually check and find out that the key Jonathan exists within our dictionary. Now if we wanted to do another key, so let's say provided another key such as Harry, who does not exist in a dictionary, will now get false because Harry is not a key that belongs to any of the data that is mapped in this dictionary. All right, let's look at some other important methods that we can call on these dictionaries to carry out some other things. So let's start with the get method. So the get method allows us to be able to get a value from our dictionary using its key. Now in this case, let's say we wanted to print out the value of the phone number of Jonathan. What we could do is to say phone number dot get, and in this case it will take in the key of that specific dictionary. So let's say I wanted to access Jonathan's phone number. This will actually return our phone number. So if we went ahead and printed this will return Jonathan's phone number. And this is very similar to how we used, so let's say the same thing such as phone book, and then we accessed it by using the key Jonathan. So let's just look at also how we can update our dictionary to add more values by use of a method. So the way we can do that is by basically coming right here. So we can do something like phone book dot, and then we call the update method. So the update method basically takes in an iterable, and this iterable has to have data that is in form of a sequence. So let's use a list, and then within this list we're going to create a sequence which is going to be a simple tuple. Now this is going to contain a key, so this key is going to be, let's say, Jesus, and Jesus is going to have, let's say, a phone number of that. So if we go ahead and print our updated list, so in this case we can say print, and then we print our phone number, which is our updated dictionary. I don't know why I'm actually mixing the two, but if we print our updated phone book, we shall see that Jesus has been added to the end of our dictionary. Now this is good. Another way we can be able to remove items from our dictionary is by using pop. So we can say something like phone book dot pop, and this will basically go ahead and remove an item given a certain key. So let's say we wanted to get rid of Jackson from our dictionary, would say dot pop Jackson. So let's go ahead and print this out. So what this is going to do is to basically return the phone number of Jackson while removing Jackson from our dictionary. So if we go ahead and print our updated list right here, just want to show you this example. So if I say print and then phone book, we'll now see that Jackson is not going to be part of our updated dictionary, but this will pop Jackson similar to how we did it in list, and then return the value of the phone number for Jackson while removing them from our updated list, just like you see right there. We can also be able to use del to be able to delete a certain key or key value pair from our dictionary. Let's say I wanted to delete Jackson, but we do not want to use pop. So in this case, what we can do is to comment this out. Now let us go ahead and use the approach of using the del keyword to basically delete Jackson from our phone book. So the way we're going to do that is by coming right here and saying del, and then we shall use our phone book dictionary. Then we'll access the value of the key of Jackson. After doing that, then we're going to print our updated dictionary. So this is going to be our phone book. So if I save and run, we shall now see that our dictionary is going to have all the other key value pairs except the one for Jackson, and that's simply because we've got rid of Jackson. Now if we wanted to remove all the items within our dictionary, then we would use the clear method. So the clear method will get rid of all the key value pairs or mappings that we've created within our dictionary. So let us go ahead and do this. So I'll come right here, and all I have to do is to say phone book dot clear, and when I call this, I'm just simply going to come and print our phone book. So we now expect that this is going to return an empty dictionary. So if I pull this up and clear my terminal, to run, we shall now see that the updated value of our phone book is going to be an empty dictionary. So that will get rid of all the items or the key value pairs that we have within our phone book dictionary. Now that we've looked at how dictionaries work, let's see how we can combine lists with dictionaries to be able to carry out certain things. Now we have a simple program right here, or a simple problem that we're going to solve. So this is basically a simple task that basically is telling us to create a program that keeps record of the total sales for an entire week. And the user should enter all the data of the total sales from the keyboard. Now, I'm going to give you some seconds so that you go ahead and figure out how to do this program, and I'll be right back. Alright, so for us to achieve this, we're going to first of all create a list of all the days of the week. So I'm going to come right here and I'll create a variable. So let me make my extend well. So I'm going to first of all begin by creating a variable. I'll call this days of week. And what this is going to do is basically keep our days of the week. Now we're going to provide a Monday, and then let's actually start with Sunday as the first day of the week. So I'll just come and say that we're going to have Sunday and then Monday. So we shall have Tuesday. Oh, this is supposed to be a string, so I'm going to make this Tuesday, and then we shall have Wednesday, and then we shall go ahead and create one for Thursday, and then Friday, and then we'll have the one for Saturday, which is the last day of the week. Now that we have this, what we need to do is to first of all get input for all the cells that are for each of the days that we have in this list. So what we're going to do is to create a simple for loop. So say for day in days, and what we're going to do is to get each of the total cells for an entire day. So I'm going to create a variable called cells, and this is going to be the result of basically getting whatever we have from our input. So we have a mistake right here. They're showing us that days is not defined. So what we needed was days of the week. So I'm going to change this and make it days of week. So when I come here to our cells, since we want this to be an integer, we'll use int, and then we'll get our input and convert it to an integer. Now I'm going to separate our prompt. So I'm just going to come here and create a variable called prompt1, and this is going to be, let's say, enter cells for, so in this case we can even make it interesting. I can come right here and say that this is going to be an f string, and we can have this being enter the cells for that specific day. So when you enter here, what you're going to do is to, let me actually tidy this up so that we can have some space after the input. Now we're going to provide that prompt as the prompt one we've created at the top. So once we've been able to do that, so let's try to see what our program is going to do. So if we try to run our program, so I'm going to pull up my terminal right here. If I run Python main.py, we're now going to see that it's going to start with Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, which is good. Now what we want to do is to create a list that's going to basically keep all these records. Now keep in mind that we're going to keep the data as dictionaries. Now I'm going to create our list right here. I'm going to call this cells records, and this is going to be a simple list. Now what we're going to do is to create dictionaries, and these dictionaries are the ones that are going to keep individual cells records for a certain day. So what I'm going to do is to create a dictionary. So I'll call this cells record, and what the cells record dictionary is going to be an empty dictionary. Now we're going to start by assigning values or assigning keys and then providing those values. So I'm going to come and say cell record. Actually, that's going to be the cells record for a certain day, and I'm going to update that right here. So when I come here, I'm going to say that our cells record for, so this key in this case is going to be that day, and in this case we shall have our day being. So here what we want to do is to store our day as the day for that specific day, and then we want to also keep our cells record, and in this case what we want is to set the amount, that's the amount of money made for that specific day. So if I change this, we want to basically go ahead and store what we have as our prompt. So that's going to be our prompt. Actually, it's not going to be our prompt, but it's going to be our cells. So once you've been able to do that, let's try to append this dictionary to our cells records list. So shall say cells records dot append. This is to add it to the end of our list, and then we're going to append our cells record for that day. So let's go ahead and print out our cells record. our sales records list at the end of the week. So if we go ahead and try to run our code, so I'm going to call our python main.py. Right now we're going to be asked to enter the sales for Sunday, so I'll enter Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and now we'll see that it's going to print out this dictionary. It's actually a list that's going to contain dictionaries for all the days of the week, which is good. So let us try to modify our code so that you can be able to loop through each of the days of the week and then calculate the total sales for the entire week. Now, since we have this list of dictionaries that's created just like we printed right here, we're going to go ahead and write another for loop that's going to loop through each of the items within that specific list. So we're going to say for day, or we can actually say for cell in sales records. It's actually going to be sales records. And what we want to do is to basically go ahead and print out each of the days mapped onto its amount. So let's just say that we're going to have an individual day. So shall say sale and then day, which is the key for our day. And then we're going to go ahead and map that onto its, let's just make this US dollars. So we're just going to say sale, and then here we shall access the amount. So once we've been able to do this, then what we want to do is to also calculate the total of each of our sales. So we shall come here and create a variable called total sales, and this is going to be 0 at the start. So what we want to do is to go ahead and add our total onto this, add our sales onto this total. So in this case, I'll just come and say that our total will be updated or incremented by each of the cells we shall have within our list of cells. So we shall say total. So this is actually going to be total cells. And we shall have our cell, and then we shall add our amount. So if we go ahead and print out our total cells, so I'm just going to come and say print our total cells for the week are. So in this case, we shall have a simple program, and here let's just put our units, then the total sales. So in this case, if we go ahead and try to run, let me actually first provide our total sales. So if we try to run our code right now, let's say we had $23 made on Monday, 12 made on Tuesday, 200 made on Tuesday, Wednesday we made 300, and Thursday was a very good day, so we made 450, and then Friday we made 200, and then Saturday was really good, so we made 2000. So this will actually go ahead and compute all the total sales for this week. So this is just a basic example of how we can combine our knowledge of dictionaries so that to use them to store data. And then we are also combining them with lists so that's to be able to carry out some other operations that require us to combine both of them. At this point, we've been able to cover pretty much what we need to deal with Python. But the thing is, Python provides us ways of using code. And when we're using a file such as main.py, we can be able to define a variety of functions, dictionaries, lists, and you may want this to be used across very many files. That's where modules come in. So I spoke of modules being just Python files. These Python files can contain various valid Python data structures or Python methods or functions and so on. But when we're dealing with these modules, we then have to consider the fact that we need to access this code in very many other files. Now that's where importing comes in. So let's go ahead and create another file. So we're going to create another module right here. And let me call this main mathstuff.py. So inside mathstuff.py, I'm going to be putting a variety of functions that we're going to import in our main.py so that we can use and then be able to carry out various things. Let us begin by first of all defining the file. So I'll just say this is going to be our math functions. And when you do this, then I'm going to go ahead and define all the functions that you may need to access out of this file. The first one I'm going to get is the one for adding two numbers. So I'll just say this is a file. Actually, this is a function, and I'm going to call it add. So it's going to take in two parameters, x and y. And what it will do is to just simply return x added to y. So once you've been able to do this, then the next thing we can do is to maybe document how this function works. So I'm going to create a docstring. So I have this autodoc generator. It's going to generate for me this. If you haven't watched this, please go back and look at documenting functions. So what I have here is I can be able to define the summary. So let's say this adds two integers. So we shall just say add two integers. Let me correct this. And then x and y. So this function basically adds two integers, x and y. Now for these arguments, we now need to define the type. So the type of this, let's say all of these are going to be integers. They're also going to have a description. So let me just say these two are going to be integers. Now the return type of this should of course be an integer. So I'm just going to say int. And then we're going to have the description. So this will be the total or the sum of the two numbers. So just say sum of x and y. So let's go ahead and create another function. I'm going to create another function. Let me first close my side panel. Now we're going to call the next function our function for subtracting. So I'll say def subtract, and this will take in x as well as y, and then it will also return the difference between these two. So I'll say x minus y. Now I'm going to do the same thing and document it by using my autodoc generator right here. So I'll say this is just simply going to return the difference between x and y. So I'll say difference between x and y. So let me remove this. So once we've done that, still we shall have types as integers. I'll have to change this. So I'll just come right here. And all I have to do is to say that this will be integers. Now, when you come back this side, we're going to change the description. So I'll just say this will also be integers. And the return type will also be an integer. So I'll just come and change this to int. And then we shall have a description as the difference between x and y. So basically, that's what we have right now. Now, given these functions, let's also go ahead and define one for product. So I'll just have three functions for this example. I'll copy this and then paste it right here. And then instead of subtract, in this case, I'm just going to simply call this multiply. So multiply will also take in x and y, but it will return the product. So in this case, it's going to be the product of x and y. So the result of multiplying the two numbers. So once we've been able to do this, so in this case, I'll also say that this will actually return our product of x and y. And we shall also modify the operation. So in this case, it will be x multiplied by y. So given such functions, we can also create a variable such as, let's say, pi. And pi, let's say our pi is going to be rounded off to 3.14. So once we have such these variables, we can even have lists, dictionaries, and other things. We can even have tuples inside here. But the point is, we can be able to use these outside this file when you want to carry out calculations. So when you go to our main.py, we're going to use the import keyword to import and be able to use all the functions and variables that we defined in another module. So the first thing I'm going to do is to call our import keyword. And in this case, I'll have to refer to the name of the file or the module in which those functions are. And I'm just going to come right here and say import math stuff. And in here, we can be able to access the various methods, the various functions, classes. It can be anything. And in this case, what I have to do is to maybe, if let's say we wanted to have two numbers, num1 and num2, let's say num1 is 12 and num2 is going to be 13. If we wanted to calculate these, to calculate different things for these values, then all we have to do is to maybe create a variable. So I'm going to create a variable called total, and this will be the sum of these two numbers. But remember, we defined a function, so in this case, if we refer to our math stuff module, we can be able to use dot, and then we'll get access to everything we define inside that specific file or that specific module. In this case, we want to add the two numbers, so in this case, we shall have x, we shall have y. We also see that Visual Studio Code is helping us to be able to return the documentation of that specific function, which is beautiful. So in here, we can provide that number 1, and also we can provide that number 2. So once we've been able to do this, let's go ahead and print this out. So if I say print, and I'll use an F string, so I'll say our total is going to be our total, just like we have right here. So if I go ahead and run our code, you shall see that our total right now is going to be 25. So by just doing this, we can be able to import and use functions or variables that come from another file. If we wanted to find out the product, we'll do the same thing. So I'm going to just come right here, and all I have to do is to change this. So let's say I'm going to update, so I'll have to highlight the total and then press Ctrl D. So this will look for all occurrences of the word total. So I'll replace this with our product. And in this case, let's say we wanted to call our multiply function. So I'll say math.multiply, and then this will multiply number 1 and number 2. So if we print again, we'll now see that our product is going to be 156. So just doing this, we can be able to access all the functions, all the methods, all the variables that we have inside of this file. Another thing is we can be able to update this. So instead of having to reference our module, we can instead use the from keyword, and then we define that we want to import some statements or let's say variables and functions from a certain module. So the way we do that is by updating this. So I'll say from our module, which is math stuff. So in this case, we have math stuff. You can have any module called with whatever name you may want. So in this case, we can have math stuff, and then we can say import, and then we import the variable, the function, or anything we want, or any object we want to import. So in this case, we can import our add, and then we can import our multiply. We can also import our pi, just like we defined it right there. We can also import our, let's say, subtract function, and that will be it. So we can be able to use each of these functions by just updating our code. So what I'm going to do is to get rid of every time we reference our module. So by us doing that, if I run our code, we'll now see that it's going to calculate just like we have here. So this is what they call an absolute import, and it is called that because we can have to reference the specific name of the module and then access the different objects or variables or functions within that module. Another way we can be able to do that is by using relative imports. And let's go ahead and look at how we do that. Before we move to relative imports, let us get to understand absolute imports in detail. So I'm going to give you an example that will help you to understand absolute imports before we actually move on to the relative imports. If we check our code right now, all we have is a simple module called mathstuff.py that contains all the functions that do whatever we want to do that requires us to do some math. And then we go ahead and import all those functions and variables from the module itself, which is mathstuff.py. But then we can go ahead and also modify this and create a package that contains all these functions in their respective modules. So let us go ahead and try that. So Python provides for us a way of keeping all related modules within one single folder called a package. So within this package, we can be able to access each of those functions or methods or classes or variables from their respective modules. So let us try to split our module right here and make it a Python package. So we're going to start by creating a folder, and we're going to call this folder math stuff. And after creating this and calling it math stuff, we're now going to create separate modules to house all these functions. Now I'm going to start by creating our file called add.py. add.py, and then within our add.py we're going to add our function. So I'm going to cut our add function right here. Let me make my mic a little bit. So when I go to our add, I'll just simply paste in our add function right here, and then I'll go to math stuff still, and I'll cut the subtract function. Sorry for that. So I'll go ahead and create a new file, and I'll call it subtract. So this will be our subtract.py. I'll paste in our function right here, and then I'll do the same thing for multiplication. So I'll say multiply, and then here we're going to basically provide our multiply function. So I'll also go ahead and access it from our mathstuff.py, and then I'll provide it right here. So let us say we wanted to also remove this pi variable right here, or this constant. We can create a module for it. So I'll say pi.py. So that's actually similar to pi, which we shall talk about. So what I'm going to do is to paste that here, and now I will save and then get rid of our mathstuff.py module. So I'll move it to the recycle bin, and after doing that, we now have one folder that contains all the respective functions that we may need to use in our main.py. But for us to be able to access those functions, then we'll have to modify our inputs in some way. So for us to label this folder a Python package, it needs to have a special file called the init.py file. So the init.py file is what will allow us to be able to import all the functions within their respective modules in our main.py. So we're going to go to our folder right here, and we're going to create a new file. So this is going to be a danda. So danda in Python is basically a short form of saying double underscore. So we're going to use two underscores, and in this case shall say init and then underscore dot py. So once we've been able to do this, then we can access each of these modules within this simple folder math stuff. So I'm going to go within our main.py. So that means we also have to change the way we imported our functions. I'll go ahead and say from math stuff. In this case, we can say .add. Then we're going to import our add function. Shall do the same thing for multiplication. So shall say math stuff. So this is going to be from math stuff dot multiply. We are going to import our multiply function, and then shall do the same thing from math stuff dot, let's say, subtract. We can now import our subtract function, just like you see right here. If we wanted to access pi, then we'll do the same thing. We'll say from math stuff dot py. Then we are going to import our py constant. Sorry for this. So that is how we can be able to access all the functions from our respective modules. So the reason as to why these are called absolute inputs is because we refer to the absolute path of those specific files or those specific variables that you want. If you wanted to access add, you would then refer to the specific package in which add is, then you access the module, and then you'll be able to access the function. Now that's why they are called absolute. You of course know where you want to go, so you of course refer to that specific path in that order until you access the variable or the method or the function that you may need. Now that we've looked at absolute inputs, let us look at relative inputs. So relative inputs are those you do when you basically want to access a certain variable or a function, but you want to use the position of the file in which you are to determine where those are. Now let us look at a simple example. What we've been doing, we've been accessing all the functions that we've been using for our code in this module, but we've been accessing them from the parent packages they are and the module where they are exactly. But if we want to do relative inputs, that means we'll have to depend on the position of that file for us to be able to get these from. Now let me show you a simple example. So within our master folder here, we have all the modules that contain our functions and variables, the ones that we use right here. But let's say we're to create another module within this package that is going to help us make use of all the functions and variables that we have in these modules. So let us go ahead and create one. What I'm going to do is to come to the package and create a new file. So I'll call this sample.py. So sample.py is going to contain a calculation that is going to involve addition, subtraction, as well as multiplication. So what we're going to do is to depend on the position of our sample.py file to import all the variables and all the functions that we shall need. Now let us start by importing the add function. So we shall say from, so instead of saying from mathstuff.add, import add, we are now going to change this to something like from dot, which is the current folder. So this will basically give us access to all the modules within our current folder. And we want to access the add module. Now from within the add module, we're going to go ahead and import our add function. And we're going to do the same thing for our subtraction. So I'll say from dot subtract. So this is basically going to be from our subtract module. We're going to go ahead and import our subtract function. We're going to also import our multiply function from dot multiply. So whenever we say dot, we're actually meaning the current folder or the current directory or package in which all these modules we are importing from are. So we're now going to go ahead and import our multiply function. Now I'm going to create a simple function right here, and this is going to basically calculate everything. So I'll just call this calculate all, and this is going to take in x and y. So it's basically going to return the sum, the difference, as well as the product of the two numbers. So what we're going to do in this case is to simply write them. So our total or our sum, let me actually just call it our sum. So I'll say that our sum is going to be equal to a call to our add, and this will take in our x and y arguments. And then we're going to have the same thing for our difference. So I'll say the difference is going to be equal to a call to our subtract function. So we shall say subtract, and in this case we shall provide x and y as the arguments. Now let's do the same thing for multiply. So if we go ahead and say multiply, actually this is going to be our product, sorry. So I'll say product, and this product is going to be a call to our multiply function. Now this will take in x and y as our arguments. So once we have that, then we're simply going to return this as return values. So this function is going to basically take in all these parameters right here, which are x and y, and then it will return three values. So in this case, we can say return, and then we can return our sum, and then we shall separate them by commas. In this case, actually our sum is going to be underscore, so I'll add that. Then we shall also include our product as well as our difference. So this is actually going to be in this order of sum, product, as well as difference. So once we've been able to do that, then let's go ahead and make use of our function within our main.py. Now in our main.py right here, what we can do is to use an absolute import to get access to the function that we've written. So to do that, I'll just simply come right here and say from math stuff. Sorry for this, so it's going to be from math stuff dot. In this case, we created a file called sample. We are now going to go ahead and import our, what did we call it? We called it calculate all. So I'll say calculate all. So right after doing that, now what I'm going to do is to simply remove this. And in this case, what we're going to do is to say that we're going to have our sample returning our sum, our product, as well as our difference. Now that's the same way we're going to unpack all these returned values. So I'll say that shall access our sum, and that is going to be equal to our sum, and then comma, then shall access our product, then comma, then shall access our difference. Yeah, it's actually our difference. So I'll say that we're going to access our difference. So once we've been able to access that, then we're going to go ahead and basically call our function of calculate all. So I'm going to come and say calculate all, and I'll give this value. So I'm going to clear my left pane or left panel, and in here I'll give values for x. So I'll start with our num1, and the value for y in this case will be our value for num2. So in case we give our num2, then we shall be able to do that. So if we come, I'll use f string, so I'll say print, and then I'll say that our f string is going to have our total. In this case, our total is going to be the value of our sum. So I'll just basically provide it as our sum right here. And in this case, we shall also do the same thing by printing our product. So I'll say print. So let me actually write print, and I'll use an f string to basically print our product. So it's actually going to be an f string, and in here we're going to have our product, and our product is going to be the value of our product. Right after doing that, let's do the same thing for our difference. We shall say print, and when we provide our difference, so I'll come and say that our difference, and in this case our difference is going to be our difference. So once we've been able to do that, then I'm simply going to go ahead and run our file, and then we shall see the outputs that this is going to give us. So when I pull up our terminal right here, I'm going to go ahead and run Python main.py, and when we run this, we shall now see that it's going to return the sum, the product, as well as the difference of the numbers that we provided right here. So basically that's how relative imports work. When using a relative import, all you do is to depend on the current location of your file or the folder. While using an absolute import, you're depending on the knowledge of where your file is, as well as what you want to import is within that current directory. If you have been observant, you've noticed that there's a folder here called the Dunder PyCache folder. So the purpose of this folder is beyond the scope of this video, but all I can say is it is a cache folder that helps our Python code run faster. Python gives us a wide library of tools and packages to use. So some of them are useful in your project, some of them you'll not be using them that much. But all I have to say is there is a standard library that Python provides, and that's why it can be used for very many things. Now let me give you a very simple example. Now, in case we want to use dates, we can use the datetime module that comes within Python that allows us to do different dates and different times calculations. So what I have to do is to import that. So I'll go ahead and say from datetime import datetime. And once we've been able to do that, now we can be able to understand where a certain class or a certain function comes from. So we can be able to hover over the function and then press Ctrl, so that will basically make it clickable. And when we click on it, we'll basically look at where it is in our environment. So this is basically the path to my Python installation, and this is datetime.py, which is basically the datetime module where we can access this class called datetime. Now do not mind about classes. We're going to look at classes later on in the video, which is not actually so late, but we're going to look at them. So basically that's how functions and Python works. If we were to check within our lib, you can have very many folders in here, and all these folders basically stand for some code that Python provides for us that's ready to use within our standard library. Python allows us to basically do a lot of things. Now, those things can also include playing around with different files, adding to them, and so on. So let us look at a simple example that will show us how to manipulate files using Python. So what I'm going to do is to create a module right here, or a file. So I'll call this write.py. And what this is going to be is a file in which we're going to write our Python code to allow us to open and write to a file. So in here, we're going to first of all create a variable or an object. So we shall look at objects later. And I'm going to call this our file variable. So this is going to be a call to a special function that Python provides for us that allows us to be able to carry out various operations on files, and that is the open function. So using the open function, we can be able to open a file and then be able to write to it, modify it, and carry out different things. So in here, what I'm going to do is to open this file and say that we're going to call this, let's say, main.text. So once we've been able to do that, we're now going to provide an open text mode. Now by default, the open text mode that we have is the one for R, which is for reading, but there are various other text modes that Python provides for us. So if we're to provide our quotes in here, Visual Studio Code is going to suggest all these modes and combination of modes that will allow us to carry out various operations on our file. But in this case, what we want to do is to go ahead and just write to the file. So we're going to say that we're now going to open our file for writing, and that's the W mode. So once we've opened our file with the W mode, then we can be able to add some text onto this file. So what I'm going to come and do in this case is to say file, and once you have our file object, we can basically go ahead and call certain commands or certain methods. Now in this case, what we're going to call is the write function, and what this is going to do is to basically add the string into our file. So let us just add a simple string in here. So what I'm going to do is to come right here and say that we're going to have the string of hello, and then in this case I'm going to add programmer. Feel free to basically add your name or whatever you want to add. Then we shall also create another write. So I'll say file.write, and in this case what I'll do is to basically write another string. So I'll say that thanks for learning Python with me. So in this case, after writing that, then we're going to close the file by calling the close method. So I'll just say file.close. And once you've been able to do this, let's try to run our file and then see what is going to be output. So what I'll do is to come in our terminal and say python write.py. So this will go ahead and create a simple file in here. So this is going to be our main.txt file. And when you open this file, we're now going to see that we basically have hello programmer, thanks for learning Python with me. So what this is basically simple text that we've added with Python, just like you see right in here. If you wanted to modify this so that you can be able to add all this text but leaving new lines, then what I'll do is to basically add a new line character or an escape sequence in here. And what it will do is to basically modify our file so that we have our text being on a new line. So basically that's a very simple way in which we can be able to add to a file using Python. At this point, what we've done is to basically go ahead and simply write to our file, but we can also add lines by using the writeLines method or the writeLines function. So when you create our file object right here, instead of just writing to it, whatever we shall be adding to the file will be writing just to concatenate onto what we have within the file. But what if we wanted to add lines to the file? So that's where the writeLines function comes in. So what I'm going to do is to come right here and say file. I'm actually calling it fly, but it's file. So when you have our file object, we can call .writeLines. And in here, what we have to do is to provide an iterable. Now, an iterable can be a string, it can be basically files.items, it can also be our list, and by providing that, then we shall be able to create multiple lines of strings and be able to concatenate them onto our main.txt file. I'm going to create a simple list right here, and in here we are going to basically call this applications. So these are basically some of the applications of Python. Now in here we can add, let's say, machine learning, and then we can also add, let's say, web development. So web development, and we can also add, let's say, our automation, and we can also add our, so we have machine learning, web development, and let's say data science. So once we have this, then we can basically provide that iterable here. We can say that we're going to provide applications. So if we come and say applications, and then we run our file. So I'm just going to clear my terminal and run our file. when you go back to our main.txt, we shall see that every line we've added onto this file has been actually added onto our file. So it also concatenates onto what we have within the file. If we wanted to make this a little bit neater, so what we'll do is to modify this and then maybe add a line. So in here, we can basically come and do the same thing we've done here. So we can do something like, here are some things you can do. So let's say here are some of the things you can do. So what I'm going to do is to say here are some of the things you can do, and then after doing that, we shall basically write our lines just like you see here, but we're going to add a new line character so that we go to the next line. So in here, I'll basically format it by basically adding this new line character, and then we shall add this, shall add just an arrow to make it look a little bit neat. So I'm going to copy this, and then I'll basically add it to whatever string that we have within our applications list, just like we have here. So I'll do the same thing for automation and the same thing for data science, just like we see over here. So I'm going to save, and when I save, I'll pull up the terminal, and when you run python write.py, when you go to our main.txt, we shall now see, hello programmer, thanks for learning Python with me. Here are some of the things you can do, and basically provides all of the applications, some of the applications of Python. And yeah, that's basically how we add multiple strings into our file. Now that we've basically created this file and added some text onto it, we can now go ahead and read this file and then display some of the text that's within this file. So for us to be able to do that, we are going to create a module right here, and we're going to call this our read.py. So within read.py, we are now going to open our file, but in this case, what we're going to do is to go ahead and basically read it in a mode that is the one for reading. So what we did in the previous example is to basically open up our file, but we opened it up with a text mode of write. So in this case, what we need to do is the same thing, but we need to do it with the read open text mode. So I'll just copy our file variable right here, and then basically paste it here, and then we shall also go ahead and close our file after doing whatever we want. So once we've done that, then I'm going to change our text mode to read, and after we've done this, then the next thing is going to be for us to be able to print out each of the lines that exist within our text file, the one we have as main.txt. So for us to do that, I'm going to use a for loop. So I'm going to say for line in, so in this case you can say file, then we're going to call a certain method which is going to be the .read lines. So once we basically have that, we can go ahead and print out each line that exists within our text file. So I'll just come and say print, and then I'll basically say that this is going to print our line. And after doing this, if we pull up our terminal right here and we run our file, so I'm basically going to come here and say python main.py. It's actually not main.py, but it's going to be read.py. We can now see that it's going to go ahead and print out every line that we shall have within our file. Now this is basically reading. There are very many other operations we can do with files, and I'm going to leave a chart at the top of the screen so that you guys can be able to see and experiment with all these and find out what these different open text modes do. If you've made it this far into the video, then you probably landed into some errors. In this section, we're going to look at how we can get those errors, and then how we can handle those errors and be able to customize those errors in a way that will be useful to us. So let us go ahead and look at some of the basic errors that we may face when coding in the Python programming language. So the first type of error we may face is going to be the name error. So a name error occurs when we have a variable that is not defined, but we're trying to actually use that. So let us go ahead and try to look at some simple examples that may make us to land into such errors. So I'm going to come right here, and the first thing I'll do is to print x. So now you may ask yourself, why am I doing this? What I'm trying to do is to land into an error. So I'll pull up my terminal right here, and when I run, we shall now see that name x is not defined. So each error has a type in Python, and the type of this error right here is going to be the name error. And it always has a description of what happened that we did not do well, or something that Python did not accept. And it also contains what is called a traceback. So the traceback allows us to point to that specific part of our code that has the error. And in this case, we can see that our traceback points us to the main.py file on the line 1, where we actually are right here. So basically, that's very important, and that is one of the beauties of the Python programming language. It allows you to see the error and where it occurred so that you can be able to fix it and do other things. So let us go ahead and fix this. So I'm going to define the variable called x. So I'll say x equals to, let's say, 100. And when I save, in this case, when we pull up our terminal, we are now going to see that our program is going to run and it will not have any errors inside it. So let us look at a certain other error that you may face when using the Python programming language. So the other error we may face is what we call the type error. A type error is one in which you can basically carry out operations in two variables or two or more variables that are of different data types. So let us go ahead and try to look at that. Now I'm going to remove what we have here. And in this case, we're going to just write a simple program. I'm trying to keep this simple, but you may understand it. So let's say we're adding two numbers, or we're trying to calculate across numbers. So I'm going to get these numbers from the input. So I'll say num1 equals to input. And then here we shall say enter number 1, or let's say enter first number. So after asking for the first number, then in this case, we are going to ask for the second number. Now I'm going to come to the second line, and here we shall ask for the second number. So we shall say second number, and then we shall also change this to second number. But if you're to notice, all these are going to be strings. So if you want to convert to integers, then we'll have to use int and then input. Then we shall be able to prompt for the second number. So if I save, right now what we're going to do is to simply come right here and say print. And here we can basically say num1 plus num2. So once we've been able to do that, if I pull up my terminal and run our file, we'll get our first number as, let's say, 12, and we get our second number as 13. So if we run this, we can now see that we're getting a type error. And this type error is telling us that can only concatenate string to string. And in this case, what we did was to get an integer and then concatenate it to a string. So basically, this operation can only be carried out on strings and strings, or integers with integers. So let's go ahead and fix this by converting our first number into an integer. So what I'm going to do is to come right here and I'll say int. And when I say int, so this will have input, and then we shall enter the first number. So if I save, if we go ahead and run our program right now, we can now go ahead and say 12 and then 13, and this will basically give us 25. Now that we've been able to look at some of these errors, let us look at how we can be able to throw some of these errors in case our programs have received incorrect input, or when users are trying to actually do something that you may not want them to do when interacting with our program. So that's where the raise keyword comes in. So the raise keyword is the way that Python provides for us to throw an error in case something unexpected is done within our program. So we have a simple function right here that basically takes in two arguments, number 1 and number 2. So we are trying to even call that function for various types or various variables or values of x, or number 1 and number 2. So in here we have, first of all, we have two strings and we have also integers. So if we call and run our function, we now see that we have Sally Jonathan for the first one, and then we have number 1 for the second one. Now in this case, if we wanted to modify our program so that we throw actual errors given wrong data or given different data types, just like you see right here. For the first one, we're getting a concatenation, and for the second one, we're getting an addition, of which we want to add 2 numbers. Now, this is where we may want to raise some errors. So what we're going to do is to go ahead and start by raising an error given data that is not of type int. So what we're going to do is to write an if statement in here, and that's what we're going to use to check if any of these numbers is not an integer. So I'm going to write an if statement in here and say if num1, or we can actually use the type function to check for the type. So we can say if type of num1 is not integer. So the way we may want to do that is by negating. So we may use the exclamation mark, and then we may use the equal sign to negate the comparison. So what we may want to do is to check if the type is not an integer, and since we want to do this for both the first number and the second number, now we're going to use an OR operator to do that. So after doing that, then we shall say if type of our num2, so in this case our num2 is not equal to, so in this case I'll say int. And what we may want to do is to raise an error and may say that we want this to be integer. So I'll say raise, and in this case we want to raise a type error, so I'll say type error. And in this case we may provide a message, so our message is going to be numbers should be integers. So once you've been able to do that, I'm going to pull up our terminal and run our code. So when you run our code, we're now going to see that the concatenation won't happen because now we expect that our numbers should be integers. So let's go ahead and comment this out. So if I comment this out and run our code, I'll also have to comment out this print statement. So if we run our code again, we shall now see that the second call to our function is the one that's actually running. But we may notice that we are having negative integers also being provided in here. So I'm going to write an elif statement that's going to prevent us from providing arguments that are of negative integers. So the way we're going to do that is by coming in here, and what I have to do is to basically go ahead and copy what we have here, or I'm actually just going to rewrite it. So let me rewrite it by saying elif. And in this case, what I have to do is to check if our num1 is less than 0. That means that if it's negative, and we want to also do the same thing for our num2, so I'll use an OR operator. And in this case, I'll say if num, this is actually going to be num2. If num2 is less than 0, then we are going to raise a value error. So in this case, we want to raise a value error. So this is one we may raise in case we have inappropriate arguments for our function. So in this case, we may want to raise a value error, and what we're going to do is to say numbers should not be negative. So once we've been able to do this, I'm going to go ahead, and so what I have to do is to catch our else, or be able to run whatever is going to run in case any of these errors has not been raised. So I'll write an else statement down here. So I'll say else, and what I have to do is to go ahead and basically return our num1 plus our num2. So when you try to run our code in this case, we shall now see that we are going to get numbers should not be negative. Now what I'm going to do is to change this. So if I change this to 12 and 13, which are both positive integers, we are now going to run our code, and now we shall get our sum of 25. So this is one of the ways in which you can raise errors by using the raise keyword, and then basically providing the best error, or the best type of error that's needed for a specific case. Alright, so now that we've looked at errors and how we can raise errors, let us see how we can handle these errors in case we have scenarios in which this may occur within our program. Now Python provides for us the try statement that basically allows us to go ahead and run code even in the presence of these errors. So let us go ahead and look at this. So one thing I'm going to try to do is to try to execute some code that I expect is going to give me some errors, and then we shall use the try statement to allow us to be able to go ahead and run our code even in the presence of those errors. So let's go ahead and try to open up a file that does not exist. So if I open my folder here, we don't have any file or any text file to open, but what I'll do is to go ahead and try to open a text file and then be able to read some of the lines that exist within that file. So I'm going to create a variable called file, and this is going to be a call to our open function. So this will take in the name of the file, so I'll say file.txt and then the mode in which you want to read the file. So once I've been able to do that, I'll want to basically go ahead and print out all the lines that exist within our file. So I'll say file dot read lines. So in this case, if I say file dot read lines and then I go ahead and print our line, so what this for loop is going to do is to loop through each of the lines that exist within our file and then go ahead and return those files or print those files on an individual new line. So I'll go ahead and run this code. So let me clear my terminal right here. So if I run, we shall now see that we are going to get an error, which is file not found error, and then we shall have no such file or directory file.txt. So this is very frustrating, as we may have a program that is going to depend on the opening of the file, but also we may want to continue executing our code even in the absence of our file. Now that's where a try comes in handy. So what I'm going to do is to go ahead and pull down my terminal, and we shall write our code that we expect to give us errors within a try block. So what I'm going to do is to go ahead and wrap our file opening in a try block. So I'm just going to come here and say try, and what I'll do is to indent this so that it appears to be inside our try block. And every try block basically goes in hand with an except block that allows us to throw the error or raise the error that we need to throw in case our file is not found. So what I'm going to do in this case is to come right here, and what I have to do is to say except, and one thing I'm going to do here is to basically go ahead and print file not found. So this is in case our file is not found. So I'm going to save, and when you try to run our code again, so when you run our code, we shall now see that our file not found is going to be printed, and then we shall have our name error saying file is not defined. So basically what we have here is we are printing this, but we're printing it outside the scope of our try block. So I'm going to comment this out for now. So if we try to run this without the for loop, what we expect is to get file not found. So basically what will happen is we'll try to execute that code that is to have errors, and then except will try to throw the errors. So we basically provide a very good way in which you can throw the errors that we may get out of our try block. So right now what we get is the print statement of file not found. But what if we are sure about the error that can happen in case our file is not found? So you can be able to do that with the except block right here. We can go ahead and accept the specific exception or error that we may have within our code. So in this case, what we're going to do is to accept file not found error. So this is actually file not found error. And in this case, what you want to do is to use the as keyword to basically specify a name of that specific error, and then maybe go ahead and print it out. So what I'll do is to say as, and in this case I'm just going to create a name for it. So I'll say file not found error, And in this case, what we shall do is to go ahead and print our file not found error in combination with the word file not found. So if we go ahead and print or run our code, what you shall get is the error, no such file or directory, file.txt, as well as our words, file not found, which is amazing. So what will happen is when you try to execute that code that has to have errors, it passes the try block. If it has errors, it will go to the except block. But what if the file actually existed and we needed to do something with that file? So that's where the else keyword comes in. So even with the try except block, we have an else statement that basically will execute our code given the fact that we do not have any errors present. So in this case, if we say else, so this is where I may want to go ahead and actually print out all the lines that exist within our file. So I'm going to come right here and I'll cut this code. I'll paste it just below here. And what I'll do is to uncomment it and then I'll fix the indentation. So let me go ahead and fix the indentation. And once we've done this, now let's try to do that. So if we try to run our code right now, we shall see that the file is not found, but let's say we created the file and added some text. So if we go ahead right here and create the file, so I'll call this file.txt, and in this case what I'm going to add here is hello, and then I'll say please like this video. So in this case, this is the text that we've added into our file. So if we go to main.py and then try to run our code right here, we're now going to see that our code is now going to be executed, and this is basically because we do not have any errors. So what we have is our file being found, and we actually have our error not being thrown at us. So this will actually go ahead and execute all the code that will exist within our else statement. Another important statement that we may want to add here is going to be finally. So finally is one that's going to run even when we have passed or failed in these conditions. So given an error or not, finally will execute that code that we want to continue executing even in the presence or the absence of these errors. So I'm just going to come right here and say finally. So I'll say finally, and in this case we shall print done. So let's say done, and then we can say yay. So if we do that, if we go ahead and print or run our program, so if we run our code, in this case done will be printed, and then we shall also have the files or the lines that exist within our file being printed. But let's say we removed our file right here. If we try to run our code once again, we shall now see that our error will be thrown at us, just like you see right here. So let me close this. Our error will be thrown just like you see right here. And then whatever code that we shall have after the errors existing shall also be executed. Now that we've looked at this example, let us try to look at another very simple example. So I'm going to go ahead and try to write a function that will basically go ahead and actually divide two numbers or be able to carry out division and return the quotient. So I'm going to say this is going to be def divide numbers. So this is going to take in numbers which are going to be num1 and let's say num2. So when you have those numbers, what you may want to do is to simply go ahead and return the quotient. So we shall return num1 divided by num2. So in this case, what we may want to do is to basically try to run this code, divide the numbers, and then return the result. So we may want to adjust or modify this so that we may want to use a try statement to allow us to catch whatever errors that we may get within this function. Let me begin by calling this function. So if we go here and call this function, so what we may do is to call this divide nums with, let's say, values such as 12 and let's say 3, and then you may try to divide let's say 12 and 0, and then you may try to divide, let's say, Jonathan, and then we may want to divide by a number 23. So if we try to basically call this file, we shall now see that we have a 0 division error. So all these errors are some of the errors that we can actually go ahead and get rid of or catch when we have a try statement. So what I'm going to do is to modify this. So this is where the errors are actually coming from. If you're to check, we have return. This is where the traceback is showing us that the error is originating from. So if we go ahead and try to wrap this in a try block, so I'm going to modify our statement to say try. So we shall try the division of two numbers. So in this case, what we're going to do is to say that our quotient, or our variable called quotient, is going to be equal to, so we shall say num1, and in this case shall divide by num2. So once we've been able to do that, we want to go ahead and accept all the errors that we may get in here. So the first error we're going to accept is going to be the 0 division error, just like you see right here. So what we're going to do in here is to just say accept, and in this case we're going to accept our 0 division error. So I'll just basically, since this is inbuilt within Python, I'll accept our 0 division error as, and I'll call this our 0 division error. So once I've been able to do this, I'll want to go ahead and basically write a simple print function. So I'll just come and say print, and in this case what I'll try to do here is to go ahead and say 0 division error. And what I have to do is to say that number. So in this case, I may say something like numbers should not contain, should actually not be 0. So let's just say numbers should not be 0. Or let's actually make it more clear by saying none of the, so we can say none of the numbers should be 0. That can be clearer. So when you try to do that, now we also want to basically execute our code in case we have got our quotient. So in this case, I'll use our else statement. And in this case, what we may want to do is to say print, or basically return our quotient. So let's actually go ahead and, I'm not going to actually use the quotient, but let's just go ahead and print our quotient. So I'll print, I'll use an f string and then say quotient, and in this case our quotient is going to be let's say our quotient. So whatever we write in here in our try block will actually be accessible via our else block. That's if our code has run without errors. And then finally, so I may want to clean this up by saying finally, and in here I may go ahead and say exiting. So let's just say exiting. So once we have this, then let's go ahead and run it. So if I pull up my terminal right here and run, we shall now see that our error is going to be division by 0. None of the numbers should be 0. And then we shall also have another error basically telling us that we have unsupported operands for type division with string and int. So let us go ahead and also accept that error. So the way we're going to do that is by coming and adding another except block right here. So I'm going to say except. So this is going to be except, and in this case we shall accept a type error. So in this case our type error is going to be as type error, so I'll call it TE. So in this case we shall say print our type error, and let's actually make this more interesting. So I'll basically come in here and use an f string. So I'll say f string, and then I'll wrap this in quotes. So we may want to print our 0 division error, and then we want to go ahead and also modify this so that after printing our 0 division error, we now also provide what our custom message is going to be. Then another thing we may want to do here is the same thing. So what I'm going to do is to come and say f, and then I'll provide our quotes. So in here, I'll provide our error, which is going to be a type error. And in this case, I may want to say that please, I'll need to provide some message. So I'll say please provide a valid integer. Please provide valid integers. So in this case, once we've been able to do this, now let's try to run our program once again. So if I pull up my terminal and run our program, we shall now see that our program will even execute given the errors that we have in our code, which is amazing. So we shall first of all run our code, and we shall get a valid division, just like you see right here. So this is going to return 4. And then for the second one, we are going to basically get a 0 division error, which is going to be having this error of none of the numbers should be 0. And then the third one, we shall go ahead and try to throw this error of unsupported operand types for division, string and int. And then we shall also see our provide valid integers, and the program will still exit. So this is basically to show you that when we use a try except block, we are saving ourselves from our program crashing even in the presence of these errors. The beauty with using the try except block is you can be able to execute your program even in the presence of errors, just like you see right here. If you have made it this far, then I would like to congratulate you. Let us look at classes. Classes are the way that Python provides for us to be able to create data of certain types. Now, these types are not those that come within the Python programming language, but these can allow us to experiment and maybe be able to express things that exist in the real world. If you're dealing with Python, you can be able to create a variable and then give it a value, which is a string. You can create a number by giving it a value that is of either an integer or a float or any other number type. But you may face instances in which you may want to create a variable, and this variable should be an object of a certain type that is in the real world. Now, that's what brings us to classes. So a class simply gives us a way of defining this type that is not actually built within Python. Classes can help us to create objects, just like we're going to see right here. So what I'm going to do is to create our first simple class. And this class is going to allow us to create multiple objects of that type that we're going to create. So each time we're creating a class, we're creating a type in Python, and then we create objects of that specific type. Now let us begin by creating a simple class. I'm going to come here and I say class, and inside here we're going to say that we're going to create a class of simple. So this is going to be our simple class. And this simple class is basically created by using our class keyword, and then we go ahead and provide the name of that specific class. Now this name is what is going to allow us to create objects, and it's also going to define the type of each of the objects that we shall create from this class. We can also have a pair of parentheses right here, and this is going to define the arguments, or it's going to define the classes which we shall inherit, just like we're going to see in the coming videos. But let's go ahead and write a simple pass statement. Now this is one we write when we do not have to write any other code beyond in a block of code, just like you see right here. Now let's go ahead and find out the type of this simple class that we've created. So if I go ahead and say print and then say type, in this case what we want to do is to find out the type of the class we are just from creating. So if I pull up and say type of simple, I'll pull up my terminal right here and then run python main.py. In this case, we're now going to see that every class that you create in Python belongs to the type of type. So every time you see a class, it is very sensible for you to think that this class is basically a type and it defines a certain type. Now, this is one of the interesting things in Python. Each and everything we've been doing when we're creating a function, a class, a statement. We're basically using a bunch of objects even without us knowing. So let us go ahead and assign some attributes to this class. Now in here, instead of having a pass statement, I can go ahead and add some attributes. So a class has attributes, and all these attributes can be present within each of the instances that we create. At this point, we haven't created any instance. So let us begin by creating simple, and then in here we can have a greeting, and inside this greeting we can have hello. So we can access this attribute on this class by basically coming and saying print, and in this case what we can do is to print our class, and then we call simple. Then in this case you can say dot, and we can have our attribute just like you see here thanks to the Vscode Python extension. So if we say simple.greeting, we shall now be in position to access our hello greeting just like you see right here. The reason that's why we create classes is to be able to create objects that will help us to manipulate our code in a certain way. Now in this case, we've created our simple class, the one that we have right here. We've accessed some attributes on this class, just like we see our greeting here. But we haven't yet created an object out of this class. Now creating an object out of a class is as simple as coming down right here. And all we have to do is to say simple. And this simple object is going to be of the type of our simple class that we've created up there. So we're going to come and say that this is going to be simple, and this is the syntax we use for creating an object. You basically write the class name as well as a pair of parentheses. Now whatever goes in here are some of the attributes that belong to that specific object, and we're going to look at how we assign them later on. But for now, let us try to find out the type of our simple object. So the way I'm going to do that is by coming down here and then saying print, and I'll use our type function to basically go ahead and help us to find the type of our simple object. So when I go ahead and save, I'll pull up our terminal, and then here we shall realize that this belongs to the class of simple, just like we see right here. So after finding out that this object is going to be of type the class we created up here, we can now go ahead and access some of the attributes, such as the greeting attribute we have right now. So if we go ahead and do that, we shall print, and in this case we shall call our object, which is our simple object, and then when we say dot, then we shall access the greeting attribute, just like the one you see right here. So after us doing that, we're going to go ahead and save, and when you try to run this, in this case we shall see that we shall access the attribute of the class via the object that we created from our class. So this basically shows us that classes are blueprints of how we can create objects. These classes can have multiple attributes, and these attributes can also be shared with the objects that we create out of those classes, just like we see for our simple class. Using classes, we can express things that exist in the real world that Python cannot provide for us. So Python can give us all these data types such as lists, strings, dictionaries, but when we want to express a thing such as a person, then we'll have to create a class that will allow us to define the person and every behavior that a person may have. So in this case, we're going to create a simple class of a person, and using that class, we are going to create some people, and we are going to enjoy this. So let's go ahead and do that. So the first thing we shall have to do is to create a class of person. So I'm going to create a class, and I'm going to call this our person class. So I'll say class person. So this is going to be our person class. And in this class, we are going to define some attributes. Now I'm going to begin by basically providing the species of that specific person. This specific person is going to be a human. So I'll just come and say that our species is going to be human. And once we've done that, we can now go ahead and create some person objects. So in here, we can go ahead and First of all, I'll print the class attribute. So I'll say person dot, and in this case, I'll access our species attribute. So we all know that this is going to return human. If I run, we shall see that this is going to return our human. But if we created an attribute of this specific person class, then this will show us that we can now create all objects, and all these objects will be people or persons. Now in this case, we shall create our person number 1, and our person number 1 is going to be our first object of the type person. And once we've been able to create it, we can as well as go ahead and first of all find out the type of our person that we've created. So we shall say person 1. So if we do that, then what we shall have is basically we shall be shown that the person is going to be of the class person. And if we try to access the species of that person, we can do something like print, and then inside here we shall say person1 dot species, meaning that we can access the class attribute of species via our person object. So this is very interesting. Now what if we wanted to actually go ahead and basically carry out some actions or define some of the actions that a person can do in real life? Now that's where methods come in. So methods are functions that we may define inside the class to help us to describe the behaviors that would belong to a certain class. Now we've looked at some of these. We're looking at data structures such as lists and dictionaries, where we call something like list.append or list.pop to be able to carry out something on a certain object. Now in this case, we're going to write a method that's going to allow our person to speak. Now what I'm going to do is to go ahead and define that method within our person class. So I'll do that by saying def, and in this case we shall basically provide our talk method. Now this is going to be a method that we shall call on our object. Now let's just say this is going to say hello. So when the person talks, we shall basically go ahead and just print hello. If we want to call this on a specific object, what we need to do is to go ahead and specify that this is going to be an instance method. So the way we're going to do that is by providing what we call the self argument to our method. So self in this case is going to refer to an instance, which is actually going to be an instance or an object that we create from the person class in this case. But let's say if we had a class of list, then when we're referring to a method that the list is going to have, self will refer to that specific object of the list class. Now in this case, what we're going to do is to call this on our person1 object. So we have to say self, and then this will actually say hello, and what I'm going to do is to make this an f string. So that means that we shall have to access our species. Let's say hello, I am a, and in this case we shall access our species. So I'm just going to come here and say self. So from self we can actually go ahead and access our attribute of species, and after doing this we shall save. So when you come right here and call this method onto our person1 object, we shall see that it's going to print this out. So if we go ahead and say print and say person1 dot, in this case shall say call talk. So this is actually going to go ahead and call the talk method. So in this case it's not a function, it's a method that you call onto our object. So if we save and go ahead and print, we shall now see that this is now going to say hello, I am a human, and then none. Now the reason that's why this is returning none is the fact that is because we are not using a return statement. So each time we do not use a return statement, Python will go ahead and print none if we are calling our person.talk. So that's basically how we shall create our person object, and then also create a method that we call onto our object. At this point, we've created our class that we've created objects from. So we've created only one object, which is our person1 object. We've gone ahead to find out the type of that object and also find out that we can access all the class attributes from this object. We've also defined one method that basically returns a greeting from our person. Now in this case, we are going to define a method that's going to allow us to attach multiple attributes onto this specific person object. So let's go ahead and do that. Now Python provides for us the init or initializer method. In other programming languages, they call it the constructor. And this initializer method has the ability to help us to attach multiple attributes onto a simple object, just like we have right here. So let's go ahead and attach attributes to this person object. So what we shall do is to go right here, and in here I'm going to go within our class and define that initializer method. So initializer or init is going to be a magic method. So the magic method is one that has the dunder syntax. Remember, dunder stands for underscore, double underscore. Now in this case, if we say dunder, and in this case we say init, we shall come here, and then the first parameter we shall have to pass in here is going to be the object itself from which we shall be attaching those attributes. Now that's where the self word is going to come in. Now self is just a conventional word that we use to refer to a certain object. In this case, we want to provide other attributes such as the name, so we can provide our name, and then we can also provide our age. So once we've been able to do that, we need to attach these attributes that we've specified in here to our object. Now the way we do that inside our initializer method is by basically going ahead and calling our object and then referring to that object. So in this case, we shall attach those attributes dynamically. So we shall say self.name, which means we are creating a field or an attribute of name onto our object. And in this case, we're going to assign that a value that we shall provide when creating that specific object. We're also going to do the same thing for our age. So we shall say self.age, and in this case, our age is going to be equal to our age. So once we've been able to do that, when we are creating our variable or our person object, that means that we shall have to go ahead and basically print out these or provide these attributes when creating the object. So if we go ahead and try to run our code, we shall now see that we're going to get a type error. And what this type error is telling us that we are missing two required positional arguments, which are the name as well as the age. Now these have to be provided each time we are creating an object. So whenever we have an initializer method and we have all these attributes being attached onto our object, we need to go ahead and provide or basically provide them when we are creating our object. So if we go ahead and say person1 is a person object, then we'll have to come and specify our attributes. So I'll start with a name. And in this case, I'll say Sally, and then we shall also provide our age, and in this case, we shall provide our age, which is 24. So when you go ahead and run our code, in this case, we shall see that it's going to run successfully. And this is because we have been able to attach attributes to our object. Now let us go ahead and modify our talk method. So inside our talk method, we're now going to go ahead and define this method so that it actually returns the name of the specific human. So instead of saying hello, I am a human, we want to say something like hello, I am, then self.name. And in this case, what we're going to do is to say hello, I am self.name. And in this case, we can basically say and I am a, so in this case, we shall call self.species. So when we go ahead and run our code, we shall now see that this is going to print hello, I am Sally, and I am a human, meaning that it's going to make use of both the class attribute or species that we have here, as well as the instance attribute, which is our name that we provide when creating that specific object. Let us look at another example that will help us to understand how classes and objects work. So the first thing we're going to do is to create a class. So we're going to create a class of a rectangle. And using this class, we shall be able to define the properties of a rectangle, as well as calculate things such as the perimeter of the rectangle, as well as the area of that specific rectangle. Now to begin, the first thing we're going to do is to create our class. And this class is going to be the class of our rectangle. So just going to come and say rectangle. And this class is one that's going to allow us to basically define the objects that we shall create, or the different rectangles that we shall create. So the first thing we shall have to do is to define what specific objects or what specific attributes the objects that we shall create from this class are going to have. Now in this case, that we shall do by using our init or our initializer method. So this is going to take in each object which we shall refer to as self. And after doing that, then the next thing we're going to do is to provide all the attributes that this specific rectangle will have, or all rectangle objects that will have. In this case, we're going to refer to the length as well as the width of all these rectangles. When we have this, then the next thing is going to be for us to attach properties or attributes onto these objects. Now we shall do that by using self dot, and in this case we shall attach a length by providing the length that we shall provide in our argument. So in this case it's going to be self dot length, which is going to be equal to the length that we give inside our init method. Then we are going to do the same thing for the width. So we shall say self dot width, and this is going to be equal to our width. Now that we've done that, if we want to calculate the area of this specific rectangle, then we'll have to define a method that's going to take in each of these attributes and then be able to calculate the area. So what we're going to do is to come right here and we define a method. So this is going to be area. But as long as we have our self that's going to refer to our object, we shall be able to access all these attributes. So if we say self, which means this is going to be called on an object, then in here we can calculate our area. So what we're going to do is to say area, and our area for our rectangle is going to be self dot length multiplied by the width, which is going to be accessed with self dot width. So once we've been able to do this, then the next thing is going to be for us to return this area. So in this case, we're going to come and say return, and we shall return our area just like we see right here. Then the next thing we shall want to do is to calculate our perimeter. So in this case, what we're going to do is to define our method called the perimeter. So it's going to be perimeter. So the perimeter is just the total distance around a certain figure. In this case, we are calculating a total distance around an individual rectangle object. So that means we shall have to count or calculate 2 times the length and then add it to 2 times the width. That will be the total distance around our rectangle. So in this case, if we go ahead and say self, so we shall be able to access our perimeter. So we shall call this our perimeter. And in this case, what this perimeter is going to provide us is going to be 2. Let me actually just use parentheses. So we shall say 2 times self dot length added to 2 times the size of our width. So in this case, we shall have 2 multiplied by the size of our width. So we shall have self dot width. And once we've been able to do that, then in this case, what we can do is to come and create a rectangle as well as call other methods on this specific rectangle. Now what we're going to come and do in this case is to basically create our first rectangle. So we shall call this rectangle 1, and it's going to be an object of type rectangle. Sorry for this. So once we've been able to do this, then we shall be required to provide our length. So I'll say length, and our length in this case is going to be, let's say, 12. And then our width in this case, let's say, is going to be, so we shall provide our width, and our width is going to be, let's say, 6. So we can now go ahead and print all these. So what we can do is to say print, and we can use f strings to basically return some very nice formatted string that's going to give us the area. So we can say the area of the rectangle. So say the area of the rectangle with width. So in this case we can say with width, and then we can access the width. So we can access the width from the object itself by saying from rect1 dot, and then we can access the width that, and then let's go to the new line. So I'll go to the new line and say and. So in this case we can say and our length. So here we can say and length of, let's say it's going to be rect1 dot length is, then we can actually get the area. So in this case we shall call rect1 dot our area. So once we call this, then we shall be able to get access to our area. So if we have this, then we can go ahead and basically call this, and basically to print out our area. So if I save, I'll come right here and run python main.py. So we shall see that this is going to be the area of a rectangle with width 6 and length that is going to be 72. So the way we can correct this is by basically going in here. So I eliminate most of the space that we had. So if we go ahead and save, so let me actually correct this to make it more clear. So if we go ahead and run our code, you shall see the area of a rectangle with length 12 and width 6 is going to be 72. You can also add units if you feel like, but I'm just trying to show you that we can call these methods onto our objects. So add a little space here, and let's do the same thing for our perimeter. So I'll just come right here and I'll copy the same print statement. So in here I'll say the perimeter of the rectangle. So in this case we're going to say the perimeter of the rectangle with width that and length that is. So instead of calling area, in this case we're going to call our perimeter method, and when we save, we are going to run our code. So we shall have the perimeter being none, and this is because, let's actually check our perimeter function. We have not actually returned our perimeter. So if we go ahead and fix this by returning our perimeter, so we shall return our perim. So when you go ahead and run our function, we shall see that it's going to return our simple perimeter. Now this is a very simple example that we can create real-world objects from using our classes, just like we see right here. One of the ways we can use object-oriented programming is by defining the relationship between objects. So most times you may have a base class or a parent class, and in that class can have children classes. And let's look at a very simple example right here. So I'm going to enlarge this a little bit, and let me pull my left panel. So once we are here, the first thing we're going to do is to first of all describe a simple relationship. Now I'm going to write a simple docstring right here. And in this docstring, we're going to establish a very simple relationship between objects. So let's say we were creating a class to define computer. So this is going to be our computer class. And once you have our computer class, we can now define all types of computers. So let's say a laptop can be a computer, and we can also have a tablet being a computer. And we can also have a MacBook being a computer. We can also have an iPhone or a smartphone. Let's actually just say a smartphone being a computer. So let me eliminate the MacBook because the MacBook is a laptop. And then iPads and all that stuff can be tablets. So let's go ahead and try to define classes that are going to define the behaviors of these real-world objects. So to start, what I'm going to do is to simply come and create a class that's going to be our base class or our parent class, from which all these are going to derive their attributes as well as properties. So I'm going to come and say that we're going to have our class. So this is going to be our computer class. Let me enlarge this. So we shall have our computer class, and this computer class is the one that's going to be our base class. So it's not going to inherit from anything. So let me just say we're going to pass this. And the class we're going to create, the second class we're going to create, is the laptop class. So this laptop class can be a class called laptop, and this can inherit from or get all the properties from the computer class. So we shall pass it right here. And then we shall also go ahead and create a class for our next type, which is going to be our tablet. So in this case, I'll say tablet, and this will be our computer. So it's also going to inherit from our computer class. We shall pass this for now. Now let's go ahead and create the last class, which is going to be our smartphone class. So smartphones are also computers, and we shall go ahead and add all these properties onto our computer. So we shall say smartphone, and our smartphone in this case is going to be a computer, just like you see right here. So if we say pass, right now if we create all these objects, they are going to have the same properties as the computer class that we have right here. So if we go ahead and first of all create our computer object, so we shall say computer, and in this case, let's say our computer is going to be an object of our type of computer. And once we've created this, then let's go ahead and create a laptop. So in this case, I'll create a laptop such as a MacBook, and this is going to have to be a laptop computer. So I'll also go ahead and define our tablet. So let's say we're going to have an iPad, and an iPad is going to be a tablet. So in this case, we shall call this a tablet. And we shall also have our smartphone. Now let's say our iPhone, in this case, is going to be our smartphone. So we're just going to add our smartphone. So I'm going to try to define some of the properties, and then we shall call them on all the objects that we've created, just to prove that all the attributes on the parent class are going to be good and are going to be shared across all objects that inherit from the parent class. So if you're to notice, we have our parent class, or our parent class being our computer, and all these classes that inherit from it are what we refer to as child classes. Now they all inherit the properties as well as the attributes of the computer class. Now in here, we can go ahead and start providing some attributes within our computer. Now in this case, let's go ahead and define some methods. Now I'm going to come and define our first method that will be called on every computer object, and this is going to be the boot method. So the boot method is going to allow us to basically go ahead and boot our computer or start our computer. So I'm going to come and say boot and then self. So what I'll do is to just print, and in this case we can come and say print, and then we shall say start or starting. So in this case, what we want to do is to start the computer. Now what I'm going to do is to try to access some of the properties that Python allows us to access on a certain class, and this is by use of dunder attributes or dunder names. Now in this case, when we say attribute, in this case the attribute we want to access is self dot. If we want to access the class name, then we'll have to access the class itself by using the dunder class, and then we say dot, then dunder name, and that will give us access to the class name. Now in this case, we are going to say starting, and then here we shall say that we're going to start the computer. So if we save and we call that method on all these objects we've created, so I'll say computer dot boot, and I'll do the same thing for MacBook dot. So this is going to be MacBook dot boot, and then we shall also call the same for the iPad. So I'll say iPad dot boot, And then lastly, I'll say iPhone dot boot. So once I've been able to do this, let me correct the spelling of our iPhone. So once I've been able to do this, I'll pull up my terminal. And then when I run this, we're now going to see that this is going to show us that we're starting our computer, we're starting our laptop, we're starting our tablet, and we are also starting our smartphone. So if we go right inside our computer method and we try to update this, so let me add 3 dots just like you see right here. If we come right here and try to run, we shall now see that it's going to start all of the classes or all objects created from the different classes that we may have in this case. So the most appropriate way we can represent this is by basically referring to each of these objects being an object of the parent class, which is our computer class right here. We can also say a laptop is a computer, a tablet is a computer, a smartphone is a computer, as long as they all inherit from the parent class, which is called our computer class. So let us add some properties onto our parent class. So I'm going to create an initializer method and I'm going to add it within our parent class. Now I'm going to come here and all I have to do is to say def. And in this case, let's say we want to go ahead and add our initializer method. Now I'm going to basically provide self, and this is actually going to be a return type of none, but I'm not going to talk about typings for now. So one thing I'll do is to provide a different attribute. So what I want to do is to provide the memory or the memory in GB for the device, and then I'll say storage, and then I'll also put in the operating system of that device. So these are the properties that we're going to attach to every computer that we shall have. And to attach them, so we're going to do this by basically referring to the objects of our computers. Then we offer a field or provide a field, and this field, in this case, the first field is going to be our memory. So when you have our memory, then we're going to have the value as the memory we provide to it when creating the object. Then we're going to provide, so this is going to be self.memory, and then we shall have self.storage. So this is going to be the second field, and it will be the storage that we provide to that specific object. Then we shall also provide our OS. So we're going to say self.os, and that is going to be equal to the OS that we provide to the object when creating it. So let's go ahead and modify our object so that we can have actual values for the memory, the storage, as well as the OS. So to do that, I'm going to come within our code, and while we create a computer object, we are now going to start by providing our memory in GB. So let's see, this is going to have memory of, let's say, 32 GB. And then we shall have storage. So in this case, let's say storage. And storage in this case is going to be, let's say, 128 GB. Then we can also have an OS. So in this case, let's say our OS is going to be Windows. So I'll just come and say that this is going to be a Windows machine. And then we shall also go to our laptop. Now, since this laptop is a computer object, we shall expect to get the same attributes just like we have for a computer. So I'm just going to copy what we have here, and then I'll paste it right here. But I'm going to change a few things. For example, MacBooks have Mac OS. So in this case, I'll say Mac OS. And then for our tablets, so in this case, we shall basically say memory. And in this case, let's say our memory is going to be 4 GB. Our storage is going to be, let's say, 64 GB. And then we shall have our OS being equal to, so for an iPad, we expect to have iOS. So in this case, I'll just provide iOS. Then after that, then I'll just come right here, and all I have to do is to provide memory for our iPhone. So let's say our iPhone has 3 GB, and our storage, in this case, our storage is having, let's say, 64 GB, and then we can have an OS. So in this case, we also expect to have iOS on our iPhone. So I'll provide iOS. So once we've been able to do this, now our program will run smoothly for every time we call our boot function or our boot method on these devices. So if we go ahead and pull up our terminal, if we run, we shall now see that it's running successfully. So let's say we wanted to associate each of our computers with a certain processor. Now in this case, what we're going to do is to create a class that's going to represent these processors, and then each of our computers will have a certain processor. Now the way I'm going to do that is by coming right here, and all I have to do is to create a class. I'm going to call this our processor class. Now this processor class is going to basically contain nothing for now. But in our computer, we're going to associate each computer with a processor type. So I'm just going to come and say that each of our computers is going to have a processor, and then this is going to be our processor type, which is going to be equal to the processor, just like we see right here. Now I'm going to create different types of processors right here, and then we can go ahead and basically get all these processor types and attach them to certain computers, just like we're going to see. Now let's begin by creating our Intel processor. So I'll just say this is going to be our Intel, and I'll just pass it for now. And then I'm going to do the same thing by coming here and saying that we're going to have our M1 processor. So I'll just say M1, so I'll say pass. And then we can also create our M2 processor, and this will also be a processor. Now let's also create our, so I'm just going to also create our AMD processor, and we shall pass for now. So once we've been able to do this, then the next thing we're going to do is to attach each of the computers that we've created, or the computer types that we've created, to an appropriate processor type. Now just like we've done here, each of our computers right here is going to inherit the processor type from the processor. Now let's update our boot function so that we can show the processor that's running on the computer at boot time. So for us to do that, I'm going to come within our boot function, still on our class of computer. All I have to do is to say print. I'll print an F string. Now in this case, I'll say running. And in this case, what I'll say is self.processor type. And I'll basically add 3 commands. So once we've been able to do this, I'll go ahead and save. And when you pull up our terminal, we're now going to see that our code is going to run, and we shall have running, then class main.processor. And that is going to just basically print out the processors of these specific computers. But to update this so that we get the processor name, we'll have to say self.processor, then dot, and in this case we want to access the name, the data name attribute of that processor. Now what I'm going to do is to go ahead and run our code, and in this case we shall see that running processor, running processor, running processor. And this is it because we haven't yet specified the different types of processors that the different computers are running. So for us to be able to do that, I'm going to go ahead and update each of our computer classes that we've created here so that we can have a specific processor running. Now for our laptops, I'm going to update this and provide us processor type. So I'm just going to come here and provide us processor type attribute. And in this, instead of us just having a simple processor, I'm going to update this so that every laptop we create has an Intel processor. Now, I'm going to come and say that we shall have an Intel processor, and then I'll go ahead and update our tablets to have, let's say, an M1 processor. So I'll just say that each tablet is going to have an M1 processor. This is a very simple example, and I know this is not the most accurate information, but feel free to create some information just like you may please. I'm just giving a very basic example. So in here, we can go ahead and also do the same thing. So let's say our processor for the smartphone is going to be our M2, just like you see right here. So when you go ahead and run our code, guess what is going to happen? So I'll pull up my terminal, run our code, and now we shall see that different processors are being printed for each of our devices. So just basically that's what we wanted. So this can show you that we can establish relationships between objects. We can also be able to basically establish relationships between classes as well as other classes by basically having classes being part of other classes, just like we've seen right here. Now let us modify our program so that for each of our computers, we actually have a name that's specific to that specific computer. So what we can do is to go ahead and update our code or attach methods that are basically specific to the specific devices that we want. Now in this case, what we're going to do is to override the init method of our parent class. So for us to be able to do that, we're going to go ahead and maybe define names for specific laptops or tablets or computers that we may have just right here. So let us go ahead and do that. So I'm going to start with our tablet class. So within our tablet class, all we have right now is just basically the processor type. But what if we wanted to add a name for the specific tablet or override a certain method so that we can be able to basically provide some more information about the device? So what I'm going to do is to define our init method. And this init method is going to be very similar to the init method that we have for our parent class. So in here, I'm going to say that we're going to have self, and then we shall have our attributes such as memory. Then we shall have our storage, and then we're also going to have our OS. And after we provided these attributes, we are now going to add an attribute that is not part of what we have within our parent class. Now in here, what I'm going to do is to go ahead and then I'll provide another attribute called the name. So this name attribute is going to be one that is specific to our class of tablet. And what I'm going to do now is to call all the properties or initialize all the properties and attributes of our parent class. So the way we do that is by using the super function that Python provides for us to refer to the parent class. So I'm going to come right here, and all I have to do is to say super, and I want to call the init method of our parent class. So in this case, I'll say .init. It's going to be init. And what I have to do is to provide ourselves. So actually, this is a call to the function. So I have to call super.init, and then I'll provide all the methods just like we have them in our parent class right here. So I'll come right here, and all I have to say is init. And in this case, we shall have to provide our memory. Then we shall have to provide our storage. Then we shall have to provide our OS. And once we've been able to do that, now I'm going to come right here and then initialize our name attribute or our name argument. So what I'll do is to say self.name, and this is going to be equal to our name. So that means that every time we create a tablet, we're supposed to add a name to that specific tablet. So if you run our code, we shall now realize that the tablet is missing one argument, which is the name. Now in this case, what I'm going to do is to go ahead and basically update our code where we create our iPad and then add a name attribute. So I'm going to come right here, and all I have to do is to go and say comma, and in this case shall say name, and our name in this case is going to be our iPad. So when I save, I'm going to go ahead and pull up our code, and in this case our code will run successfully. So let us try to modify one of our methods that we have on our parent class so that we customize the way it returns the booting message. So I'm going to go within our tablet class right here, and what I'll do is to basically go ahead and update our boot function. So I'll say def boot. So right here, just like you see, we have return super.boot, meaning that's going to be the same boot function for our parent class, which is our computer class. But if we want to update this, then what I'll do is to say print. So what I want to do in this case is to say print, and then I'll basically write an F string. So in here, we're going to say running, and in this case, we shall say self dot let's say processor. So this is going to be the processor type. Remember, this is going to be a class, so we need to access its name. So I'll say dot name, and right after doing this, then I'll say on, and then in this case I'll say self dot name. So once I've been able to do this, I'm going to save, and what I'll have to do is to go ahead and basically run our code. So if we run our code, we're now going to see that we are now running M1 on iPad. So let me go ahead and try to modify this so that it makes more sense. So if we say running M1 processor on iPad, so if we go ahead and run our code, we shall now see running M1 processor on iPad. Let's go ahead and do the same thing for all the other children classes. Now I'm going to go ahead and basically copy what we have in here, and then I'll provide it within our smartphone. So I'll go ahead and add it to our smartphone class. And what I'll do is to go ahead and provide it for our smartphone class. We shall have to edit some few things here. So the first thing we're going to edit within our code right here is going to be our name. This is actually the same thing, but we're going to edit the way we create the smartphone object. So I'm going to add a name. So in here, I can create a name. And in this case, we can go ahead and add our name. And the name of this will be our iPhone. So I'll just come and say iPhone and then save. So when you run our code, we shall now see that running M2 processor on iPhone, which is kind of cool. So let us go ahead and do the same thing for our laptop. Now I'm going to come right here, and what I have to do is to change our laptop class so that it also has the same methods. Now I'm going to come right here and paste in the methods. So in here, what we shall do is to update this so that we can also have our laptop having a name. Now when we come on our MacBook, I'm going to update this so that we have the name attribute. So our name is going to be equal to, let's say, MacBook, and then Pro. So when we save, we can now go ahead and run, and this is going to basically run and show us the processors that will be running on the specific devices, just like you see right here. At this point, we've basically got introduced to inheritance and how it allows children classes to obtain all methods and properties of their parent classes. Now let's go ahead and look at some important methods that can be helpful when dealing with these classes. So the first one we're going to look at is the isinstance class. So in the isinstance method or function is what is going to allow us to check if an object is an instance of a certain class. Now in this case, what we're going to do is to try to find out if a certain object is an instance of a certain class. Now in this case, let's try to use the isinstance, and we provide our object. So our object is going to be, let's say, our iPhone. So then we also have to provide our class. So in this case, we have to provide our class, which is going to be our, so in this case, this is belonging to the smartphone class. So let's actually try to access our smartphone class. So if we save, we can now return true. That's if this iPhone object belongs to the smartphone class, or return false. That's if it does not belong to the class. So what I'm going to do is to run our code. So when we run our code, we shall now see true, meaning that this can show us that this iPhone is actually a smartphone. So this will return true. But let's say we wanted to actually find out that our iPad belongs to smartphone. So we tried iPad. In this case, we expect false because it doesn't really belong to the iPad, but it belongs to our tablet class. Now that is one of the methods that we can use. There is also the subclass method that allows us to find out if a certain class is a child of a certain other class. Now let us try to do that. So what I'm going to do is to print, and in this case I'll say is subclass, and what this does is to take in the class. So in this case, let's say we are going to take in our smartphone class, and then we provide our second class, which is going to be our parent class. So in this case, our class is going to be, let's say, our computer class. So if we go ahead and run, We're now going to say that this is going to return true because this smartphone or smartphones are actually computers. That's what we can talk. That's the English we can talk in that case. So right now we can check the instance and issubclass methods, and this can be helpful when we are dealing with things such as if statements. If you have made it to this point in the video, I'd like to appreciate you for what you've done. Python is a programming language that's being used out there, and there's a lot of wonderful, interesting things you can do with your knowledge of Python. This is not so much that you've learned from Python, but there's a lot more you can learn. And when you learn such, you can be able to do some of the things I'm going to be talking about in this concluding part. So one of those things is data science. Data science is when data is analyzed so that insights can be made that can help to grow a business. Professionals all over the world are using Python to calculate and carry out statistics that will enable businesses to grow. Python is also widely used to come up with data visualizations that can draw insights about how businesses are performing and can give key insights on what businesses can do in order to grow. Another field that Python is being used in is web development. Using frameworks such as Django or Flask, professionals are building web application backends using these technologies. Using Python, these professionals can be able to manage things such as URL routing, security, as well as to be able to manage databases. You can also use Python to automate and script a lot of things. Professionals all over the world are using Python to test web applications and test features that are built onto software. You can also incorporate Python in your real-world work. You can use Python to monitor the stock market. You can use Python to rename very many large files, move files around your computer, and so on. So I hope you've learned a lot from this video, and I hope you get to use your knowledge of Python for the good of our planet. I'd like to thank you for watching this video, and without further ado, let me request you to like this video, share it, and help everyone to learn this awesome programming language. I remain Jonathan, and thank you for watching my Python course. Bye.